So I'm going to be talking today about something we've been calling Cilium Datapath plugins. So first, I'm going to give a little bit of background about the motivation behind this, kind of the goals of Datapath plugins. And then I'm going to jump into what plugins actually look like and how they work. And then at the end, I got a proof of concept, like a demo of an actual Datapath plugin, simple Datapath plugin that we developed, kind of illustrate the mechanism. Right. So first off, like, what's the point of plugins to Datapath? So kind of a smaller goal here is possibly allowing some better modularity in the control or in the data plane. So moving feature-specific code into their own plugin, kind of reducing the monolith that is the BPF code. But I think for our purposes, and probably more importantly, is allowing for easier third-party extension and more useful third-party extension points in the Datapath itself. So there's something like this today called custom calls, where you have, particularly at the end of the BPF programs that are attached to the interfaces and such, you can insert your own program to get executed. But it's limited in scope, and for a lot of use cases, a lot of extension use cases, it's not very useful, or you can't really use it to achieve your goals without literally patching the code. So that's kind of where Datapath plugins comes in. I think of it as custom calls plus, kind of like more extension points, more hook points, and then some better mechanism for actually loading in these plugins and assembling plugins that you want to enable. So with this POC, kind of wanted to start defining some various hook points within the Cilium Datapath that would be useful to have. Spec out what a plugin actually looks like, and how you'd implement a plugin as a developer. Provide the plumbing inside of the Datapath loader that compiles, loads, and injects plugins into the Cilium Datapath, and then provide the configuration for enabling and disabling plugins as well. So now we're going to get into the actual structure of plugins, how they work, what they look like. So very high level, how we have it right now is a plugin has its own directory inside of the BPF code. So BPF/plugin/myplugin, or myplugin is the name of the plugin I'm developing. We've considered that in the future, far off in the future, it could be possible to develop out-of-tree plugins, things that you distribute its own container image or something, download from somewhere else, have some other configuration like CRDs around that, but we're not going that far for this POC. So plugins sit on top of the kind of abstraction layer. We have well-defined hook points and possibly some stable APIs that plugins can rely on between Cilium releases. And for sorry, the slide went through. I was just reading. Oh, yeah, go ahead. Okay. Sorry if I'm moving fast. Let me know. Okay. And of course, all that on top of the core Datapath code, which is BGP BGP host, etc. So just trying to point out that we know that the details can change here. We don't want to restrict what we can do in BGP and BGP host and all these places too much by introducing plugins. So we kind of have this layer that plugins rely on. So what does the plugin actually look like? So I mentioned before, we have our own directory with our plugin code, and right now there's like a hooks directory with our actual code that implements hook points within the Datapath. So we have various compilation units inside of hooks, corresponding basically to the existing BPF code, like BPF LXC and BPF host. So LXC.c would be where hooks for BPF LXC are implemented, host for BPF host, etc. You can also have state that's local to your plugin, all contained within that directory. And you can also take advantage of endpoint configuration and other configuration that would also be available to BGP LXC. So if you want to customize behavior based on your LXC ID or anything else, you can do that in your plugin as well. So yeah, before I jump into the specifics of how hook points are actually implemented, I'm gonna touch on like some places we're thinking about adding hook points and kind of why. So we don't really want to. So we have obviously our own use cases where we think this will be useful, but we don't necessarily want to just sprinkle hook points anywhere and everywhere where it doesn't make sense to do so. So we're trying to find some kind of generic places or places that are unlikely to change or break or induce undue maintenance burden as we go forward. But we think there's some fundamental phases or constraints already in the Datapath, but where there's kind of an ordering required between doing certain things where it does make sense and would be kind of a natural extension point as is. So this is my very high level diagram of what like a container ingress order looks like, right? So first, when a packet comes in, you need to figure out what protocol it is, like IPv4, IPv6, and from there you're going to do contract lookup, and then you're going to do some policy enforcement. So in a lot of our internal use cases, we find that putting some code either before contract, after contract, but before policy enforcement is a useful tool to have. And on the egress side, we have some kind of similar hook points that we were imagining. So before service resolution, pre-contract, pre-policy enforcement. And this picture gets a little different if you're using socket LB, right? You're not using purback LB, but those are kind of some details we'd have to work through. So as we developed this POC, we kind of were considering a few different extension mechanisms. First, and probably the most simple one, is just compile a program and attach it somewhere on the TC or TCX hook point, right? And that's kind of simple to manage because we just have a bunch of programs that are called in order. But for a lot of use cases we had in mind, it just isn't flexible enough. You can't really express what you want to do without putting logic into the middle of the Cilium data path. The next thing we considered was combining BPF to BPF function calls with tail calls, which is a nice mechanism because you can really, it's really flexible in where you can insert hook points. You don't have to change the function structure much at all to have an arbitrary or call out to some arbitrary programs that you've compiled. But when we tried this with Cilium, we found very quickly that it imposes a 256 byte stack limit, which makes it kind of infeasible for pretty much any place where we wanted to extend. So we gave up on that and went to just this last thing, which is kind of what we use in this POC, which is just inserting tail calls between an existing boundary. So I think I mentioned before, before we do contract lookup or before we do policy enforcement. So it's a little more flexible than the alternative one, but it's got more maintenance costs because if we have a place in the Cilium code path where we want to introduce a hook point, but it's not between two programs that already have a tail call between them, then we have to break it apart, and that has its own headaches. So, but this is what we ended up settling on for this.
Joe, you seem like you had a hint you were about to raise.
Yeah. I'm trying to figure out what is a good time to sort of approach some things and bring ideas versus kind of get the whole picture and then discuss. So we can always come back and
sure. I mean, I think I have some time at the end for questions and discussions.
Hopefully, the discussion is the point, right? it's not this is the slide.
I'm gonna run away as soon as I can. Okay, so
this is why we said 2 slides, but
2 slides is limit.
Well, that's the general idea.
They're all just
discussion.
Yeah.
But we'll
Okay, well, we'll try to get to the. So using one example, two kind of pre-contract V4 as an example of a hook point. So this is kind of an interesting example because we have basically depending on your routing mode, you can have 2 different code paths that get executed, right? If you're using endpoint routes, so to the container, tail calls to tail IPv4 to endpoint. If you're not using that, you have this handle policy thing. So we were kind of just trying to decide whether or not we wanted to have hook points be one-to-one, mapped to the actual code structure, or have this kind of abstraction where a plugin doesn't have to worry too much about the configuration you choose or your exact routing mode. You'd have these kind of abstract points like before this abstract thing happens, and we'd make sure that depending, any routing mode you choose, that happens, the plugin works. So in this POC, I've kind of opted for this approach where we try to make the plugin work regardless of your configuration, or at least try to make some configuration work. So the way we've implemented this is each hook point gets its own program array map. We insert from various plugins the same hook program into that array. So you can have element 0 here would maybe be from plugin 1, element 1 would be from plugin 2. And then we have some plumbing we do where we take an existing tail call point, and then we redirect to this chain that's stored in this program array, and then that redirects back to the original target of that tail call.
So let's say like crossing, because you have to find the right program for the right endpoint after, like at the end of this, right? So you have to somehow, when you do the jump off into this separate prog array,
you simulate a stack, I think, is the general idea.
Sorry, what's the question?
The return address.
Yeah. Right. Yeah. No, we have some state that we maintain in like a per CPU array. Yeah. And then just to clarify, so this is generated per endpoint. So we have it's similar to BGP LXC, how it's generated per endpoint using template.
Mm-hmm.
We compile, and I'm actually skipping ahead. We compile the LXC.c file from each plugin into a template, and that gets generated per endpoint in a similar way.
So effectively, the prog array on the left there is you've got in for any endpoint on the node, as well as the existing.
So this is per
plugin as well.
Per plugin. So the actual array is actually per hook point per endpoint. Some things I mentioned before. All right. So I just explained all that. Just explaining how we do
the diagrams are very helpful.
Right. So I skipped out a little bit, but yeah, we build and load the plugins in a similar way that the BGP LXC program is loaded, for at least with the LXC stuff. So because say we had two plugins, plugin 1 and plugin 2, they each implement some hook points inside of an LXC.c file. Those are compiled into a template, and then when we reload the data path for a pod, we would fetch those, do the map renames and variable substitutions, and then we look at the programs inside those, and then kind of sort them into the various maps for the various hook points. And I do have a demo of this actually working. So, let's see.
Is this for the presentation?
Sorry, this is the end of the presentation.
No, sorry. I'm just saying. Okay, we just switch to the screen share. This is where usually the recording potential. Anyways,
I did not record anything.
Yeah.
I gotta figure this out.
Exactly.
Didn't think this through. Gotta join this.
It should be fine.
Thanks.
When they do the pixel demos, they have the phone right off to the side.
Oh yeah, it's like you don't want to chance it. Well, you see the code. Done.
Right. There you go. Voila.
Joe's here.
Yeah. So this is like a very simple example. So I have hopefully everybody can see that.
Control plus.
Control plus.
Yeah.
Excellent.
There you go.
Yeah. All right. That's easy. So I've got two plugins, plugin 1 and plugin 2. They each implement both of these endpoints, or sorry, both of these hook points for the LXC hooks. basically just printing out the LXC ID and then a counter, which is incremented each time something happens, which is defined in this .h file as a map. And then we have this host file, which has this other hook point called from net.dev IPv4, which again, we're just incrementing a counter to show that we have some state associated with this plugin, and then printing it out. Plugin 2, pretty similar. We have similar hook points where we're printing out plugin 2 instead of plugin 1, just to show that we have two things running.
Plugins.yaml.
That is not used in this.
Oh, okay.
Actually.
Right.
And this is where I need to switch my window. There we go. So here's the system in action. You can see the stuff happening. All of those things are printing out. So plugin 1, plugin 2, printing out their things. Counters incrementing. We have host hook points as well.
Is a plugin like an implementation of an interface where you have to satisfy all the functions or anything like that, or if they're omitted, they don't do it?
It's you pick and choose what you need to implement.
Okay,
for
so
your plugin.
okay,
You wouldn't have to implement.
you wouldn't have to do like a no-op.
No, it just because it just looks at it's by name, so it just looks at what you've implemented and loads that in. And then we have it's pretty simple in the ordering right now. Like it'll just if plugin 1 is configured to load before plugin 2, it just all the hook points that are shared for plugin 1 get inserted first, and then plugin 2 stuff gets inserted. So there's not too much customization of the ordering per hook point.
Yeah, it's like one of those things that you can add like an infinite amount of complexity and like how to wire it up. But you probably just want to start with the basic thing. Just
Yeah, like I've got many trains of thought, but like one of them like is like taking a step back. Like, what are we doing? We're writing C programs, right? And you want to share some code or something like that. You write libraries,
yes,
and then you want to write an application like something that actually does stuff. You take a bunch of libraries, you plug them together, and voila, you have something that kind of works, right? And had kind of debates over the years, I guess, about like what do BPF libraries look like? And can we get to a point where you have a standard C experience where you GCC, compile, okay, and then link these things together, and then like, okay, yeah, you do have a loader component, so that's a little different, but you can kind of just hand a bunch of dollars to something, and it will figure out how to kind of link and load. So I think there's an element here of like different pieces of logic come from different places, and we kind of want to like it feels a lot more like a library thing than I want to solve this specific set of problems for everybody in the community, should we say?
Yeah, I think it's like there's like a discipline that comes from plugins, and then there's like a cost. So like I think right now the code, it's very easy to end up being very intertwined between like different stages, or there's like I think one of the sort of subtle things is like what Jordan's thing did is like we now have these abstract stages that we can kind of understand versus the code. I know that historically, I think we had a conversation on Slack where it was like, we don't necessarily want to get too tied up in a particular code flow, because what if we could like change it to make it better and like all these things. At the same time, if you look at how Kubernetes semantics work, it's like you actually have to do certain stages.
So yeah, like there's things like services running for like policy, for instance.
Exactly.
Like, we had this discussion in network policy API.
Yeah. It's just like you can't
like, even the future APIs.
You can't like compute it.
Nobody's seeing a path to do something different.
Yeah.
So that kind of thing makes sense at that level.
Yeah. So like the discipline of plugins is that for sure, when you write a plugin, as Mark was saying, you do kind of have to adhere to an interface. And if you pass any data or any kind of dependencies across that boundary, it has to be very explicit. I think like that is one feature that then allows you to compose things easier. But the question is like, do you need to go all the way there to like make it a tail call, et cetera, et cetera? Otherwise, you end up with like a bunch of headers that just get like CPP included, which is probably like the most.
Yeah, like
yeah,
like one simple solution is like, okay, so you have like the one-liner hash define, pound define, like somewhere in all your hook points, right?
Yeah.
And then you have some cater file, whatever defines what that's going to be. Or it's going to be
right
some chunk of code, but that's not giving you the formalization that you're looking for, I guess.
Yeah, I think the phases and identification, and of course, it's a maintenance cost across development, and it's not necessarily like you say we're going to maintain this forever. It's more like it's predictable whether or not it changes, and kind of decoupling between the person who writes like after this phase I want to do X versus like oh, we moved where X happens, but you really shouldn't care. It's like, how do we separate those two things? It's difficult. It's difficult.
Yeah.
Because we know for sure, like there are certain features that all they care about is like they run after some phase X, right? It's like how do
like you're trying to observe something, just make sure that
exactly
you're actually going to get that. Like you're going to admit, okay, observe
Yeah.
that point, right?
where it's like, oh, you're like headed out or something. Like even in today, it's like, let's say like you're done with everything, add an extra step. Because I think in the code base today, there's this hook point, like, which has a little bit of mysterious, like, do not do anything semantically meaningful in this hook point, like the extra tail call, I think.
Is that what the custom call?
The custom call, yes.
Yeah.
It was like, well,
that was an experiment that
but the thing is, when you see that, right, the developer immediately is just like, you told me I shouldn't do anything. but no one's looking.
well
So,
yeah, I mean, I think part of that is like that, like as a community, we don't want to kind of get to that point where somebody shows up out of the blue and says, oh, but we can't change that because my product is built on this. And like, well, we never agreed it's a stable API, and we can never change this. And like, that creates like tension for sure.
Yeah.
That's kind of our
And I
concern. Like
you seem to have some cognizance of this.
we're locking down a lot of things that now can't change, or if they change, they'll break plugins. If people are relying on those things to be stable. So we're kind of trying to figure out what's the right level of guarantee, right? We could say like we have a version constraint. It only works for this version, and then we have to build that in. And then we have some freedom to change it, but then plugins now have to fix things every time they upgrade. So yeah, we're thinking about like what the right balance is.
So maybe one other kind of macro, like looking outside the project kind of thing is if you look at BPF man project, it's trying to formalize a lot more what BPF programs do. Actually, you had a slide which I think had like 3 different options, different options you were exploring, right? And I think the TCX, that first TCX kind of one is effectively what their solution is to this problem.
Yeah.
But they are, I mean, they're trying to build a BPF manager, so it's like a system, like a privileged system component that handles all BPF learning for the system. And so I think part of the thesis is, well, as long as you have some strict ordering between these things, you can define, maybe you can say, I need to run after a program named this or something, however it is. Then hopefully over time, we will figure out how to actually make all these different software components like compatible. Some of the skepticism on the other side of that is like, when you do have logic really somewhere deep inside, like I think maybe an example in the Cilium data plane is anytime we do these tail calls, we have all of this like control block buffer, like store these random bytes in this thing, and then like restore them once we get to the like past the tail call. And I think that's some of the indications of state that happens in one program that we actually need much later. And so we have to then carry that state through.
Yeah.
I mean, and like maybe formalizing like the per CPU buffers as a way to solve that problem would kind of give us a more generic.
I think it's interesting because we mentioned the C programming model, but what you kind of see when you have the BPF is that the tail calls make it more like a continuation passing model. because you have to explicitly like rip out your stack and send it.
Yeah.
So it's just like it's the mix, I think, that makes it hard. Because you have some code before you insert a tail call that's like this like C nested stack model. And then as soon as you have to insert a tail call, you're like, oh, I need to kind of make it a continuation.
Yeah, that's the challenge. It's really easy to do what we've done here if there's already tail call, but splitting things apart gets really messy really fast.
Well, this isn't a point I wanted to look at as well, because we have been gradually splitting up a bunch of tail calls, and yes, it's hard. But I also wonder, is that the same hard work of trying to define what the API is between these things? Because you're like disentangling these pieces, and then you're trying to figure out what state in this program needs to transfer to retain the semantics over to this like subsequent program.
So
is that the same?
Yeah, is
thing
that
that we're actually struggling
a
with?
Directional thing that you're seeing like the project move to?
I mean,
because I think
usually
in
the pressure
end,
for that is just like code size, is like the complexity. Like we try to load some program, maybe you want to add some like new logic into some particular segment, and it's just quite
because like if there was like an overall push to like, hey, we should make this more continuation versus like nested functions, which I think would also hit verifier issues, because you have like, oh, this variable is like live like all the way through the stuff.
I mean, unfortunately, the worst combination is both. And originally in BPF, we didn't have the other option. Like L-goals was the original way to do multiple programs, right? And that's kind of the indication of Cilium's age in some way. I would like to have a good long discussion about, what does the future of the Cilium data plane look like? Do we actually want tail calls? I know that some folks are wanting to kind of move away from tail calls as a primary mechanism, but it's obviously a lot of work to sort of overhaul it.
Is it possible to remove it, because it does have like separate loading, separate compilation? Like there are advantages to having it split. The verifier only has to verify like one segment. If you like added everything together, I
think it would still be. I think it would still be multiple BPF programs somehow chained together. It's just whether it's a continuation, whether it's like function call kind of library routines, or it's like PCX. Like these are discrete programs, and you define some.
So
kind of
have you considered like, are you saying like break apart the Cilium Datapath and then load multiple programs to a CCX point, or?
It's certainly one of the options. I mean,
that would be a big refactor.
That's part of my reticence, right?
Yeah.
And I think there's a couple other constraints. Like one is that we aim to do a hitless upgrade of the data path, right? So you have some version of Cilium already running. You start up a new agent of a brand new version, and then with that version, you have the BPF data plane shift. So then you have to load all the new BPF programs, and then basically do atomic switch.
You only need atomic swap the first step. Gets a little bit more complicated.
It gets more complicated, unfortunately. Yeah.
It's like the like shadow. Like, oh, welcome. There should be an upward. More chairs over there. I am Bowie. I'm the co-host. Hey. Hopefully you can
Please join us. Chandan is our partner software engineering manager. My manager is Neha.
Yeah, so I think this is a very rich topic. We are really interested in understanding like what is the way to manage complexity. Obviously, plugins is like one technique.
Yeah, so complexity is the primary. Like
I think complexity, and then so we have this other use case where we just have like some random stuff that doesn't make like adaptions. It's like doesn't make sense to upstream. We would try. We might not be like generic enough, and we would like to not send it into the upstream if possible. Not that we couldn't upstream it. It's just like it might be kind of like such a specific use case. Like, okay, trying to get it upstream might be hard. So there's the how do we make the programs easier to understand, I think, because obviously if you like really did the big refactor, and then you could have this like graph.
Part of the reason I bring that up is like I think one of the Cilium project philosophies that we like to bring back up is like, okay, how would we design this if we were just doing from scratch?
Right.
And like have that like in the back of your head so that
Yeah,
you're
yeah.
not moving to a less efficient,
Yes.
like crappier version. Because you're like, okay,
Yeah. So like
some kind of null stuff.
Yeah,
Like
like
in
the
the right
plugins
direction,
is an
right?
interesting one because it's like you could see that as an incremental architectural step towards like a more staged. You just basically like try to like one of the strategies is to like move actual general things into plugins. But again, that has a performance cost. And I was
Right.
talking to Jordan, and it's just like, what is the intuition behind the cost of calling a tail call versus like inlining something versus something else?
Yeah.
Like.
Do you have a sense for that?
Well, you're supposed to spend.
I feel like this is something I should know, but I couldn't
Okay.
qualify it.
Yeah, we were going to benchmark it to just understand, like, you know, because like these like rules of thumb or whatever, it's just like if I added a tail call, this is equivalent to doing blah blah blah.
Yeah.
Like, in the code.
Yeah,
I mean, those are
in-
always useful.
In the context of this plugin system, I would like to just see what's the performance impact of disabling plugins completely, not having them, and then enabling like a really minimal one just to see what like the scaffolding itself, what's the overhead of that, you know? Get a better sense of it.
Am I right in thinking that if somebody's using open source and wants to add a plugin, they now have to do a custom build themselves to compile that into?
I think like, okay, assuming Jordan's POC, blah blah blah, like. It seems conceivable that you could have like Cilium checked out, and then you could have your things separately and have a separate compilation. There's caveats.
We were kicking around the idea of like, well, wouldn't it be cool if you had like an out of tree third-party plugin that gets dynamically loaded somehow? But we don't really have a use case for it right now.
Yeah.
It's a lot of complexity. But in therery, yeah, I mean, you could do something.
But
Like if we had like
mostly
3
remote.
users being like, yeah, let's do that.
Right.
Okay, let's solve that problem, right? Yeah, it's a lot harder to say right now.
The concern I just have that you're probably thinking of is as the community at large is not Google's and Facebook's or
Right.
and all that are custom building it. So now we're kind of encouraging them to go off the master branch and the releases and do custom builds and have to like
That's
keep them
true.
up to date.
But I think the biggest thing though is just making sure your functions are well organized as opposed to like trying to spread it all over the code. And that goes to the current code itself, though, in some sense.
Yeah,
There's
it's-
some similarity with the core DNS and node local DNS plugin model.
That's actually what I was thinking, yeah.
Yeah, so the node local DNS one explicitly requires you to import all of them together and then make a custom build. But I think the core DNS,
Or DNS, you can do it
add them
separate.
on the fly.
Yeah.
Right. Yeah. So for Datadog, we have like, this is from an observability standpoint, right? So we have a network performance monitoring product, and there's a lot of stuff Cilium does that, like what we do is basically look at everything from a TCP stack perspective and just observe it, right? But if you want to get more visibility into what Cilium's doing, it gets really ugly. So
Yeah, I think tracing is like very hard because you have to kind of plunk little bits everywhere.
yeah,
to
but
get it right.
this would be great. Like if Datadog agent can add something into the Datapath to like get some more visibility. Yeah, I don't know if that's the direction you want to go, but that's another use case that comes to my mind. And with another thing that came to my mind is with Hive, I guess, with Hive and StateDB maybe, like we get a lot of debuggability and tracing with the tooling, right? So do you think like this would make debugging easier in the Datapath?
Yeah, I think like one of the subtitles for this is like Hive for data plane, because it's like Hive kind of
I had it somewhat.
Yeah, like
right at the top.
it's like Hive is like it's great because not only it's like you could add your own stuff, but it's like actually the existing stuff now is reorganized in a way that's like more, enforced modular. And it's like, how do we add that for the data plane? And once you have that, then you can talk about interposition. There is, of course, the maintenance issue of like, now we have to like, hopefully not have a guaranteed API for that.
Yeah,
But
I mean that's yeah. When you mention stable, I think I kind of what do you mean by stable? Like because that's one problem
Yeah.
with Hive that we do not have, right?
But
I
I'm-
mean the infrastructure obviously is
I am curious though, because I think like Jordan has this abstract Datapath, which I think exists in many people's minds, but I don't know if it's like a thing. Like I think even that would be interesting because if we don't guarantee any kind of stability, but it's like a documentation almost. It's just like this is what kind of abstractly
We
the
have
data-
these features, they
yeah.
operate in
Yeah,
this
I think-
order,
I
so
think
that makes sense.
I think I showed you like the screenshot of the Kubernetes scheduler plugin
Yeah.
model. I don't know how one-to-one that maps to their actual implementation, but they have this kind of abstract, like here's phase 1, phase 2, here's the order, here's what things do. So like having that model in mind, or that picture in mind of here from a plugin implementer's perspective, here's what the data path does, but the code may look a certain way or completely different or change from release to release, but you still have that kind of abstract picture in mind or working for a plugin.
Yeah, like I even, just as like a hack, just because I was curious, I even took the LLVM emitted code from the make BPF and then like extracted the call graph and then basically like tried to make sense of it. But then I realized that most of the functions are not a function call, they're just like inline in the main.
Oh, I see. Yeah.
So it's
Oh,
like,
well, yes, so that's another kick it, basically.
I see.
I
Yeah,
mean,
like
to some
even
degree.
like.
I mean, obviously,
factoring
like they're optimized, like,
Yeah,
but like originally you just couldn't, you had to do inline.
yes.
And so,
But actually my hack uninlines everything.
Okay.
So you could like extract the call graph. But I think like even moving just the code base, just like slight refactorings towards something more defined would be useful.
mhm.
Like forget plugins.
Did you look at packet? Where are you from Martinez?
Packet, where are you?
PWRU.
Yeah,
Peru.
yeah.
So at LPC, Martinez and Gary, like they gave a talk where they were also trying to have some visibility into what Cilium's BPF programs itself are doing, and kind of capture like the input and output from every BPF program. I don't know how they're doing that. Like,
But like, so Peru in general is attaching basically tracing to the kernel overall. And so like part of the benefit and the idea behind it is, okay, it's great that we have Cilium. We put a bunch of debuggability, Hubble, like whatever
Yeah.
else, like you want to know what's happening with these packets, or your Datapath program, you can like add debug statements, like all this kind of stuff. It's great if you're just handling Cilium.
Mm.
And then at some point, Cilium hands the packet over to the Linux stack, and then like, who knows?
Yep.
And so like a packet just disappears, right? And maybe if you're lucky, there's some metric somewhere in the Linux kernel that you can kind of look at and then interpret. But this is trying to say, well, actually, no, like what if I can like have some constraint, like an IP address or something, and just say, okay, trace all the functions that where this packet is actually going.
Kind of like a more
And then,
generic
like, yeah.
tracing.
And then you can catch like, oh, it was dropped in IP tables, it dropped in the routing table, it was dropped in Cilium, this BPF program specifically, but it's like a general tool for that stuff.
Yeah, it prints out all the exported functions and then attaches trace probe to all of those, right?
It's
And then it looks for those specific things and catches the probe. Yeah.
potentially expensive.
Yeah, that sounds pretty
Yeah,
expensive.
very expensive. It takes almost like 2 minutes for it to just
Yeah.
figure out and then attach.
But if you have a repro,
Yeah.
Yeah, I actually had a pretty interesting experience with that. Doesn't catch checksum miscalculations. I was working on something.
because that packet would just leave the system or what?
Just have to just eaten
It
somewhere.
was, yeah, it was like completely silent. And it's, yeah,
I
that was
think
my
we had a similar experience when we did for dual stack. I mean, there's something like checks. I mean, related to checksum, but it catches it, but it says like because of the kernel, it doesn't return like exact error for the checksum. It returns unknown. Unknown.
Even
Then I
though,
have to
like-
figure out like unknown is like probably the checksum problem. Then we guessed it and then we changed it.
last known function and then go look at the function.
Yeah, last known, and then we looked at the kernel calls. Then we thought, okay, unknown probably written from the checksum. Yeah. But to your questions, like, so the plugin model, right? So this plugin model will be like, you said, like for each endpoint, you'll be generating this full BPF.
I think that is the case with the current POC, but for example, some of the post compilation, because like Cilium is like Glang compilation and then ELF elaboration and that, right? It's like, but that ELF elaboration is what forces the per endpoint program, right?
All of that is in flux. Like,
Yeah.
so we have this like Clang-free
Yes.
project. I think the name is leaked out in different places. There's a few people who are wanting to kind of put
Yeah,
it as a way, like Yeah.
Are we looking
Checking
at
a command as well.
Cori? Is I don't know how to pronounce it.
Yeah.
Or is like some other approach? I'm curious, like, because
Yeah. I mean,
that's pretty invasive as well.
Yeah.
We're all talking-
Which is why
We're
I'm like,
really
yeah,
interested
painting
in
the picture.
like possibly pre-compiling everything, not having to do compilation during Cilium loading and such. Yeah.
But it was also kind of helping us to reevaluate exactly how the loader works. Because previously there was a bunch of different tools. We had like a IP Route 2 that did some loading.
Yeah.
It had like just weird conventions in the ELF files where it's like, oh, the section name is a number underscore slash
Yeah.
whatever, and that means this map, and then you inject the tail call into this like slot in the BPF tail call map, and then, so a lot of that, the conventions have started to stabilize towards something a little bit more sane. Like if you look at like the C BPF library, or even the Go eBPF library. So
Also, I'll give us like 5, maybe max 10 more minutes on this.
Okay.
Definitely have to.
So I think, Joe, like, what do you feel like would be the next step here? It seems like there's a lot of interest, and there are a lot of different possibilities.
how do you narrow it down?
Yeah. And I would love to see like how I know there's like some North Stars, like that's like a big refactor. So obviously the community's not going to do that in one step,
Yeah.
but just like
You need to
incrementally, how do we
somehow.
get there?
So one, I think, quite interesting point that you've raised that I'm seeing is basically like you would like at some point in the data path to be able to say, here are a bunch of invariants, and you
Yes.
clear those invariants. And even if that's just like some asserts there somewhere that we can say, we're agreeing, at least right now, these things should be in this, like the LXC. I guess I don't know necessarily exactly what those invariants would look like, but
Yeah,
if we
like,
start to formalize that, I think that's definitely
Yeah.
step.
because I think like, for example, let's say, oh, I'm going to write the CFP for this feature, and I start hunting around for like, where am I going to put this? And I think, you can correct me if I'm wrong, like you basically have to look at the whole code base. If you're new to the project, kind of like look at the whole code base and be like, I think I need to go here.
So how much of that is like a documentation issue versus?
So that's what I was saying is like the abstract representation, documentation, that might be, it's not an API and it's not stable for sure, but it would help folks, and especially if it could be extracted automatically through some magic, which I'm happy to see if we could do that. Like that would be awesome, because then you could basically easily go to someone and be like, I think it makes sense here because this is like kind of understood, and it's like it's supposed to behave like this.
On the documentation point, my head goes to the wanting to define like formal stages at each point in the code base. And
So it's like documentation. I think it goes, maybe that would be an incremental step, because the refactoring anyways would require someone to understand it to the level they could talk about it to get to a refactoring. So, and then like in terms of automatically generating it, it's like, yeah, we could like put like some doc string kind of thing. Maybe it could be extracted through some CFG in Clang. Maybe I'm waving my hands severely. It could be done.
One thing I've thought for a while is like it'd be nice to even just have a tool where you can just say, hey, I have a setup. I have a bunch of tail call maps and a bunch of programs. Just give me the graph. But actually, I think maybe Anton wrote this tool, and like he presented the picture at OSF maybe a couple of years back, and like it's just this giant graph, and you're like, oh, that doesn't necessarily count, because like what like. I mean, I think even we had like some slide where we just said, oh, here's the data path. Like you do service processing, you do
there is a picture
linked into that contract and then policy and then like routing.
So actually, I was able to extract something like that by looking at the LLVM bitcode. And then separately on the side, you scan through the code base to extract annotations, and then you can actually correlate them back to source code and create a graph. If with some modification of the Cilium source code, like by adding like some annotation stuff, you could automatically extract it. There's one catch, which is the if and defs.
Yeah, we're trying to get rid of this.
Yeah, so the if and
Again,
defs
like,
are
long-
quite, because it's like a step that happens before any analysis tool, and it's like sometimes the code segment just like disappears. It's like it's like very hard to track.
We're trying to get rid of those to swap them for something that. So the nice thing about if-diff is like if there's code there and you disable it, well,
It's gone.
don't. Yeah.
Yeah.
But you can achieve the same with.
Like, does Clang
not-
DCE not work in all cases? Dead code elimination.
Um,
I know Clang is very aggressive about that. Like you have a const and
Yeah,
then
yeah,
like
yeah.
DCE.
I think it's more just like the way that we can code the config of like which parts of the data path will be enabled or not.
I see,
is
through
always
the
different. Like,
deflags.
so like, kind of
Yeah.
prevented.
I'm curious though, if you like did a
wanted to-
deflag to a const and then Clang DCE, like maybe you could just replace all the
Right.
if defs with just ifs.
Very roughly, that's what we want to get towards, but then rather than get code elimination, we want to compile both in but have static variables. And so
Oh,
you basically have
interesting.
this like table of here are all the features, are they enabled or not? And so then you could generate, okay, enable this, and then anything that needs to be included basically follows through and just like runs all that code. And then anything where you want to skip it, you basically have like a no-op or a jump instruction.
Mhm.
So if it's a no-op, even flows through and you like run the code.
Yeah.
If you need to disable the function, you add like this jump statement there that jumps to the
Oh,
end.
this is
And
like
then the dead code elimination, everything.
my self-modifying assembly back in the day.
And so there's been gradual progress on this kind of infrastructure in the kernel. Yeah, Anton would definitely be a good one to talk to. I think he was still presenting it like a Linux conference.
Yeah, I'm
a
trying to
couple months
find the
ago.
talk, but yeah, I don't know. That's not part of it.
So like a lot of the pieces are there to make that possible, at least on the kernel infrastructure side, like static
Static keys and
keys is what the,
this is so.
I see.
like, because this is heavily used in kernel in general, just for like,
Oh, I see.
kernel modules.
Get rid of branches.
That kind of stuff. So this is trying to formalize it more into like BGP APIs, where you have a map that somehow has this kind of static key
Interesting.
thing, and you get the kernel JIT to then.
Yeah, the JIT could
control
remove
that
it,
stuff,
yes.
right? So that's sort of our intended solution to the if-diff problem,
Mm.
which is one small piece of the
Yeah.
solve, but, obviously we could probably talk about this all day.
Yeah.
Like one thing I'm wondering is if the simplest step is just have like pound defines at these well-defined points. We identify what these well-defined points are, right? And then the default of that thing
It's
is
just
just assert this I don't know, control block field has this value.
Mhm.
Or something like start to try to identify what are those assertions you want to make. And I'm not saying we're going to commit to that forever, right? I'm just saying
Yeah.
let's declare those, because if they change, then you're going to want to know, right?
Yes.
If you're writing your plugin. That seems like it's a very simple thing without hugely changing other things. Now, maybe it turns out like one of the other solutions you brought, or like the one that you demoed, maybe we need to get there anyway. Like maybe that's another step, but like
So
I don't know what the
the
line
purpose of the assertions are what, just to make sure that the
It gets maintained,
guarantees
I guess.
are maintained?
Yeah.
Yeah, I mean, because I guess what I was hearing is there's two things. Like you want to dynamically add some code, but then that code is somehow
Reliant on.
reliant on, like if it's just where it is, then maybe it's a little simpler. But sometimes it's, well, like I mentioned, you're gonna have some way to call back. So
Yeah, I think like
if you're doing the insert the tail call.
the challenge is like, let's say you used to have
Yeah,
a straight line thing,
Yeah.
and you're like, this is kind of a point where I well understood
Yeah.
what semantic is, and it gets refactored into a bunch of tail calls, and then it may not join back. So it's like sort of like, something is like, can I grab the packet at the end of all the Cilium stuff and do X or something, right? It's like, is the disposition, because you have all these tail calls, it's a tree,
Yeah.
maybe it joins back, but maybe it doesn't.
So you want to like you have a lot of like drop conditions.
Yeah,
something
yeah,
like
yeah.
that, right?
Yeah, so it's like, how do I know that I kind of caught it in this phase? Whereas NetFilter, not to use a bad example, it's like you do know that like it eventually traverses like one of those functions.
One thing I wanted to ask before we're out of time is, you're like looking way in the future of like what Cilium Datapath should look like or could look like. I mean, is it possible to, so if we were to say we have well-defined stages, is it possible to refactor things so that we literally have like program 1 attached to the TCX point at, first, and then program 2, and sort of just makes it very easy to insert things between those points. Maybe that's impossible because we have to branch and do things that aren't easy to just linearize in that way. But just wondering how feasible that would be if we were to like push in that direction.
I kind of like that because I feel like that's the natural boundaries we're forming.
Yeah, it's very natural. It's like what?
I feel like that's the natural boundaries we're
It's
forming.
like I don't know how feasible it is to take what we have today and kind of fit it into that sort of shape.
But it's one thing is like, if, for example, we want to go there, do we want to start sort of pushing the code in that direction? It's kind of like, I think one of the things that when we were looking at it, we weren't like, is the project, it sounds like, yes, we want to kind of push it there more like a pipeline graph model versus like a C function tree model. Because the C function tree model is like going to be very different. And some of the things you do to the code, like just in terms of like refactoring, like you wouldn't do unless you're kind of like moving more towards like, okay, these like kind of abstract stages that are well understood stitched together.
Well, yeah, I mean, so when I think about like communicating to users about how Cilium's behaving or how it's misbehaving, right? I end up coming back to like these logical statements, like services,
Yes, exactly. It's
and
all
contract,
in your
and
mind.
policy, and routing, like a tunnel. So that's what makes sense, and that's how I think we probably want to get to communicating to users. This is what the data path is.
Yeah.
So it's different from IP tables where it's like, here's a list of rules. You have to figure out what those rules are.
Yes.
But saying, no, we're more opinionated. We say like, these are the functionalities you're getting in this kind of order. But I also think that that's kind of a middle ground. I think if you go even further, you end up like just creating a generic like table, like match action, like jump to the table.
Yeah.
Whatever. My background's OES, like did that for a while. It's very cool. I think it's great for if you don't know what your solution is.
Yeah.
But I feel like Cilium's trying to say, no, we have a specific set of problems we're trying to solve around networking. We are opinionated. We're going to try to build the best thing for this set of use cases. We're not trying to build a generic API for everybody.
Yeah. I think
So
like
I think the pipeline thing seems like it's somewhere in the middle.
Yeah, that's like always the trap of this, for example, like aspect-oriented programming, where you just get this like blob of like all these things like this depends on this and this, and it's just like it's very hard to comprehend. So I think the definitive stages and some light amount of phasing would definitely, to me, like
I mean, you could maybe start out just saying like, here's the idea of what stages look like. There's like just documentation, and then try to then move the code that actually fit that shape.
Yeah,
It may turn out that it's actually not that far. That it's just that like
it's not
one
formalized,
stage
yeah.
is like 3 or 4 different programs, but like the kind of I mean, there's no split before or after contract or before or after policy. Although contract and policy usually very tightly bound anyway. Like you have a bunch of stack context that you need to somehow share between the 2 different programs, if you will. So I don't know if
So I'm like,
no more.
but yeah, I'm sure we can.
Okay, so
We'll be here all weekend.
So we should talk if you are around this week.
If we can pull in Daniel, it'd be awesome as well.
Okay,
he's coming right now.
Okay. Yes.
I'll ping you because I'm here until Thursday, so we can catch up in the hall, and then for sure Jordan will be on Slack and all those places.
Yeah.
So we could.
Are you sticking around a couple like any longer?
I'm going back tomorrow.
But I think we can catch, and I know you're in the area. We could even meet up for coffee.
Thanks for presenting this. This is really fascinating. Like,
Thanks.
All right.
how you're trying to dive in.
Yeah. So like, I think we'll just be hanging out on Slack and then the community thing, and then we'll probably have impromptu meetings to kind of keep discussing this. It sounds like everyone has like a million ideas.
Well, yeah. So yeah, we had a strict data path and like a regular meeting and so on for a while, but like data path is so core to Cilium.
Yeah.
It just grows and grows and grows. And now it's like there's like 40 or 50 people who all have some different ideas. And
Does
so,
anybody own? Like, is there somebody in charge?
Right now, there's no specific on.
Okay.
But we make
But obviously, there's interest, right?
Yeah,
Yep.
maybe we talk about that later in the day when we get to SIGs.
Yeah.
But
Oh, yes.
we got a different topic right
Yeah,
now.
Okay, yeah, let's move to
So-
a different topic, sorry.
Is this the making Hubble standard? Is that the one we're doing?
Yeah. So I want to preface that once he joins. So we have built this project called Retina, and then our goal with Retina is to make it a sugar stick so that customers get used to the observability, and then they can easily move to Cilium based. So that's why we are using and we are bringing the parity with as much as possible with Hubble. We did make it like almost parity with Hubble, but there are some pieces missing. And that's what we want to discuss on how we can make it so that Hubble is more of a library and is joined. Okay. Hey, I'm Bob.
Hello.
Hey, welcome. Oh, success.
Hey. Thank you for sending the invite.
Okay. Anubhav, I was just mentioning the goal of Retina project, so you can take it over and then probably talk a little bit more about what is missing and what is the parity right now.
Give me 1 second, please. Can I share my screen maybe?
Yeah, so
To show the slide?
if you can, it's like if you look at the bottom row, there's like a couple of icons, just hover over. One of them is share the screen.
Okay. Okay. Give me just 1 second, please.
Could list of the members I can share this with.
Do I have permission to share my screen?
I think you should, if you share your screen with me, I can tell you what you need to do. There you go.
Oh, yeah.
Okay. Thanks. Thanks.
Anubhav, keep this short, only 2 or 3.
Yeah. Yeah.
Just for the meat of it.
Correct. So this is just to introduce the Retina project. So the goal was to build a very lightweight and multiple things agonistic lightweight agent that will be capable of collecting important events and serving important metrics and traces to users. And the point I want to highlight, for the purpose of this discussion is the thing that I mentioned is how to use Hubble as a standard platform. So whenever we talk about observability, like how we will consume observability, we talk about Prometheus metrics and we talk about Grafana. Right? They have become kind of a standard. And if you use these terminologies, if you say, hey, whatever software you are using is going to generate Prometheus metrics, and you can visualize them in a Grafana dashboard, everyone would understand what exactly you are serving, no matter how you are serving them. So that brought us to the question is, okay, are we planning to create our own standard? And if you look at the bottom left corner, I think this is very, in software engineering world is very common, which is we say, hey, well, there are all these standard, I am going to create my own standard. This is going to be the industry standard going forward. And then it just becomes one more standard out there in the open world. So, we already knew Hubble, what it can provide, and we really liked. Users also brought us this feedback that Hubble, the Hubble platform is like, it produces metrics, it produces these traces, it has all these sort of tools that you can interact with, like CLI or Hubble UI. So that was then what we wanted to do, is make Hubble a part of a standard on how to serve the metrics. So if Prometheus metrics is the end goal, then how we are going to serve it to you is through Hubble. So we are hoping going forward, Hubble is going to become like a standard library, which you can just add to your project. And if you go ahead and tell anyone that, hey, we serve metrics through the Hubble platform, then people would immediately understand what it is. They know they will be getting Prometheus metrics. They know there will be a broad set of tools that is openly available for them to interact with that. They would know exactly maybe how to get the metrics and traces, like very standard ports. So that's what we hope we would achieve going forward, is that Hubble, this box Hubble is going to become like a standard of observability platform, irrespective of what CNI you are running, what kind of OS you are running, doesn't matter. As long as the software supports the Hubble observability layer, you are going to get a standard experience no matter where you are running it.
Yeah, one point there, actually, we made Windows also work with this. It's a little bit of a winded story. We have like 3 different solutions with Windows, but we will bring Windows eBPF very soon with Retina, so that Hubble Windows eBPF works fine.
Right, and I can share also the issue that is already open against Retina repository to bring Hubble, the entire Hubble experience seamlessly on Windows. We have made some progress to it, not the whole bit, but we are hoping to bring it very soon.
Yeah, so what has happened is, because right now Windows has never been thought about it, right? So when you think of Hubble libraries, they have like these intricate 3rd or 4th dependencies which use Unix socket, which Hubble doesn't need it. So if we can cut them off, I think we did some pre-work on what are all the libraries which are using them. I think we have to go in, like, librarize Hubble, make it in such a way that we can just import and then make it work with.
Is there like a library? Like, I've heard this problem in the, like, how do you run some Linux app on Windows?
Yeah.
Agent on Windows.
Certainly not the first times that I've heard this kind of, oh, I use Unix sockets. What do I do instead? Like, is there some sense of, like, there could be a Go library that then just provides some local socket thing that solves this? I mean, I guess you still have to change Hubble, you still have to change whatever other software you're
Yeah, and then we have to interface some bits and then Windows and stuff. But
the bit that was more, so there's a Unix socket, but there's also a remote server that runs, right? Like, at least for peer service, you can use that to interface with Relay, for example, or talk to the other agent. That part, I know we were saying that may be easier to replicate, because that's just a remote server, right? Like, you can run a remote server on Windows. That may be easier to kind of create a wrapper and interface around. The Unix socket part, of course, that there need to be some kind of other socket experience there. But we think we would be able to replicate, as long as, again, like, the experience is same. Like, there is some kind of a socket you can access, pretty similar to how you do it for Linux. I think we can replicate that.
Yeah, I think it's usually, maybe this is going way out on a limb, but I do feel like compiling like that, like, even if it's just Go OS equals Windows, make like whatever, like Go build, usually leads to like some kind of code quality improvements, just because, like, yeah, we just write a bunch of stuff that works on Linux, and then we cut some corners, because you don't have to solve these problems. This can lead to improvements. I think Go is fortunately has a lot of nice tooling to help with this kind of problems.
Yeah. And I think this also kind of replaces a different problem of running whole Cilium agent in Windows. Yeah, that's also counterpart of ours, is like struggling with it a bit, and then they're taking a different route. Instead of like navigating this code, they thought of like taking a short-term solution, which we did not agree with, but again. But it's a long-tailed effort to make the whole Cilium agent itself to run on Windows as well.
Part of that effort, it turns out like we are trying to use Hubble as a library, right? But there are some dependencies with like underlying other Cilium modules. Even in Hubble, they may be just referencing, some variable or constant, but there is definitely some linking that is not necessarily required with some of the other Cilium modules, which we are not using, but Hubble is basically pulling them in for compilation. So I think it will be a good exercise also for the Cilium code base that we are identifying these dependencies that doesn't necessarily need to exist. That will make the Hubble module in Cilium more like a independent package that can be pulled in more easily for any project.
Yeah, so I could maybe speak one thing, which I don't know if you're going to like this, but so in the Cilium code base, early on, it was a bunch of C programmers writing Go, and we didn't necessarily follow all the conventions. And so in practice, one of the major things that the Cilium project does, which does not conform with the norms of Go projects, is that we have this pkg/foo. And technically for a Go program, you would normally expect after 1.0 that's stable. Cilium project does not adhere to that whatsoever. Like they will shift package/foo to package/file.
Well, I have to admit,
rearrange
most
like,
projects
whatever.
don't adhere to that.
I mean, like, I don't know if we've explicitly written this down somewhere, but we've certainly we've tried to at least like say it in forms like this, or like whenever it comes up, like, hey, like we have not put thought into how any of that stuff actually is a stable API. And so when you import it into things like Hubble or anything else, that means we're kind of expecting you just have to, there's a new version of the library. It could, like, if effectively every minor version is a new major version. Yeah, there's no effort to retain that stability. But that doesn't mean that we can't, for instance, maybe refactor some of that so that dependencies that shouldn't be there in Hubble aren't there in Hubble, right? Like Hubble shouldn't need to link against BPF libraries or something like that because it's not inherently like touching the BPF side of things. It's communicating with the Cilium agent over the Unix socket. Okay, so we need an abstraction for how it communicates with the Cilium agent to receive that data or to like make this query.
That we kind of found alternatives on how to do it. Instead of Unix socket, probably a board of programming. So we found ways around it. But again, it's the, like for example, I think Hubble imports IP cache or something like that. And then it goes somewhere else, and it goes somewhere else, and then that uses something else. That is the issue. So that was one question we wanted to ask, like what was the motivation to pull in Hubble from a repo of its own into Cilium?
Yeah. So we're talking basically about the Hubble server here. And this is, we've encountered this a few times actually, but initially we've written like some piece of software and like, oh, like we had Hubble, or like even before that, I think even the Cilium monitor piece, which is like the piece underneath Hubble actually interfacing with the BPF, was a separate agent at one point in time. And over time, you tend to hit this problem where you grow the features, you need to use more stuff, you need to pull in more Kubernetes state. And so like the daemon kind of grows and grows and grows. And at some point, half the memory is like just shared state, and like you're just separately syncing all the other things from everywhere else. So you kind of, there's a tendency to, once things get a bit more mature, say, well, actually we need to kind of pull it back like into the main actual tree, or like the main actual binary, so that we can just reach over and get whatever resources we need, and we don't have all this state sharing or like race conditions of like how we're sharing the information across different
it's because of the classic Kubernetes informer problem of like
I think that can be some of it.
I mean, we've seen this, like, we've like, oh, why don't we just run every controller separately? And then it's like, oh, that's too much memory. Push them together.
For
yeah.
So but when we merge it together, like still like making it like more of an interface based kind of a versus right now it's very tightly coupled with Cilium agent. Do we have any like I don't know when it would benefit definitely us to make it more?
Yeah, I think we have to
interface-based?
do some POC ourselves first and then put all those interfacing and then maybe we
That
can
would
propose to
help
you
it,
guys.
even if it is
Yeah.
some
I don't want to run like the controllers in like separate containers or something, but like for example, I saw that Cilium has pulled out the cell concept into a separate repository, if I'm not wrong. Like, and that's great, right? Because it's such a nifty tool that can be used across other projects. And I think there are components in Cilium that are so useful in like generic term, like the IP cache concept, right? The state DB. I feel like this may be more maintenance involved, but if Hubble can be a separate repository which has a very distinct API contract that I can bind myself to, like Cilium would, that probably would be excellent, because then that is like a true library. Hubble can be like a true library which has dependencies on a cache which has its own contract and a data plane that has its own contract. So as long as you satisfy both of them, then Hubble can like keep working.
Maybe if it's a full repo, might be a overkill. Then we can take like within this, like just either to what you said, package Hubble, right? Make it a little.
I think some of this also in like what is like what exactly is the, I guess we're kind of looking for a stable Hubble API, which I mean I think we're not breaking that, like that's considered stable in some sense, but there are aspects, for instance, like we'll put the hook point where the packet was monitored, and so that's like a very Cilium specific thing. It's like it's come from an endpoint, it's come to an endpoint, or I think it's like service related, like we did this service translation. Yeah. And so some of that, I mean, maybe it's generic, or maybe we say the code points are a range of things, and if you come with a different implementation of another CNI or however you're gathering information, you just put a different code point and say, oh, it's actually this other thing. Right. And maybe it's not critical at that point, I'm not sure.
Yeah, I think drawing that distinctions is very important. So we have a diagram. Maybe you can go to the diagram of those pieces.
Yeah.
So some of the libraries is what we are looking for, and not the data plane pieces. I understand data plane pieces, right? And then we get an event that gets converted into a flow. That's middle bit is the custom bit. The green color is what we had to create, the enricher and stuff. The blue ones are the Hubble libraries, which we are hoping to standardize. So it's, is it too small?
It's too small.
Yeah. Is it small?
Let me see.
Anyway, yeah. So what happens after a flow object is created with fully enriched flow object, right? And that gets converted to a metric or a whatever interfacing it has. If we can standardize those pieces, which is a much smaller subset in my mind.
So like there's some notion that like let's say it didn't exist in Cilium. You're going to come along, you're going to build these green boxes. So but you're pulling these blue boxes as some sort of a library. So you can just get presented like, hey, here's this ring buffer. Please populate this with some flow. Yeah. And then it's up to you how to put those things into that buffer. And then other than that, it's just a library. Just put the things, and then Hubble will then export that off the node.
Yeah, and it should work beautifully with CLI. It should work beautifully with UI and everything. So that's how we are doing it right now. Actually, we get all the data plane events from our own eBPF programs. We convert them into flow objects. Use your IP cache. We want to use StateDB. Convert that into enrich the flows. Send them up to Hubble.
And when you say IP cache, so this is in the Cilium engine in the user space. This is
endpoints.
This is the BPF map read and interpreting the contents, or this is from.
So bear with me. Yeah.
Yeah,
so
sure.
Like this.
So it's the concept
we don't like it.
constructing it.
Yeah. So we have an operator which is converting pods to endpoints, Cilium endpoints, and identities.
Okay.
Yeah. And then
these are the clusters which has not yet migrated to Cilium, and they are in the need for network observability. But you need a single pane of observability glass. Like they want to interact only with Hubble UI, Hubble CLI customers, but they don't care. They have not migrated their systems to Cilium yet. So
Stubborn customers is what we call them.
They'll get it.
So-
They'll see the light.
So that-
They'll see the light.
yes, that's the intent is eventually yes, all Cilium, but we also would want to standardize the Hubble metrics, Hubble library, yes, packaging it in a way so that it can run seamlessly for non-Cilium based data.
And other advantage is like, wow, we're getting the Windows thing ready, right?
Yeah.
This-
I can see the bridging those worlds.
Exactly,
Because-
because Windows eBPF is still, I think, year out from running production, and then there's like a big gap in terms of Power BI consistency.
Yeah, it's trying to solve multiple use cases at once. But I think, so I think bottom line is we only need two things to be solved right now. Maybe you can just go to them, Madhavan. So which we want to bring to you guys.
Yes, let me.
So one is service enrichment today doesn't work with Hubble OSS because of these dependencies. Go ahead, Anupam, sorry.
Yeah, so I think this like the first one I would say is this one, which is currently we can't enrich the services. Again, like as Vamsi mentioned, we are using the IP cache, but the IP cache and the service cache functionality libraries from Cilium, and again, like because there's a like strong tie with Cilium, and Cilium handles service creation, pod creation. So there's when these things are created, then Cilium kind of updates the cache accordingly, but it doesn't do it if Cilium is not in charge of creating or maintaining this object. So if we can separate out those concerns so that the watcher that already exists in Cilium, the service watcher, they can cache the service specific some service specific identities and IPs in the service cache, even when the Cilium service controller is not running. That would be really good. We have a CFP around this. There was some discussion going on that the implementation is moving from cache to state DB, so maybe that would solve our problem. We are involved in those discussions, but that's one of the issues I wanted to highlight. And the second one is similar, which is IP cache currently doesn't trigger updates or stores labels until, again, like the endpoint controller is running. So if we could further modularize those IP cache and service cache implementations in Cilium, then we can use the same libraries for enrichment purposes in right now. And the issues are linked here. I can share them on the chat as well if you want to take a look.
Yeah, I think we can bring those and then have a discussion later on. But one thing I
Would you
want,
mind adding the slides if you haven't?
yeah, to the Google Doc. This one actually will happen tomorrow. There'll be a
Yeah.
Okay, do you mind copying the slide as well?
Yeah,
So we can get it.
Just in the Slack channel. I will. Okay, I think I have the link to it. I can add it. Okay. So
Please attend the talk tomorrow as well. There are more slides I want to show.
this group you don't need persuading, but so going back to a previous discussion, right? Running multiple agents. One issue we are seeing is when observability is enabled, Cilium agent has this unbound usage of memory because we cannot put limits on it. It goes 4 gig, 5 gig, right? In a way, there is some merit in bringing out Hubble in its own agent. How we solve the cache sharing, maybe we have to discuss that. Maybe move StateDB into an IPC and have Unix socket so that this guy can directly talk to StateDB and get the data.
Yeah, I mean, like, so maybe some other context there was when Hubble was separate, or when Zoe Monitor was separate, for instance, you had basically some event is generated in BGP, and then that gets put into a brain buffer between the kernel space and the user space. And then the user space then needs to somehow make a copy. I think maybe it makes its own copy between Cilium Monitor and Hubble, even journaling. Oh, and maybe that's actually what it was like previously that memory was basically being pushed across this IPC channel to this other binary. And then you're serving it to like outside the node. So it's like, so part of the question is like how many memory copies you're doing for each of these flows. Like how you
One issue
optimize
also
that.
we had the deep copy one.
That's labels. So, that's just memory was being used up a lot because Hubble, each flow for a given flow, which it has already seen, is going to deep copy the labels every time for every flow object.
Sounds so
And that has been, yeah.
Let's not do that.
We're going to bring that fix soon. So
Yeah.
we have to reduce that as well. I mean, there is some consistency issues there. Let's suppose if the labels change, the flow object is like all the whatever. Like, actually, in fact, it's much better because flow object also gets updated labels if it's just a shallow copy or like a reference to it. But
Should be able to do some string encoding or something.
yeah. So, but aside, yeah. So yeah,
So yeah,
we,
memories and I guess CPU copy.
yeah, we don't have a good way of putting limits on Hubble itself. Yeah, I don't know how we can solve it. I don't know how you guys are solving it for us.
No, we've observed the same issue. I actually felt, yeah, we've had customers where we've had to kind of like tune some of the like configurations to kind of limit that. I know,
You guys
like,
talk, please.
I was gonna say, yeah, I mean, like Shopify have opened up some issues like directly to kind of like address some of their use cases to be able to like turn off certain eventing because before it was like binary, like it was on off. So yeah, no, we've definitely encountered some of the same things. Yeah, no, it'd be interesting to follow up, but like the other.
It's sorry, I don't see that on any of these.
Oh, these are issues on Retina. We have to replicate them. It's called GitHub/Microsoft Retina.
I see.
Yeah, these are just some of the things. This kind of ties in with some of the other aspects of the presentation. Hence, I have hand selected them. But if you go to Retina's issues, there are issues around the things Bouncy was mentioning as well.
Sorry, I meant the label space issue. If you guys filed one and we didn't want the Cilium ones.
Right.
Yeah, deep copy one. Do you remember if you raised one?
Yeah, Mark, I don't know if we filed one or.
Yeah, I have to double check if it was the exact same issue. I mean, I know we've taken like profiles from similar from Cilium agents and saying that like that's one.
I actually created a PR for the same. I'll raise it against Cilium very soon. I haven't run all the tests, so hence it's not raised yet. But that PR should come into Cilium's queue very soon.
Okay.
To fix the label issues.
We'll be watching for it too.
There was another thing, the CFP, I think, Vamsi, you submitted for the filtering. That would also reduce some of the, like, you don't want, if you can give the logs to filter out some of the events, you would want to get it from the Hubble. So again, reducing the footprint.
Spaces,
that was, I think,
I don't know if the
one of the
changes.
changes. Yeah, I'd have to figure out like where that landed.
Cookie or something, there's a newer CFP that's kind of related as well, which is it's different.
I'm not sure.
I think the
too, but
newest,
I'm not.
so like on the if we go to design CFPs, right now there's a proposal from Google folks. I think it's more like I think it's relying on an external system to tag some traffic in some way so that the Datapath could say, oh, like this is something we want to pay attention to.
Oh, yeah.
In a multi-tenant industry, you would want to say, you would also want to filter that I want to observe only certain namespaces. I don't want to observe the whole cluster. Again, it's reducing the footprints.
I think this one, I thought they wanted to track from the cloud itself, right? Hey, my packet is leaving.
Yeah, that's the IP tracing.
To my
that's
host, and then where is it ending up in? Maybe it's tying up to their GKE host routing. Is what I thought.
Yeah, actually, I mean, the main use case is actually not running on GCE. It's actually another product we have, which is GDCH. But yeah, I mean, it's also or it will be cross-platform. But I think what you're referring to with the filtering.
I'm talking about something like.
Yeah, yours is like on the Hubble eventing.
Yeah.
So yeah, I think
Let's say some user is facing some active problem. They know the problem fix this part and this part or this namespace. Like,
yeah, I mean, I think these are different. I think it's just that from like the Hubble event, like producing standpoint, is what you're referring to, and being able to like if as a a cluster operator, you kind of understand like what you don't need.
Yeah.
Be able to
Yeah,
kind
I
of like
can put
exclude
that
that.
out
So
in
yeah,
my Hubble.
so I mean that was what some of the upstream changes that went. These were just like I don't think quite as granular as what you're referring to. They were more like just again before it was like you can kind of have Hubble on and off. Now it's like certain like types of trace events.
Correct.
You're looking to go even like one step
Even
further.
further,
than
like
that.
I need all trace events, but I need it for certain namespaces or certain workloads.
Yeah.
I don't want the whole cluster to be observed. I
And
care
also,
about my application workload. I don't care about my system or vice versa.
and also dynamically restarting the labels applied on metrics,
Correct.
stop reloading the whole Cilium agent. There are some issues with it. So now we cannot, unless we reset all the metrics, if we change the dimensions. So at Chance, we are working with Chance to see if we can create a new Prometheus registry, which will handle some of these scenarios only for the labels which have changed and not changed, etc. So it's a little.
So yeah, I mean, Hubble has been widely accepted by Microsoft customers. They know it, they like it. But these are the scale is the biggest challenge right now for us, where we have like 5,000 node cluster support. We are marching towards 10K, and Cilium, like we're gonna have a talk about the scale where Cilium without Hubble itself is not able to scale. So,
Wait, this is a KubeCon?
3K.
1K.
Is it KubeCon this session?
1K?
Yeah, without I mean
Without
with
scaling
Cilium
endpoints.
endpoint slice, it can scale to 3K, but without Cilium endpoint slice.
And if you enable Hubble after
Yeah.
that,
Session,
then
send
it
it to
just
me.
like
Yeah,
kicks it out. So
I think, we will share that.
Yeah,
Yeah, we're super, because like
yeah. I mean, it's
some of our
it-
folks
it
added
is-
Cilium endpoint slice.
Yeah.
Yeah,
Yeah.
thanks for that.
Yeah, no, I mean, Hubble has been like one of those pain points for like our really high scale.
It's frustrating because like it's so
It's so
useful.
useful because when you don't have it, exactly. When you don't have it, you're like, why isn't this on? So yeah, it's like a really.
Just a rollout of thing. All of these clusters are configured with monitor aggregation, I'm assuming.
Yeah, because that's so we
And
that's one of
maximum
the.
monitor aggregation.
So
It's I think for us, I think we run like medium.
Okay.
It's like default.
Maximum is an alias for medium.
Yes.
because, Like when I wrote that, I was like, oh,
There you go.
hopefully at some point we'll get a better solution. Because I know even medium is not enough aggregation, and maybe aggregation is actually not a solution.
Yeah, so at Datadog also we noticed some of this, but so we didn't have a bigger fix, but what we did was we added a bunch of flags to kind of pick and choose what you want Hubble to emit. So we kind of disable most of the stuff we don't care about. So maybe some of those flags are added like very recently.
what are those flags? Are they
Policy verdict enable, BPF events, trace enable, and also for drops. At least it gives you a little bit more control.
Let's say you're only interested in drops. You know,
Yeah,
you could set it
yeah,
in a mode
yeah.
that's going to drop.
Yeah, you can ignore all the trace events, so that reduces a lot of volume. So we kind of have that
is
disabled
it
by
same
default.
as like your safe? Is it recently added?
We did this like around March. this
Okay.
year.
So
we should wrap this up soon, just so we get a break before like the next
Okay.
set of sessions too.
Okay. So for this one, right, what we have realized is the ring buffer is exactly same size. The number of events coming, I mean, GC will eventually clean them out. That's
So
not-
this happens before the events are even emitted
right inside.
from the Datapath itself.
Okay,
Yeah.
okay.
So you control it from the GPS program itself? Okay.
So, yeah.
You can do it this.
Another thing we noticed is Cilium monitoring itself. So if you run Cilium monitor by mistake without any filters added, there's traffic from Cilium monitor, and you're also
Yeah.
monitoring the monitoring traffic. So I think this is something
Yeah.
there's no
Classic,
fix
like,
for it.
I will admit the flow for every flow that I see.
Yeah. Yeah.
You know, one classic demo we do is just we port forward Hubble UI and then go to Hubble UI's traffic. Oh, look at this. I'm pinging from the world and then it's going to Hubble UI. This is what you are saying. Which is fun, but yeah, we should know that sometimes.
Yeah, but that causes a lot of CPU on that node if you just run, especially if you expose it to users, like second to the agent and then on Cilium monitor blows up. So
Okay. Yeah, but yeah, these are in a way temporary mitigation, and then it can run away at any moment. How can we like limit the process itself? That's the maybe if we I don't know. We can if we can have Go mem limit just for Hubble processes itself.
There's this like Go arena
Yeah.
proposal, but I mean it's a proposal, right? Who knows when? And there's active discussion on this, but like it's the idea is like more dedicated memory regions and you could actually like not exactly allocate memory for yourself, but like have some bounding around.
Is that an active public proposal?
Like I saw like discussions on it.
Interesting.
Like because probably dig up a
Is that
somewhat inside baseball? Like a couple of years ago, all the Kubernetes, at least at Google, were complaining to Google Golang people about how you couldn't bound the data, like the daemons were not small enough. And then I don't know where the message got through. They were adding like more. So hopefully this proposal is along the same lines.
like the issue is quite old. There's been some activity recently, but like I don't have enough insight to understand whether
Yeah,
that's,
send
like,
it to me.
it's making
I'm
progress
curious.
or if it's just like more
Yeah,
people complaining.
Because that's exactly what I think every systems programmer is asking for with Go.
Yeah, that'll be interesting if we can limit by maybe bound by Go routine. Put a Go mem limit on Go routine.
Yeah, that's the dream.
Yeah.
The trouble is what happens when you go over it. No one in Go is writing like if mem.
Well, this is I think this is actually the crux of it. Is like how do you actually make it somewhat cohesive with the Go language of just how Go treats things.
Exactly, like how do you kill a thread?
That's why it's not yet implemented.
Even bigger pipe dream is have a GC per Go routine. No.
Yes, okay,
I think we'll pause the conversation there.
Okay.
And then maybe we can come back at like 10 after. So about like 20 minutes, but if we're all back here, we can also start a little bit
Okay.
earlier too.
I'm
So-
gonna.
Hopefully the flight goes well.
Thank you, and I hope I meet everyone in person.
Yeah.
All right.
Thank you.
Okay, so we've been looking into this cluster mesh for cross cluster connectivity, single region, cross regions, multi region, and the premise of is like yes to have the scale and east west traffic direct connectivity. So I think there are a few options like when he was exploring like the VXLAN based overlay. You have one option. And we have or there is completely native, like you have direct routing, like we have different CNI modes in Azure, like one is pod subnet, which is direct routing, VNet based routing. We assign VNet IPs to the pods, and then you can connect two clusters, peer those VNets and peer those pod subnets as well, which are belong to the same VNet space. And then by the virtue of VNet connectivity, you get east-west. And we can enable cluster mesh capabilities to do the service import export. The second we have is like we don't have a VXLAN based overlay support in the Cilium, at least as a managed offering. We have our own native direct overlay, which is a native overlay, which is built based on the system routes provision via a stack called routing domain internally. What we need is, we saw some blog by Cilium that Cilium does support cross cluster, some kind of a hybrid mode.
It's a very old blog
an
where
old
it
blog.
says like supports like a hybrid mode.
Yeah, where
Says
you have
supports both native and VXLAN routing.
yeah, you have a direct routing.
Which era?
Very old era.
So
There's I think we started very future looking, and then over time we kind of got a lot more close to like what was actually done.
but
versus
we
what
really
was
like that feature.
So there's also I think currently there is also CFP opened, I guess, at the Cilium as well.
Yeah, there was
share
one you
for
shared
supporting
yesterday.
this hybrid
Yeah.
routing.
So Calico does already something like this. they say cross subnet IP pools, where you can define a CRD saying, hey, these are the subnet pools which I want it to be like encapsulated traffic. So pod cider native routing, those IPs mentioned in that CRD encapsulated, everything out is like no traffic. So basically what we want, what we are thinking is if we have some kind of mechanism to tell Cilium that, hey, these cider pools, send it to our VXLAN encap.
Yeah.
And then, so that'll be the mesh where all our stuff will be running.
So anything outside the cluster can get encapped by the node. Going to your like connected cluster pod CIDR via VXLAN. Internally in clusters via direct routing or native routing, whatever routing mode we have.
And the VXLAN is, in this case, it's Cilium.
Yes.
Yeah.
Cilium.
Encapsulated, yeah, VXLAN.
So the reason I asked that question is that the use of the DNI field in VXLAN and Cilium is completely different from the way that traditional VXLAN would use. So just want to make sure we're not.
So
we're
I
talking about
think
Cilium's
I think
usage,
it's
not
We are
some
okay
other
with Cilium
company's
VXLAN.
software.
we just want the Cilium
Yeah.
channel mode for the outside cluster and native routing for within the cluster.
Native routing could be either pod subnet routing or it could be the R overload. Doesn't matter.
Yeah.
So I think, go ahead.
There was a feature called high scale IP cache, which kind of like looks up, which dynamically decides when to embed some identity information into the packet. I think we can either do Geneve or VXLAN for the encapsulation part. This was an experiment, it never landed, it's never stabilized, but it does have a notion of global CIDRs or world CIDRs or whatever. There's a BPF map where you can populate.
Is there some way to expose that through the CRD? Like how Calico does it?
Not a
Because-
CRD, I don't think.
Yeah, it was a BPF map. I think there were plans to make it a CRD,
Okay.
but I don't think the feature is stable, or it never went beyond an experiment. But
I mean,
that's a replacement for IP cache, right? Like you encode identity within that, and then you always use VXLAN mode. That's not in a hybrid mode. Once you choose that mode, it will always go with the.
right, but as an extension of that, we are also thinking, what if we can do IP cache-based policy enforcement within the cluster, and when you want to cross the cluster boundary, then only then encapsulate it.
Got it.
So
That'll help.
because with the way that feature is built, it might be easier to extend it to basically do IP cache-based policy enforcement within the cluster and only do uncap after. It needs some changes, but to me,
And
it's
has that feature already, is it in? Like, is it?
Yeah, I think it's it's meant master or no?
it is in the
It's
master, but it's not really stable.
It's not stable and
I
it's-
think
there's no way to
the
expose
biggest
it.
problem we've had with that feature is like there was a CFP and a couple of people understood exactly what it meant. And the name is much simpler than what the actual implications are for the architecture of the entire thing. So like, I think there are elements of the data plane that changed to try to support this kind of use case. And there's alignment to some degree there. I think what would be maybe more interesting to me is like, what do you see as the requirements at the, say, management, like CRD kind of level, at the agent level, what does the agent need to do? And then, yeah, if we need to dive into the data path. I mean, at some point, the data path is choosing maybe IP ranges to decide whether we're going to send it to the tunnel device or not, right? So like, is it, because we have I guess the IP pools is actually new since that proposal. So like, are we thinking like IP, like IPAM
IPAM
cluster
pool
pool,
is
V2?
IPAM pool is for just you can say like which pods gets which IPs.
Yeah,
Can annotate
not-
and then
not
say,
for
but it's,
that.
yeah, I think our use case
Is
kind of.
there overlap there, or is it, because you have a sense of a pool and some, like, you know that these IPs are directly routable or
Yeah.
tunnel routable.
I would expect that information to come via the cluster mesh, because today when you do Cilium cluster mesh connect cluster 1 and cluster 2, there's like this cluster mesh. We try to do the API server. There's an API server running for this cluster mesh, and it gets all the information, all the CIDR information from that. Like my thinking, and correct me, like is you get that information from your cluster mesh, from the other cluster that this is the pod CIDR, and then behind the scenes, if I don't know about the feature you are talking about, if we can update your map that this is the pod CIDR I'm interested in, where I need to traffic to be encapsulated. So nothing to be by the customers here. Like I need it to be completely managed.
One of the motivation for this actually is like in terms of basically in terms of multi-cluster world.
Yeah.
People don't plan their
Yeah.
IP addresses in advance and they end up connecting them, right? And this is one of the reasons of they have to go for these TO or service mesh kind of thing, which can do this kind of translation across cluster, right? And if we, but the cluster mesh, your assumption is, hey, you already have planned it, you already have Cilium running and all that, but that's not the world, right? People already deployed things, people don't plan, people don't know when they're building these things. How do you connect services in this fragmented IP space? And that is the key motivation, right? So if you can, what Neha is saying is like, if you can leverage the metadata information you have for different clusters, what their IP ranges are, and when you know that, hey, this cluster traffic is going across different cluster, what the IPs it translate to, should I do a tunnel mode or not? But the meta point, the customer, they're looking for that, hey, that kind of flexibility, right?
Is
Seamless cross clusters.
Yeah.
is overlapping pod IP ranges part of this or not? That simplifies the problem drastically.
Yeah,
I mean, I'm sure maybe.
today cluster mesh does not, right? It expects a flat network.
Yeah.
So
Cluster
that's,
mesh assumes-
for now.
Again,
we are
it's
okay.
like a simple, like it's
So let me ask,
one step
the
at a time.
realist, yeah, for now flat is fine, but when very soon customers will ask for that, hey, I need overlapping database as well. But at least if we can
One
get the
challenge at a time.
one challenge, I think we have a,
Yes.
Yeah, historically cluster mesh always assumes
This is the flat
connectivity
network.
between nodes at least. And it does everything on top of that.
Are you guys seeing people interested in overlapping? Because it's inevitable given like, oh, I have this
Well,
joint
yeah,
set up.
Yeah.
well, you
that's
kind of
what
mentioned
this
like, oh, I
is.
deployed this cluster, and oh, I
Exactly.
deployed this other cluster. The teams didn't talk to each other. Like, okay,
Right.
well, now do I have to renumber the IPs? Or, like, it's another operational.
Most of the time when you have overlapping CIDRs, people end up bringing up a gateway between.
not south, yeah, then
uh,
probably, yeah.
And is it the similar how Istio solves it by the gateway approach, or how, or they always get to the traffic? How they handle it?
They-
Istio, like how the service mesh handle this kind of thing, right?
I think it's get through gateway.
To the gateway.
Yes.
So there is no
But it feels like different in that all cross clusters like through gateway.
I see.
So it's kind of implicit in the architecture.
Yeah, I mean, what we're looking for here is like native
Correct.
experience that you have within a single cluster, translate that between
Correct, exactly.
clusters, right? Yeah, with gateways, you kind of lose that. You kind of
Exactly.
have to assume, how do I get the traffic to the gateway?
And then gateway becomes a small part, so eventually, if you have too much traffic in there, right? But I hear that like if it's an overlapping thing is like much harder to do. But even without it, right?
I mainly asked that just to either rule it in scope or out of scope, so we could.
We can keep it out of
Yeah,
scope.
we
for
can
now.
keep it out of scope.
Like,
Like,
it's an interesting discussion, but I'm sure we can stay in a
I
whole.
solving the hybrid itself, I think will be a very big work in itself. So yes, out of scope.
So with cluster mesh today, like we expose a set of a config that
Mhm.
is kind of written to etcd,
Mhm.
and other clusters discover that config. And
Yeah.
that includes things like cluster ID,
Yeah.
cluster name,
Yeah.
things like that.
Yeah.
So we could enrich that with node CIDRs, pod CIDRs, service CIDRs.
Yes,
I
And
don't know if
then-
we already replicate some
I think
of
port cider you already have it, if I'm not wrong.
that. Okay, but if we do that, then maybe I keep drawing parallels between high scale IP cache and cluster mesh, and if we can merge both of them together to
Yes.
populate this CIDR, that you can have dynamic encapsulation based on. the
Exactly,
targets.
once you get that information from your cluster mesh config, and then if you can enable your that
But-
config inside the feature number.
But if there's connectivity between these two clusters already, do you need additional?
It is only node connectivity. There is
Not the
no
pod
pod connectivity.
connectivity.
So
Pod
the
connectivity
way
is
we
still-
have built our overlays, they are kind of islands. The two overlays can't talk to each other.
And also for scale purposes, even if we want to do VNet peering, we cannot have a mesh of VNet peering between.
You don't like every IP changes eating there in any cluster.
We would end up with a hub and spoke VNet, hub cluster, VNet spoke clusters with like some gateways running.
You would still need to have a node connectivity because eventually your packet is getting encapped, right?
So node connectivity will be to hub cluster.
He was talking about
more than whatever the VNet peering limit is. Like you have like 10 to 15 clusters, and all the 10 to 15 clusters needs to be connected. Then you need like one VNet peering everywhere.
I mean, in
You're talking
inter-region,
about something-
intra-region, if we have to like go with the.
It's talking about something like more than, but for the shorter term, I think the scope is like to have the hybrid routing.
For the scope of this discussion, we have some form of node-to-node connectivity.
Sure.
So
To be
it's
able
really
to encap the
just,
traffic.
so it's really just like it sounds like we either have the pod cider for each. So it's per node that or it's the whole cluster.
Whole cluster,
Whole
whole cluster pod cider to be extended to.
But then, like, let's say I'm on one node and I somehow receive this information from another cluster. I say, okay, I now know that this entire pod range is accessible via where?
So I think you are talking about ingress, right? Like coming from cluster B to cluster A, and the traffic will be like encap, and the node should decap the traffic.
I was thinking transnet, but I was thinking I want to send to another cluster. How am I going to make this decision? So I know that the pod range.
That's your
Pod
feature,
sitter.
right?
That's your pod sitter.
Also, not to complicate things, but in Azure, in some configurations, there might be more than one pod sitter for a cluster.
Yeah.
Like we support having node pools that are in different subnets.
Yeah.
So it's not just like.
I think
one
sometimes we should turn a blind eye to this and
Right.
really shouldn't.
range.
Like
Clusters.
pod sitters, it could be part of multiple clusters also, so you should.
Yeah, it can be a
support
group of
multiple
pod sitters.
Group of pod sitters
But-
as part of the.
But I think
There's
what you're
node-to-node
asking is,
connectivity, right?
when a, sorry.
Yeah, node to node, sorry.
Between two different clusters, there is node-to-node
Yes,
connectivity.
Yeah,
there is,
yes,
there is.
So as long as we take the packet and hand it over to the node with
Yes.
the right encapsulation,
We should be
it
able to
should go
decap
to
it.
the right
Yeah.
destination.
I think his question was, how would you know this pod sitter? I know that this pod sitter belongs to my second cluster P. Is that, but how would I know whether to encap? I think maybe you should expand on this IP cache feature maybe one more time.
Yeah, so primarily the reason that feature was built was how do we do cross-cluster policy enforcement and scale IP cache beyond like 1 million entries, right? So if you have a lot of clusters that are meshed together, you're populating IP cache from every other cluster's identity information, and every node has that information, right? So the idea was to, what if we get rid of IP cache and encapsulate that identity information into the packet itself, and then decapsulate the identity information on the destination node and do policy enforcement.
Yeah, I think we're
That's my
cutting
read on
a
it.
lot of corners on the explanation, which makes it difficult to. So like, I mean, I think what you touched on about saying like, oh, IP cache with 1 million entries. It's like if you're trying to tell every single node about every single IP of every single pod anywhere in any connected cluster, you can see like that's just not feasible at all, right? Then you've got like ingress policy versus egress policy. So ingress policy is generally a lot easier because if you can trust the source to give you the context about what labels, what pod, what namespace, something like that, then you can say, oh, okay, I trust that the VXLAN packet said this is the identity. I can now do policy enforcement because I know where it came from, I know who that is, I know which workload I'm sending it to, I can do the full policy calculation. Egress is a lot more difficult because you don't inherently have the information about the destination. So to be able to make that like decision, then you need to somehow gain that information. So either you learn about every single IP, that's a model.
Or you package
But
your
the
own
IP cache
identity.
thing is like doesn't support the egress policy. Only supports the ingress policy because it just receives the remote identity. The egress policy, like it doesn't. I mean, if you have a policy for egress with IP cache, high scale IP cache, it doesn't work on the source.
Right. So high scale IP cache says we're not going to learn about every single remote IP.
So it doesn't work on the source. The egress policy is one.
So, but sorry, how do you then do that? Do you encap it with your own identity, source identity?
Yeah, this is the source identity that's encapsulated so that the destination can enforce the ingress policy.
Destination will be enforcing.
Destination can enforce the egress policy. Let's say I have an egress policy. Sorry, and pardon, I'm not able to understand it. I have an egress policy of drop my traffic which belongs to egress IP A.
Yeah.
Now I don't have that. I don't know if this egress pod A, right? I don't have that pod A IP because
the
the
source
I
IP.
High-scale
don't
IP
have
cache doesn't solve for the egress.
Actually, yeah, I think that's one of the constraints.
That's
They
the
just-
It
they
does not solve
just
for the egress.
decided not to solve that problem.
Yeah.
So
Limitation.
for egress, you need to do FQDN, and then for ingress, you can do.
I think there's maybe a little bit of a strong philosophy behind that of like,
I read
if something
somewhere-
is compromised, then it can send whatever it wants, but like it's your responsibility when you're
So
receiving stuff.
so my egress policy will not be applicable here. Even if I have a egress rule, it will not.
Yeah.
It's not possible.
So that's a limitation they mentioned. I think it's
Not
mentioned in the CFP, I
solved,
guess.
should we say?
Yeah.
Yeah.
Egress policies not work with iScale.
I mean, maybe you could say like, maybe you just say, well, for egress, you'll do 2FTDM policy, or like maybe you'll
No,
come up with some
that
other
will not
solution.
solve for the cluster mesh, because then that's a like a
Yeah.
feature.
I mean, yes,
Can
that's
we
correct, but
Can we not differentially get the identities for the egress policies for the pods? We have the policies of that. I mean, again, there is no upper bound for it.
So the question is like, how do you know which identity you're sending to?
Yeah.
So currently in Cilium for egress policy, what you'll do is you'll look up the IP. The IP, like there's a map that says IP to identity. Now you know exactly which label, which namespace, and so on. I mean, it's pre-calculated in user space, but basically in the data path, you'll be IP to identity, and then there's an identity to allow or deny. And that's your policy map. And so then now you can make your decision on egress.
So that's-
policy, right?
so I
So
think
that's
the
relying on
Yeah.
every
Idea
single
there
item.
is- Idea there is, we will only, so it's a one step up, right? In the user space itself, if we can only have the identities from the policies, derived from the policies on the labels you are interested in, get the identities for only those, and then insert only those into them.
But how do you look that up? So you've got a packet, you're sending a packet to some remote cluster. How do you know which identity?
Which means then we will have to take some kind of like, I think we will have to do some kind of network policy in a centralized location, which is very bad.
Yeah.
And then we have to then, because at very high scale, this will become a problem for us too. You will have a centralized control plane for network policy, taking away from Cilium engine.
Yeah.
Then this guy will have some kind of XDS server sending these data back to Cilium agent.
I'm a little less concerned about the control plane thing because, yeah, I mean,
Okay.
probably there's some
Yeah.
solutions. I'm thinking like you have a packet, you need to figure out what, like, who am I sending this to?
Right.
And how are you going to enforce policy? Like, exactly how do you want to constrain that? Do you want to say it is this label attached to a pod in a remote cluster, and I can use that to then enforce that policy? And like, is that something you're looking at the back and saying, somehow this packet has contents that I can use to make that policy decision to this remote thing? Or do we have some other egress? Is egress policy in scope here? And
It is in scope.
What's the?
So one,
It isn't. It
It is
isn't.
in
one
scope.
clarification.
Yeah, go ahead.
So there are two distinct work streams, I guess.
Yeah, I.
Yeah, that's what I'm saying. We are losing
We're talking about
Yeah,
the
the
network
policies,
policy.
but I
I
think
want
we
to
are
bring back
interested in
only
that
to the
hybrid
connectivity
routing.
right now.
Oh, yeah.
getting-
We are
This is probably an interesting topic.
Yeah.
No policies.
Yeah, so
Policies, whatever the limitations we have, I think that
Yeah.
works for us, but more interested in the hybrid routing.
Yeah, he's
How
like,
can we,
I wanna
how
bring
can we
it
make
back to
decisions? So
connectivity.
we can make decisions based on the destination pod setter in the BPF. Say if the pod setter is this, use native routing. If
Exactly.
the pod setter is this,
That's it.
then encap the packet.
yeah, so again, just to clarify, high scale IP cache's goal was to improve the scalability of IP cache. Right?
Okay,
I'm saying some design aspects of that
got it. Can
we
put
could
them-
borrow probably
Yes.
to kind of determine this dynamic encapsulation.
Okay.
But if we want this full seamless experience between clusters, then the best we would have is the KV star mesh, cluster mesh kind of solutions, where it would not scale to like, I don't know, like
More than-
having 4K node clusters, and then if you mesh 256 clusters, it's going to fall apart, right? But I guess that's a good starting point. If you
We
want
are
to
okay
mesh
with
just a
that.
handful of
Yeah.
clusters.
Yeah.
But if you want high scale, then we'll have to get
Yes,
into these smart
that's true.
solutions. So
That's
No,
true.
starting 150 clusters, connecting 150 clusters, how many pods we're talking per cluster? How many node clusters?
So are you asking what's upper bound with KV
Yeah,
star mesh?
yeah.
So I think there was a talk last time at CiliumCon where Ryan tested the upper bound for KV star mesh. I think the scale was, they had 50K pods between 255 clusters.
50K total pods.
Yeah, 50K total pods. And I think in their experimental setup, HCD starts falling over at that point. But it's really dependent on so many parameters, your
yes.
pod churn, identity churn.
Your policies, your services, it depends on
And
all the
KV
things.
Store Mesh here is running on customer workloads like nodes.
KV star mesh should run as a part of your control, your Cilium control plane. But
I was
Is it
hoping you would
possible
say
to move it-
50K nodes are not
Yeah.
pods.
no,
50K pods is less. Is it tight? I have to look into this. Is it tightly integrated? The KV Store Mesh is in.
Yeah.
Cilium agent, is it not, it's not possible to
KV
take
store
it out?
mesh is a separate deployment, right? It's part of the API server.
It's part of the custom mesh API server, right?
Yeah.
We were also thinking of if we can take that and run it on our underlays.
Yeah, you can
Instead
manage
of-
it.
Yeah, something.
It's like a Cilium operator.
That way we have a better control on the scale.
Could do that. Like,
Yeah. So we're not
But-
like
but
at the
even,
customer's
you know,
mercy.
even then, want to understand what did you mean by at 50K the NCD was going up?
I mean, it depends on his experimental
Okay.
setup. Let me pull up his slides.
Right, so I
So
think
bringing back to the connectivity.
Yeah.
So-
scaling back. Scale we can get by switching off some features. Let's suppose we keep network policy out of scope for time being.
Mhm, mhm.
Then ingress policy, ignore it for time being. Then we just have to figure out how to lock at a service level, right? If we have the connectivity built.
Yeah, so I want to bring it back, the discussion only to purely on the connectivity, how we can maybe, Hemant, if you can share this design of high scale IP cache and have what we can take it out from there.
So what is the cluster IP pools V2 feature used for today? Can we have like, hey, this is this cluster's IP pool, and then can we have, these are the remote cluster IP pools, and then based on that, we could probably decide the device we send the traffic to.
I think it was intended for multi-network, right?
This IPAM pool you're talking about, that's for multi-IP pod, I guess. Like,
Yeah,
you can specify like pod, you can have pods on the cluster and then say annotate the pod, say I want IP from this pool or anything. So you can have the CRD defined.
Okay.
And each
That's
IP
not
pool
relevant.
can have.
So yeah, I would say like it's trying to solve that, like how do you have an IPAM mode that just
Yeah.
has multiple different
different subnets.
pools that you can allocate from. So it doesn't solve the other problems.
Yes.
Yeah.
It's just that there's, again, like there's a conceptual overlap with another feature.
But
Because
but I
like
what-
when you mentioned like
yeah,
pools.
Nega proposed, right? You don't need CRD. So if the cluster mesh API server itself learns all the other pods it does, then you can just configure it in the
One clarification. This is 50K nodes,
Okay.
not 50K.
That's a little bit
That's
of,
okay.
yeah.
It's 254 clusters, and the test was made with 200 nodes in each cluster. And all of them have hollow nodes, but it's still representative of the scale that cluster.
And
API
50K
server-
pods, one pod per node,
50K nodes.
50K
nodes, but no pod limitation.
no pod.
I mean, this is no
Just
way like
the-
fully representative, but like this is
Just the system parts, I think.
I'd imagine what this is like from a testing perspective, how do you try to simulate that level of scale? So you run one instance of Cilium and then you put a bunch of resources into the side that like simulate that it's learning about all these other clusters and so on. And then you observe that one instance and you say, how does it respond? That's my guess. I mean,
Yeah,
definitely,
so this-
definitely watch the
Yeah,
presentation.
yeah. So this basically the whole test was to measure the scalability of KV store mesh in comparison with the traditional cluster mesh. And they were measuring the endpoint propagation latency, but from one cluster to the other. So this basically was with 50K nodes, their experimentals. Like I think the range was anywhere from half a second to 30 seconds was the propagation latency. But yeah, there are a lot of assumptions here. But if you have an upper bound on what's the number you want to hit, I think you can go pretty far with KV store mesh.
This is n factorial mesh between all the clusters, right? It's basically. It is
Full cluster mesh, yeah, full mesh.
So
Full
the,
mesh.
the good, the benefit of KV store mesh is you get one consumer from each cluster reading contents from other clusters.
Okay.
Compared to the traditional cluster mesh where we had every single Cilium agent connecting to every other HCD. So that's sort of like an N cross M updates on every pod update. But here you would almost have N plus M updates because you're only having one KV store mesh controller getting all the updates, writing into the local HCD. And that HCD fans out updates to every local agent. So from a remote HCD perspective, it has its own Cilium agents connected to it, plus the total number of KV store mesh controllers that are part of the mesh. So it's N plus M updates.
So this is control plane. How can we bring this to the data plane?
Yeah,
Right.
that's what I'm
So
saying.
if we can bring this like hub and spoke fan out mechanism to the data plane itself, where we have like the centralized hubs which are taking care of like updates control plane and also routing the data plane to the other clusters, so they can be the VXLAN terminations, right? essentially like extending your L2 network through the hub cluster.
Sounds like a logical extension of K-style mesh. Like, as a way
Yeah,
to discover that
yeah,
information.
yeah. I mean, I think there's probably some IPAM assumptions we want to make.
Yeah.
Like, so like, are we assuming one pod sider per node, for instance?
Not per node, per cluster.
We cannot guarantee it.
I mean,
Cluster.
can't
Because
guarantee
the reason this comes up,
You can
right,
consider
is like,
per node.
So
like,
what is
how does an
today-
agent
what is today
decide where
KV
I'm going to
store?
send this?
So today KV store, can it learn multiple pod seeders per cluster?
It does not learn about, it assumes fragment. Like it assumes,
So
Right.
we should take that assumption that we can have multiple pod seeders.
We can have
per
multiple
cluster.
pod sitters. In Azure, the assumption that I think makes sense is each node is part of exactly one pod sitter.
Yes,
Does that make sense?
but yeah, cluster for cluster mesh, it's like, yeah, we can take multiple pod seeders.
I think Joe is asking a fundamental question. Oh, it says I cannot share the screen, but I think you are asking, okay, we have encapsulated in one cluster, but how do we send this encapsulated traffic to the other cluster? How do we
Do you just
make a decision?
randomly pick a node and then that cluster will figure out how to get it
So
to the destination?
Ideally, I think we would have to have like service mechanism, right? Either you send it to, like all the
Node
nodes.
pool. Or
Node pools, anybody in that node pool, and then they de-encapsulate and then figure out the pod IP where they want to send.
So that's why ARC helps, right? I don't understand. So when ARC broadcast for that specific pod IP, so it gets response from one of the nodes, right? So it finds the path. So next time when you send IP traffic, the tunnel will be set only for that specific. That's how I think.
What we're saying, like a flat L2 domain for every connected cluster, or what? Like,
Right.
How is this
Yeah, I think
doesn't
okay.
scale, right?
Okay, flat. Yeah, L2 should be connectable. Yes.
Yeah.
Otherwise, it cannot.
You
It cannot.
can't-
It doesn't know
you
which
can't do
node
that
it can
at
connect.
that scale, right?
So you would
Yeah,
have to
don't
have
scale.
some kind of NVA in between, which has the view of all the pod siders. That is running in the hub where all your encapsulated traffic comes to it. It takes a decision on where to send next.
No, that's a. I would
Killer.
try.
So now
That's-
it's a
that was
gateway.
the.
It sounds like we
Exactly what we thought.
Yeah, that platform.
Right.
Maybe a set of nodes. If it can learn a set of nodes, then yes, then you have a second order of proxy. No, but set of nodes versus single, like no.
VS are never single, it's like plus one.
So I don't want to cut the discussion short, but we also want to do the making DNS.
Yes, and then we don't want to get between people in lunch. So that's always dangerous.
Maybe we should have a.
I mean, I feel like we're getting to a
Yes.
next question we need to solve, at
Yes.
least. Like, hopefully that's helping us.
So,
Because I think something to preface is, we also want to do very high scale testing. You might have seen the blog from Istio. So.
Yeah.
Your blog from Istio.
Put those fingers down.
we are here to do the writing the Cilium scale. Help us get the scale.
No, I mean, that's a problem we want to solve.
For writing.
They are,
blogs every week.
they are pointing back to us, right? Like, what is the scale you support?
I
That's
think,
what-
I think an action item from that blog is, so the blog kind of does an Apple storage comparison.
Exactly.
That's true.
So like we're all on the same page.
Yeah.
But what they've done is they took the
Cherry
defaults from Cilium. They took the defaults from Istio, whatever.
Yes,
Then did a comparison. I think we have a ton of features that we can enable.
exactly.
So maybe we should come up with a performance profile. We already have a scalability guide. So we convert all of that into like a help flag, whatever. Assume that you have the latest kernel. So that every time somebody does a benchmark, we give them the best possible settings.
Let's do that, Joe, and we are fully supportive. We'll co-author it. We are ready to co-author it from Microsoft, crediting it from Microsoft.
So how did the discredit happen?
So it was an internal discussion between.
So we didn't agree yet.
But we didn't
Yeah.
see the discredit.
We don't see that. Because
Yeah.
it was,
So yeah, it's not bad.
We got this on the recording, right? Take it to the.
but there was a question, are you doing it as a Microsoft employee or are you doing it as an ex-Solar? So that was the question we had. Yeah. Anyway, so we don't have to go there.
Whatever the data in there is like, we're not like, saying the data is wrong or right, that's the person.
Yeah,
who did the testing.
methodology is
It's
wrong.
about,
I mean,
and like Hemant is saying, it's a good step back to us also to make sure that we are investing in, and the community into the scale, because people love Cilium and now they want to use into their scale enterprise clusters. And that's a challenge we should be solving it together. I don't know if with Google it's the same.
Yeah,
If
we
it's
are
the same challenges or not.
super interested in getting Cilium and the base data structures, algorithms to
Perfect.
scale like 10K, 20K. Like
So
that's
we
like-
are together on it. So
I think you work
invested.
like Georgie,
Yeah.
Georgie, on this. Yeah.
There's also a talk about benchmarking at Cilium and eBPF Day tomorrow, and I think Ryan's working with the speaker to try to integrate some of that into CI and like do a project with them too. So
Yeah, that's an interesting thing. I was talking to George, like, it's always useful to have benchmarks that have like very representative workloads, because sometimes you micro benchmark something to death and it's like, oh, well, this one branch, like, get rid of it. Like, it's like, but in the context of like a realistic workload, like, it's kind of washed down.
we do have you have Wednesday Cilium dev community. I don't know, just an idea. And in my opinion, we should have a very dedicated slot for just for the scale.
We have a
discussions.
scalability.
So there is a once a month.
So you should join
SIG
that.
scalability.
I think I only share joining from my side.
I don't even know that exists.
I think Bill also joins, but I usually keep forgetting that last Thursdays.
So maybe we should increase the instead of once a month, maybe have it bi-weekly.
What do you think, SIG scalability, Chair?
Yeah. So based on the attendance we've got, based on the topics we've discussed, like 1 month cadence seemed great to us.
Is it? Okay.
It's mostly like me and Marcel coming up with topics on the fly. So please join.
No, we want
I
to.
think this-
Like, if cadence is the problem, that's an easy problem
Yeah.
to solve, right?
Yeah,
We can.
I think
So-
this group is definitely interested in the
Yep.
scale and solving the
Yeah.
scalability
And
challenges. I think
we've-
we didn't even know that
We've
existed.
constantly been discussing the CI tests. Like right now, there is a 200 node, 500 node CI test that runs upstream. There's some Gideon benchmarking that's happening. As
Yeah,
a part of that.
if you're curious, like, we have results from like 5K and above. And, I can see if we can share those, because
But
we've
does
been
that-
benchmarking it like,
5K nodes?
Is that the upstream?
5K nodes.
Was it
But
able,
the
we don't
upstream-
even able to run 5K nodes.
So the problem is they're using like API server is 96 core, right?
No, we're not cheating all the time. No, I have to see. I have to
There's a huge
see.
problem for us.
Yeah,
Cilium
but
is
I have to
default.
see, but I think we're very interested in sharing this, like, hey,
That'd
we've
be
tried to
awesome.
like.
I think there's a
really
lot of
push it.
general.
Yeah. So like, get the data out there, kind of understand how it works.
So one question is
So I'm
the
assuming, is
endpoint-
that from the fork or is it like all
The
upstream?
fork doesn't really, in matters of scale, it's all mostly upstream.
Upstream.
Like, I don't think there's anything, Mark, correct me if I'm wrong, like, there's not, it's basically vanilla.
It's pretty vanilla, yeah.
Yeah, there's like almost like nothing.
There's one exception to that.
So there are
That'll be
some
super
variations.
helpful for us to know, because
Yeah.
if we are missing any knobs, then we'll
Okay,
publish on that.
someone take an AI on the Google side.
I think for endpoint slices, there are some variations on what the default patch modes are. So they're still not
I see.
standardized on whether you want to do FCFS or identity-based patching. I don't know what you guys are using to benchmark. But
Yeah,
We did the test, I think, from our end. We found FCFS. I asked like Google, found FCFS performs better.
Yeah, let's follow up, like,
Yeah.
we'll just
Yeah.
publish like the script that run, I mean.
So I think like
anything
that was actually the blocker on making Cilium endpoint slice stable, was we were like, okay, well, we
Yeah.
have two algorithms, like what are we actually trying to?
Okay,
use,
that's
right?
useful to hear.
Which was, I think, 6 months ago.
Okay,
So feature freezes in 1 month. If you want to land it for 117.
Yeah.
we should
I
come
thought
up
like,
with-
I don't know, maybe the current update, the blocker is one of the CA tests or some end-to-end test is not there. That's the blocker first.
Yeah,
But I think they
yeah,
did
that's
it on
not-
FCFS, I guess, based on what I get from Share.
Isn't there also like a threshold beyond which like FCFS is
Okay.
more efficient, and then before that it's all identity?
I think if it was
It's based on
we'll just make the decision, we would have just made the decision. I think it's a little one.
yeah, let me see if I can get that resolved. We might already have the data. So I'll send something to those folks.
Maybe we can have, we can use the SIG scalability more. to
Yeah.
get those results.
Yeah.
Yeah.
And there's a Slack channel, so like you don't have to wait for the monthly meeting.
Yeah.
You can schedule another one. Like if you guys just want to meet, like
Yeah.
we can make that happen, right?
Yeah, so I think that's like the next thing is to move it to SIG scalability.
So I'm gonna cut the discussion off now.
Awesome.
Okay.
That covers the open.
Word of
Then
warning,
we should
so
have a single customer show.
We have a presentation,
We should create one.
but we only have 20 minutes. We could also see if the lunch is already here. And then move it after lunch. Usually if you're like,
Can you cover in 20
having a
minutes?
presentation and there's a lunch attending.
I actually, what's meaningful for that is to have the expert discussion because most of this.
So it's up to you guys. I don't
I
know.
got
who-
it.
You
I
do it
can
in
do a
20
paper
minutes.
overview,
20 minutes is fine, but I think like we have like a few other things to talk about. Like through HA itself will take 20 minutes. Then I have few things to talk about as well. So that's why I'm like, maybe you can go through HA now. Then after the lunch, we can cover.
First,
the
let me
rest
see
of
the lunch is here. So.
Okay.
Let's cover just it.
I'll probably get going. I
Yeah.
think I covered my favorite topics just.
Yeah, scale, I think, yeah, just to
Yeah.
summarize what Nang is saying, like, to us, to block, I mean, at least for us, adoption of Cilium in AKS, the main blocker is the scalability.
Yes. The
And
API.
that's what I excluded in the breakfast. So like, we wanted that Cilium to scale, then I think we will migrate all the clusters to Cilium. That's the main blocker.
So lunch is here.
Okay.
If we wanted to get lunch first, I'm gonna do it after.
The speaker cannot eat,
Yeah, yeah.
but we can eat. No, I'm just kidding. But
Fine. That's
do you want to do 20 minutes?
20 minutes.
Just hit it.
I mean, HA, but can we continue after that?
Yeah.
We have an hour and a half.
Okay, all right, let's just
Yeah,
stay
let's
with
go
the schedule
for
then.
I think most of the things we already discussed, so we want to straightly go, but I can set the context. What is DNS Proxy and what the CFP does. So we already have a CFP also open in the design CFP repo. So currently today, like Cilium does this FQDN filtering with the help of DNS Proxy, and this DNS Proxy, I mean, it helps to, so it helps you to build, I cannot move to the next slide.
I don't think you can do it from here. You have to switch to it.
Oh, yeah. Add it to team. Yes. Just give me a second, sorry. Oh, yeah, it's slow. Cilium FQDN filtering, I think most of you already know, just I'm saying like, so you can, customers can define network policy based on the DNS names and doesn't need to care about worry about the IPs. So Cilium manages like renewing the IPs on the DNS request and then update the policy based on the new IPs or stuff like that. So this is how it's implemented, and so you can define a Cilium network policy and then define rules, DNS match pattern, say like I wanted to allow only star.example.com, like subdomains under example.com. And when this rules present, like rules.dns.match button present, the agent will create an IP table rule to or BPF redirect rule to redirect the traffic to the DNS proxy, and then the DNS proxy will forward the traffic to the DNS server, and then it can update the mappings to the Cilium agent. So today, the DNS proxy is part of the Cilium agent, as you see, and so the DNS request gets redirected to the DNS proxy inside the Cilium agent, and then it forwards to the DNS server. And once it gets the response, it updates within the Cilium agent because it runs within the Cilium agent itself. And once it's updated, forward the response back to the pod here. So the problem with this approach is like if the DNS proxy goes down here, right? So if the DNS proxy goes down, sorry, the Cilium agent goes down, the DNS proxy also goes down. So which affects all the pods which has the CMP enforced Cilium network policy, not be able to resolve the DNS request because all the request is getting now redirected to the DNS proxy, but the Cilium agent went down, and these pods have this DNS resolution impact. So this can affect all customer pods who is like relies on this network policy until the Cilium agent comes up. So that's like a very common scenario for us because we always upgrade Cilium agent for any patches or CVs or even for major upgrades we do at the time that agent goes down. And then this impacts the DNS resolution for running pods, existing running pods, right? So how can we solve this problem? So that's a CFP is about like how can we make this DNS proxy highly available even for upgrades. So this is like an I think we inspired from Envoy. So like Envoy is like moved to a separate daemon set, And even if Cilium agent goes down, the L7 policy is still enforced through Envoy since it's running as a separate daemon set. So this idea is like more kind of derived from that. So let me expand this.
So I'm curious, is this, because this is like, the Cilium agent is this like big thing. And then this seems like it's like commingling that data path, the control plane. Are there any other pieces that are sort of kind of this intermingling?
So one thing I want to clarify here. So when I say HA, like HA here means only resolving the DNS request. So
Right.
still, if you change policy,
It's talking high level.
I'm talking like generally speaking, because I know
You're
like,
saying outside of.
yeah, outside of this, it's like, does the project have other things that kind of could benefit from that separation? I'm just asking because
Because L7
like this one seems like very clear.
I mean,
Like-
probably everything L7, no?
L7.
Everything within.
Yeah, generally L7.
Yeah.
Like anything.
Has that been moved out or is that still?
So
part of the
you can deploy Envoy as a separate daemon set, which
I
you
see.
can cycle it separately, and then Cilium will still configure it.
I guess that we're leading into is like, should ENS be a separate thing or is it packaged as part of this data plane thing?
So I think what's
Like-
interesting from a DNS perspective is specifically this QAPDM feature and the way that it informs the policy engine to be
I see.
allowed traffic for a data connection. So you're proxying the L7 of DNS to learn the mapping,
Right.
and then somehow doing some policy calculation,
Right.
modified BPF maps, a bunch
Yeah.
of stuff that Cilium agent is specifically.
I see.
And then the consequence is when there's a data connection to the actual destination, the actual IP that traffic.
Yeah, that
Exactly.
doesn't go through. Yeah.
That's none of that's proxy, but it's reliant on the
Right,
previous
right.
calculation, right? So that's what makes this particular problem a bit
I see, interesting.
It's different from Envoy, where it's like, oh, you just
Yeah,
get
just
all of this
dump it.
traffic goes through
Yeah.
the partners where it.
So, yes, we have two parts to this, right? Like for the CFP part, do we have any items that we need to get consensus on? It's the first part.
Yep.
And once we resolve that, we can also maybe use this forum to discuss, like, how do we make it truly HA, and make an external component also populate the IP cache and have the same policy enforcement posture. Okay. So, yeah.
maybe a little short discussion on like what is STP, and then we can go on gRPC contract, like what we have to conclude that. So yes, we are just separating the DNS proxy as a separate component now, and it's still the flow is same as like the Cilium agent DNS proxy. The only difference here is like kernel now load balance, because like two DNS proxy listening now on the same socket port using the SO reuse port socket setting, and then the kernel load balancer between the standalone DNS proxy and the in-agent DNS proxy. The request can be forwarded to any one of them. Let's say consider it's forward to that STP here. Let's call it STP standalone DNS proxy, and then it checks first whether the DNS request is allowed to resolve or not. So for that, it needs IP to identity mappings. So what we do here, we read from the eBPF map, IP cache map that the STP reads from it, and then populates it. So now it knows what is the IP to identity map, and then it enforces that. So if the DNS request is allowed to resolve, it forwards the request and then gets back the response. And once it gets back the response, now before forwarding to the pod, it needs to update the Cilium agent. Okay, this is my DNS to IP mappings. So Cilium agent once updated it, it gives an ACK, and then the STP will forward the response back to the client. So this is exactly same as like the only difference here is how kernel load balances and how we are retrieving this IP to identity mappings, because we are STP relies directly on the BPF map here. So hopefully no questions, I can move on.
But I think also critically, you've got policy plumbing now happening.
Yeah, policy plumbing is
Like
happening.
like this Unix socket gRPC thing.
Yeah, update mappings. When I say update mappings, so update mappings is like kind of sense the goal state, and then Cilium agent will be like plumbing the policies. So
Is this an existing API or is this?
It's part of the CFP.
I see.
So
Right now, it's all in process.
Right.
So it's
Yeah,
just a
that's what-
function call.
Yeah,
It's much
so
easier.
this is not
I mean,
true
it's
HA as like what Hemant mentioning. So here HA is just like making sure the DNS request is resolved. Still, the policy plumbing cannot happen without the help of Cilium agent.
Right,
If Cilium
right.
agent is down, we cannot do it. So if some
Right.
customers change the network policy and the Cilium agent is down, then those network policy may not be enforced at
Right.
that time. So just make sure the existing parts, whatever the existing policies, is continued to work.
Right. because
and it's even maybe a little more than that. If you make new DNS requests for
New DNS
IPs, then it's not going to figure that out either.
Right.
So it's now like
good as we
it
can get.
catches a chunk of, so like as long as you like if you did a bunch of DNS requests while Cilium Agent is up and you continue using those IPs and then Cilium Agent goes down, everything's going to continue to work. But if you start doing new resolution and getting new IPs back, then falls apart the new IPs.
Yeah, the fail static, I guess. Right. Yeah.
So this will help in case where when we update the Cilium agent, right? So 30 seconds, Cilium agent takes like 20 to 30 seconds to get up running state. So that would be a period where we expect like most, I mean, still that can be like DNS IP can change or not, but this is mostly helpful in the cases where the existing connections should not be interrupted.
Yeah, so we're heavily dependent on what the applications are doing and how frequently they do DNS and how frequently the DNS changes. And all
Right,
that stuff
right,
as well.
makes
But like,
So if you
this,
take,
it does cover a chunk of application.
yeah, so if you consider like when we move more to STP, it interacts with the Cilium agent only on two cases. One is like update the mappings. Other is like getting the DNS rules so that the STP can enforce the policy, whether the DNS request is allowed to forward to DNS server or not. So these are the two things like the STP interacts with the Cilium agent. So this gRPC contract is also about that same thing. Like we define two APIs. One is like update mappings. Other is like subscribing to the DNS rules. So let's first look at the update mappings here. So this is called by STP to Cilium agent. Whenever it receives updates from the DNS server, this is the DNS IP, this is the mapping. So this is the message for it, like gRPC message, where we include the FQDN and what are the IPs that get resolved to the FQDN and identity information, everything. So given this information, Cilium agent now gets the whole state, right? And then you can go and plumb the policy for L3, L4 network policy, as like L3, L4 network policy here. So, and also it sends an ACK, like whether it's succeeded or not. So based on this ACK, then the STP can forward this response back to the client.
This is the same event which is then used for Hubble for observability of DNS metrics.
And then this is a synchronous call.
Yeah, this is a synchronous call. So it just sends it and then it waits for a response back.
Which then you presumably when the Cilium agent's down, hits detection, say like,
yep,
don't be synchronous.
It's just yeah, it fails, I guess, like the connection will fail there. So I think this is the second one which talked about, like this is from Cilium agent. The STP has to now retrieve the L7 DNS rules so that it enforces it, right? Like whether this DNS request is allowed to resolve or not. So this is kind of because here we assume like Cilium agent, sorry, the STP will be the client and Cilium agent will be the server exposing these two APIs. So here we need to open a stream here so that Cilium agent asynchronously updates this policy updates whenever customer creates a new FQDN network policy, or if he updates the existing network policy, those rules has to be sent to the STP. So the STP will open a stream to Cilium agent, and then Cilium agent uses the stream to send these updates here. And this mainly have this like what is the DNS server is allowed to connect to, what is the FQDN match pattern here. DNS pattern represents like what is the FQDN match pattern it allows to resolve here. So you see here, like this is like it's supposed only for egress, right? The FQDN filtering is all about egress policy here, L7 egress policy, and each DNS policy will contain the what is the workload identity of the workload that allows to resolve DNS, and what is the pattern it allows to resolve here, and what are the servers it connect to. So it can be like multiple DNS servers with can be configured to resolve this DNS request. And so the key part here is we have request ID for each snapshot. So since the snapshot of all the DNS rules for all endpoints on every update, so it can be like multiple updates can be sent at a time. So the STP needs to act like what is the request, what is the snapshot it received. So it has a request ID to say like this is the request ID for this snapshot. Then the STP acts, okay, whether it's success, and then it also includes the request ID. So the Cilium server, like the snapshot is sent, we had, and then it can proceed with the rest of those.
So is there a sense that the agent is tracking the state of the DNS proxy of like which rules it's sent to?
So the primary reason why we're kind of making it a snapshot instead of sending updates for every single endpoint is that whenever you have an endpoint delete, you need to also tell STP that okay, this is a delete event. So instead, if it's a snapshot, like you can reconcile against the latest snapshot. So you don't have to care about should you track the acknowledgements for that snapshot. But every time you have a change, you send a snapshot. So STP simply updates
So it's
whatever
like
the latest
state of the
obvious-
world, basically.
So we don't need to worry about update or delete, right? If you just send the snapshot, HTTP just migrates.
Because you'll have to almost pre-implement what we get with Kubernetes, right? So. delete
Or
events
XDS.
and all that.
Yeah, I was gonna
Yeah.
say.
So it's also we are
I mean,
resilient.
the thing is though, XDS, I guess, unfortunately, they didn't like decouple the transport from the contents. But, like really, like everyone's solving very similar problems. Like it's almost like MPEG streaming. Like here's a keyframe, and here's a bunch of deltas.
But is there like, does that snapshot ever get like too large?
Yeah, that's you'll basically have to layer
Yeah, so it
delta on
depends on
top.
the max spots and the policy.
But I think the gRPC allowed limit is like way higher, the message limit, so it should be handled. Or whatever the
chunks as well.
yeah, can also send chunks.
I
So
mean,
this is the V1, so we can always optimize it, but
and like how many you need, like is DNS filtering what customers are looking for? Or is this just the mechanism by which they learn about FTDMs? They can do FTDM filtering for the data connections. So I think the latter is definitely very interesting. Filtering DNS requests, sure we can do it, but I don't know if that's like the primary thing. And I don't know if it's like, hey, please only allow resolution for these 5 domains, or these 100 domains, or these 1,000 domains. Like that's the problem.
Yep.
Is it a problem that the users have? I don't know. If it is, okay, let's solve it, sure. And then how much scale? You know, is it 1,000 rules times 100 endpoints on the node?
I
That
see.
gets to
What you're
your
saying
scale.
is like, do people care mostly about the monitor mode, not the enforcement?
Or
There are-
DNS
there are
traffic
two-
itself.
There are
They
two rules, right?
do actually. So one of our internal customers, huge workloads, right? They have like these remote Cosmos or any of these, and they need to track only which pods can talk to those Cosmos somehow. So they are Cosmos endpoints. So they'll say, hey, only these pods can talk to the Azure databases at star.cosmos.read.
Yeah, so that's FKDM filtering. It's not filtering on the DNS names you can resolve, right?
I don't think they care about
Yeah,
DNS
they don't.
resolution.
Yeah, they don't
That's-
have what
They don't, yeah, I think mostly like whatever I'm saying, right? Like the main feature is the FTDM filter. Like this is like DNS request resolution happens or not. It can be like a secondary feature, but so
But there is a different thought process there. So when Cilium agent goes down, there is like the DNS can be like spoofed in a way, sending wrong IP addresses. So let's suppose if they are not supposed to, somebody hijacked a pod, and then they are trying to get to a different, I don't know, because now the policies, okay, they have sent for google.com, they got an IP address, right? That got like invalidated. Now they are getting a different domain, but got back the same IP address. That way they can talk to that spoofed.
That is a problem. And that
Yeah.
is part of
Yeah.
the security framing around
Right.
DNS-based policy. Yeah,
that's
so
that.
definitely.
That's that. Definitely
So for
that.
that, we have
We
to
can
do the
restrict, right?
filtering by what they
Instead
can.
of star, you can say like the customer can say like, this is the request I want to do. So in that way, they are secure. So because only those DNS requests are secure.
the other aspect where the L7 FQDN filtering is important is users who use FQDN as a way to like block their internet access. So you can also exfiltrate data using DNS itself, right?
Yeah.
So this kind of is required for that.
That has a whole other set of solutions.
Yeah.
Right?
So it's lunchtime.
Yeah, have we?
You want to put pause?
Yeah, I
and
think
then-
we have few things to cover here about the upgrade and then I think the true HA part we want to discuss.
Yeah.
So we can
I
take it
feel like
after
we've
lunch.
kind of covered concepts, and then the next is like the problems that we want to solve, right? So it's probably good.
So do you want to just finish off with this or we can continue after lunch?
How hungry are people?
Okay, let's go.
I think we should get lunch.
continuing from the DNS proxy.
Okay.
So this is like a proposal for making DNS proxy highly available. We are separating out DNS proxy and running it as a separate function. So just continuing from the middle of we left for lunch, and then I'm just continuing from the middle of this present context. So to consider upgrades, first we have to consider like what are the dependencies STP have with Cilium agent, and then what are the dependencies it has. Like because like only if we resolve those dependencies, then we can consider like what order it can upgrade, right? So one of the dependencies like BPF map dependency, and the gRPC API contact, which Cilium and STP have to honor here. So for the BPF map dependency, like now the STP now directly reads from the IP cache and gets IP identity mapping, then it enforces the policy here. So one of the things I think Joe brought out in CFP is like kind of like what happens if tomorrow like the BPF map, the IP cache format changes. How like STP can handle those changes, the format changes here. So we discussed this. One solution we brought up here is like, can STP detect this change and then can handle both the formats, like based on like the key value size, based on some heuristics there. Can we detect can STP detect if this map is like using the old format or new format, and then can read based on that. So it looks like it's feasible, and for this we have to first make sure like STP can be upgraded. The new STP now is upgraded first, and then the Cilium agent, because when the new STP get upgraded, it can handle both old format and also the new format. So the old Cilium agent may have the old format, the new Cilium agent comes with the new format. The STP can have some kind of wrapper library, and based on the format it returns, it can fall back to the old one if based on some heuristic. So we can support this at least for the stable releases. I know like Cilium supports log3 releases, so whatever comes with that, this STP can able to handle those upgrades till that upgrade. That's the thing we have decided.
Like maybe the background to that was like, I see as BPF's provided like these granular APIs, which we can pretty much program whatever we want in any release we want just by like writing the code. So what I didn't want is to end up kind of locking in parts of the BPF data frame to say like, this is now stable in the API, we can never change it. And then that kind of blocks us from trying to innovate in some way and rework the way we use maps, that kind of thing. So I at least wanted to explore whether this kind of dependency on the BPF IP cache from a binary that's not the Cilium agent, as in, because Cilium agent creates the map, so it will always be self-consistent with whatever the format of the map is. But if you extend that to a different component, then how do we at least have like a plausible solution to if we want to try to change it in the future, so that we don't end up in a situation where Datapath people are like, no, you can't, or like, I want to change this, and then standalone DNS proxy people are like, oh, but we are depending on that. I wanted to at least say it's plausible we will be able to resolve that kind of a difference in the future if necessary. Not that I think we're specifically looking at changing that again right now.
So on the gRPC side, right? So whenever, I will just go quick. Like if you have questions, like need to stop me here. So whenever the new fields are added in the gRPC message, like consider like both ways, right? STP to agent communication. This is when new field can be added in the update mappings. The old Cilium agent can still ignore the fields and work with the new fields. Should not be a problem. And new fields added on the agent to STP communication. This can happen when the DNS proxy receive the L7 rules from the agent. So STP can support. Again, it supports both fields because it's upgraded first now. It can support the older field and the newer field. So if the old Cilium agent is not sending the new field, the default value will always be like gRPC assigns some default value. Based on that, it can decide like whether to take some action on it on the new field, or it can just ignore until the new Cilium agent sends it. So adding wise, I think there's no complication. And also like if the fields get removed, you can also consider this for APIs as well. If API is tomorrow, if the fields are removed from the gRPC message, how we handle, right? So until the fields is referred from both SDP or Cilium, that version should support both the fields. You can mark, that protocol follows to specify some fields as deprecated, so that will give a warning. Then once I think we remove dependency from both SDP and Cilium, then those fields can be removed in the subsequent releases, but not in the later release. If we have no questions, then I can move on to the next slide, so where we can talk about the future works. And yeah, thanks Joe, Casey, and everyone from SIG policy folks for the support so far and giving us good feedback. So I think first we can talk about TrueHA, then I can talk about the other stuff.
Yeah. So as Joe mentioned, right, like what we're trying to do with this CFP is basically for the policy that's already plugged in the data path. How do we make sure that the DNS resolutions continue to go through? Right? But what we're not explicitly handling is if there's a new mapping between an existing DNS name and a new IP or completely new names that are being resolved. The policy is not plugged for it, right? But ideally, we want to get to a stage where user defines a network policy, and even if Cilium agent is down, we should be able to enforce that network policy, right? So how do we get to that true HA where even if Cilium agent is down for an upgrade or whatever, we handle all aspects of network policy, the spec that we've committed to the user, right? So that involves somehow automatically, if Cilium or the Cilium subcomponents learn a new mapping between a DNS name and a new IP address, how do we make sure that the network policy is aware of that, right? So what we don't want to do is have two user space components parallelly writing to the same IP cache BPF, right? So that's a recipe for disaster. So can we have a separate BPF map that's used only by the standalone DNS proxy to maybe, I'm literally brainstorming ideas here. So the point here is this part, I think we have some agreement on how we should have a contract between the DNS proxy and Cilium agent. But going forward, if you want to have 100% HA, how do we do this? Like one possible approach could be if Cilium's standalone DNS proxy maintains a separate BPF map, and every time it discovers new mappings, we write them to that. And if an IP cache lookup fails on the primary map, maybe we also look up the secondary map to get the identity mappings. And with Casey's recent work of curleasing FQDN identities. So previously what we used to do is with every unique IP address, we used to allocate a dedicated identity. So that was a scalability issue because like S3 Azure Blob Storage can resolve to tons of IPs, and we keep allocating identities and memory consumption and everything. But with the new model, I think which landed from 116, we only have one identity for all the names, for all the IPs that are mapped to one DNS name, right? So what this allows us to do is we don't have to touch the policy map because the policy map already says from the pod's identity to the destination FQDN identity, we want to allow the traffic. But what we don't have when agent is down is the mapping between the IP address and the identity, right? So what if we have a secondary BPF map that's 100% managed only by the standalone DNS proxy? And the standalone DNS proxy updates that BPF map, and we update the Cilium's data path to do a secondary lookup based on some heuristic. It could be, the way it works in Cilium agent today is we have a user space cache from the BPF map. So we have to maybe build two caches. I don't know. So if we do two lookups, then we could technically enforce policy against newly resolved mappings as well. And when the agent comes back up, we can have something that reads all the new mappings in the secondary BPF map and writes them back to the primary one. And because that's done as a part of the bootstrap process and only one process does it, it might be okay.
So are you suggesting,
I think we have.
are you suggesting if SDP detects that Cilium agent is down, then it will write into that secondary
Always.
or every time?
Yeah, any mappings that are resolved by the standalone DNS proxy can be written to that.
So it'll send an update even to Cilium agent if it's present.
So we have the
Also,
right. We have the gRPC protocol, right? That we're using to actually notify Cilium agent, and Cilium agent does them, updates the policy plugging. But we never know when Cilium agent is going to go down, right? So if we populate the BPF map, a secondary BPF map, then maybe we can do.
Is it populated by STP or Cilium agent?
STP.
Okay, then if DNS request is resolved through the inbuilt DNS proxy, Cilium agent DNS proxy, then how can STP update it?
Because we're updating through the gRPCs. I mean, I'm literally exploring ideas here, but
Well, I guess like some level is maybe just you have two IP caches effectively they're just managed by different binaries. And the different binary, one just manages one of them, and you just have some way to resolve this.
Sync, we have to sync, right? Like the secondary map has to sync with the primary map. Like if the DNS request goes through the Cilium agent DNS Proxy, it has the mappings.
What I'm saying is the gRPC spec that we've documented in the first CFP already handles a way to notify Cilium agent. So in addition to doing that, we also update a secondary map. That way, SDP can continue to do that map updates even if the agent is down. So that the program, the policy enforcement program, can do a secondary lookup.
But like, what's the rationale for two separate maps? I mean, like the Datapath stays alive and everything, right? But like, why can it not use the same IP cache?
I think it's like a correctness, like you've got two different binaries writing one BPF map. So then how do you reconcile what is the correct values? Like, will they argue? Do they need to have some failover that, oh, it's my, like I'm taking action now I'm the only one responsible for this. They'll both write at the same time, but then
We'll have to somehow acquire a lock before writing, right? Or if not, we might have race conditions between.
But that's done in the kernel now. Lock and update. But I guess the concern that like this HA resolver override IP cache entries that the agent would push down are like
you could, I guess you could just say only create new entries, like don't overwrite the existing ones. Is that part of
you could, yeah. Like there's this no exist like
You mean new entries, then you cannot remove the old entries because if some customer deletes it, if you're in policy, right? Then it has to remove that.
So we're not trying to support customer modifying network policy while something's down. We're just trying to say
The new
we will
IPs
support new IP mappings
Okay,
for a
okay.
static set of network policies.
not connect policy update.
That's a whole other.
Yeah.
Okay.
You need informer in
Yeah, that's why I'm
SDP.
asking, like
Yeah, no, it's good, it's good. I think there's one background concern I would have here a little bit with just the LPM property. Like, there's not a sense that, like, you'll always find a mapping. There's no, I did an IP cache lookup and it failed because you
Match a
always
bigger
get
side
back to
of
world.
Yeah, right.
And then, like, if it falls all the way back to world, like, every IP will eventually. If there's no other specific mapping that will be considered as world.
But does the IP cache API have, what if, can we change that logic if it's a /32 prefix? Like,
What do you mean if it's especially, so like what content of the packet are you using to make this determination?
yeah,
No, I haven't yet resolved in my head whether this is actually a problem that would cause, for instance, like incorrect policy enforcement. If there's something like that, we should definitely think about it, because that's
So this is
security vulnerability.
the secondary map you're talking about is a BPF map. Right? So this should be attached to some BPF program, and BPF program attaches to some map. And what I'm saying, like Cilium agent program attaches Cilium agent as an eBPF program, right? So it does the BPF map lookup for the policy, and then somehow it needs to decide, okay, this is down or some heuristic, then it has to fall back on the secondary BPF map. So the second, what SDP attaches a different eBPF program, or it's like, so I'm just wondering like how this can work here, like how this eBPF program can say, okay, now fall back to the secondary eBPF map, and this program has to be called, right?
the program is the same.
Yeah.
The
Just
policy.
a map where you look up the IP cache.
So you're saying like it can still look up from the first Cilium eBPF program instead of the secondary map lookup.
It's having just saying have two sources of IP cache, primary and a secondary. But I guess it depends on if we're able to find a mechanism where we can safely update the existing BPF map. But that also starts a precedence of having more than components outside Cilium agent managing primary BPF maps. That's something we don't do today. Not sure if there are any other side effects of doing that. If, like, for example, if Cilium agent starts up and does a migration, we already write to a completely new IP cache every time. on
Yeah,
startup,
I
right?
think on startup we'll
So
basically create a brand new IP cache map. We'll sync all the Kubernetes state we need to be able to construct the BPF content. We'll construct the BPF content in the new map, and then we'll create a new data path, load all the new data paths, all the new maps, and then do the atomic swap over to the new data path.
so one of the rationale here is like most of the clients are they don't really respect the DNS TTLs, so they resolve on startup, and then they can do a connection based on their business logic 30 minutes after the pod startup. So we never know when the resolutions are happening. So if the agent is down, ideally we want to say that Cilium agent has nothing to do after a policy spec is received and we processed it. We want to say that we can be hands off. We don't, our data path does not interfere with the user space connections.
Just as a note here, like probably like 5, maybe a little bit more minutes left for this.
And another point to note is like this feature has a lot of potential because it's so convenient for users. Like no matter who's owning the service, where it's running, managed, self-managed, whatever, put in a DNS name, call it a day. So any stability to this, like I think will increase the adoption of network policies a lot. And this is the easiest way to cross the cluster boundary today. Because everything else is like a heavy-handed approach. You'll have to have components, moving identities, endpoints, and all of that. This is
So also this one works only for external domain, right? Like if you have something like service export, if I have for cluster machinery I'm talking about, I wanted cluster A to talk to cluster B through a service, then including policy cannot help in solving that. Like something like we have to, I don't know, like because like the service cancellation happens before the network policy is enforced. Right, it's supported only for external DNS names.
But resolution, it does block resolution.
Yeah, only resolution is blocked, correct? But actual connectivity cannot be blocked for the service.
I think we could definitely explore solutions to that problem.
If we dig a little bit deeper of both of them right into the same IP cache, right, under update, what would be the potential issues there? One is more number of duplicate calls to update the same thing, which will most probably be a no, but it has some performance. And you are sending one gRPC API call and also updating this, and then again, this guy updating it, right? The duplication of data. But data corruption will not be an issue unless there is a race condition where SDP has newer mappings, this guy has older mappings, and then they try to override each other at the same time. But eventually it will come back to the right mapping, right?
Yeah, I mean, it opens up all of that kind of forms, right? Like,
Yeah.
So we'll have to think about it. I'm not sure like if there are scenarios where this will be problematic, but we just don't do that today. Like Cilium agent is the only component that writes updates to BPF maps. And it's always, even with that, there might be bugs. But if you have two components in play,
We have to think
at least with two distinct maps, we can have a clear protocol on when do we restore mappings from that to the primary map, right?
So then I'm inclined towards if SDP detects Cilium agent is down, then start updating IP cache, not when Cilium agent is alive. Then there is only one writer at a given point of time. And then once Cilium agent is detected, SDP will stop writing it and only depend on gRPC.
Well, at that point, probably the SDP has to be detecting that there's a new IP cache map being created anyway.
Yeah.
So, but I'm more concerned like how it does the lookup fallback, right? Like how the BPF program now needs to know Cilium agent.
Yeah, that's a problem. Like what he described, like we will never know when the mapping doesn't exist.
Yeah.
Maybe one thing we could do is we always do two lookups and compare which is the fine-grained identity, I guess.
So, I mean, want to cover the other stuff as well?
Yeah.
Just like one final note on this one, right? I mean, like when you have two LPMs and there are a lot of policies, it gets really expensive because LPM is much slower than hash table. So it's not
So other work streams we are considering, I think this is already being opened by one of the community folks. Today, when you specify an FQDN policy, the star represents only one domain. It doesn't include all other subdomains. Like you have to, if the customer has to specify it, you have to specify star dot star dot star dot star, or like if it is star dot star dot. So it's kind of makes the use difficult here. I think we saw this proposal in the upstream as well. Can we allow customer to specify multiple domains through some other format, like star star represents like multiple subdomains. Instead, you can just specify star star dot something, then it includes all the other subdomains instead of specifying each subdomain specifically. This looks an interesting proposal. I think one of them already went a PR here, but didn't hear, but just now he responded back just before the summit. So if not, we are also interested in taking up this item. But any thoughts on this? Because I know there are a lot of things discussed here, like about the security perspective and everything. But I'm more inclined to what Joe you mentioned. Like this is only for subdomains. I don't want this for naming. I think it's also discussed about naming, like star star without dot, star star some example which includes like you can put any naming in the domain name as well. So which I feel like not required, but this is required for the subdomains, mainly multiple subdomains.
Yeah, because I imagine it's like my company foo. I want to be able to do star.foo.com or something like that, and I know that I can trust the DNS mappings that retrieve from API for that one. So that's probably like I don't think we've actually gone through a user journey kind of like here is actually what the core use cases are. I think it's just like, oh well, this seems kind of useful. We might as well put something, and now we're kind of backwards go through to figure out what use cases we actually want to solve. But like in principle, it seems like it makes sense. I think originally there was just a little bit of concern about the scale of the number of possible domains you would match or something, stuff along those lines. But at least when I looked soon after this, before this was created, I couldn't figure out any like concerning security properties. It seemed like we are. I mean, ultimately, anything with DNS, we're trusting the user to understand well enough what they're actually allowing by their policy, and encoding a network policy is going to satisfy the users.
Another point I want to mention since we're talking user journeys is so to FQDN we have an opportunity to like provide so most of the companies want to limit internet access, right? So it's a common requirement to prevent data exfiltration after a compromise, right? So we have a solution that is sort of distributed, right? Every agent can enforce the policy on that node itself instead of having to deploy like a centralized gateway. So the traditional approach would be all egress traffic would go through a gateway, and then the organization will figure out how do we update the policy on that gateway. It's a hard problem. You are maintaining mappings for the entire organization in that one single gateway. But instead, the solution here, we have a really good solution with decentralized policy enforcement. So I guess any improvement here will get a lot of traction. That's the reason. I mean, I'm seeing this at Datadog today. Like we want to use this to enforce block access to internet globally, but the reliability features are not there yet.
So yeah, just I'm closing on it one other issue, like the scale we are seeing. This right now we are in exploring it. Still, it's a startup. We are exploring. Like we are seeing like at least what we tested 1K nodes with 40K pods, and each node sending like 1,000 requests per second through DNS Proxy. We are seeing like Cilium hitting like 4 to 5 GPF, which is like kind of.
This is with 116.
116, yes. We added in both in 114 and 116.
Do you have like
yes,
memory?
We did the pprof and everything. I think it's cloning labels, probably the similar one you experience, or it's actually doing it in regenerating endpoints. So what happens is the IPs is keep on getting changed, your domain IPs, and then Cilium is doing this regeneration of endpoints for every, because the IP is getting changed, right? That it needs to plumb the policy again. So it does the regenerating endpoints, and then that's actually consumed like 2 GB of memory. That regenerate endpoint call itself consumes 2 GB of memory. We have the pprof and everything. We are trying to narrow down like what's causing it, which part of the code, or it's really the code, or like what. Like, but we are, I mean, just open an issue.
Seems like low hanging fruit.
Yeah.
Is this related to the, there was a Slack thread recently where we discussed selective regeneration, and where we want to get to a stage where we always do incremental regeneration.
Yes,
We don't
Casey actually has a PR up for this.
It's in 117, but probably I think let's check in the latest as well.
So we're implementing 100% incremental endpoint regeneration fix this.
Probably he said 117 in this case. But we were validated.
Like the PR for that is
yes.
open maybe last week.
This seems like a good point. Just one more piece of it. And then 1 minute and then okay. So what we also seen is update operation in BPF is using up a lot of memory. We couldn't figure out why. Is update should be using the same struct and then putting it inside, right? But we think that it is using up a lot.
Is it doing some allocations in the Golang side, which maybe doesn't technically need to be doing?
Yeah.
Which version is this?
16.
16. Okay. So I think in 114 or 115 we saw a bug with the API server policy matching feature where just before calling inject tables, there was a bug where I think the user space component thought the changes were not propagated and it would call flush to the BPF layer more than so there are actually no changes to the API server at once, but you would call the BPF map update over and over again.
Okay.
But that was fixed recently. So if you're seeing still in 116 right now. But if you try to look at like what values you're updating.
Yeah.
No.
One question.
Going into your talk now.
Did you consider removing DNS Proxy entirely from Cilium agent and just making it entirely standalone and having like 2 supports?
This test is for the DNS proxy.
Okay.
You mean like instead of running inside the Cilium agent, just run the dedicated DNS?
Yeah, you were showing how you have it on the side and in Cilium
Yes,
agent.
yes. I think I have this conversation with
Only having 2 on the side.
I guess it's the opposite of whatever the last item was. That's why that's right.
Is
Like,
that
That's a nice present for like decoupling things out of Cilium agent.
So he's saying like why don't we just run standalone DNS Proxy?
it's
I
just
think-
less
yeah.
efficient.
I think I had this conversation. I mean, first we wanted to focus on the core part, like the gRPC contract. Maybe in the next CFPs, like if needed, we can just run the standalone DNS proxy. It can also be delegated, right? You can also bring your own DNS proxy and then do that stuff. I mean,
Okay.
it can be done.
The component that's actually causing this increase in memory will not go away because it's computing the policy.
Oh, right.
just
Yeah.
like long. In fact, you'll only have more overhead because you know gRPC connection is shuffling data.
So standalone DNS proxy is just consuming like 60 MB to the max. The load test we tested, it's not, but the Cilium agent is the main piece, like it's consuming like a lot of memory. But also like you may miss the performance improvements, right? Like this is another thing. It's closed. It's let's see, prepare CA DNS proxy.
Yeah.
So we can do this optimization which you are working on, right? Instead of STP, so that you don't need to share mappings and everything. It will be more performant.
Oh, thank you. I think I've met everybody already, but I'm David Swafford with CoreWeave. Just some quick background about us. Marketing would want me to tell you that we are the AI hyperscaler. We are building our own cloud for GPU and specialized AI workloads. All hardware on our own on-prem in our own data centers. And from a Cilium perspective, we are using Cilium in native routing mode. Specifically, my project right now is to roll out Cilium fleet-wide. We're kind of in the midst of it, and part of my presentation here today is about one of the edge cases that we're having a little trouble kind of fitting Cilium into. As some background, our network's fairly simple. We are using native routing mode. So from Cilium's perspective, no VXLAN, no cluster mesh at the moment. And we are using the BGP stack, specifically BGP version 2 at this point. Just taking a look at, and so the title of this is actually BGP Route Learning. And we're going to kind of dive into this in a minute. I have just a handful of slides to kind of walk you through what Cilium can do today for those not using BGP, and then what I propose. In this example, we have a Cilium node with a number of pods, a number of workloads, and Cilium has a BGP daemon running. In this case, under the covers, it's actually Go BGP is the implementation. But we have a BGP daemon, one network path to the network, shown with ETH0, and a simple default route. I may butcher some of this, but I believe it's just simple kernel routing. I'm not actually sure if eBPF has a default route concept, but effectively we have one path out of the node into the network. BGP exists today for one purpose in Cilium, which is to advertise the reachability of specific IPs or prefixes. They might be the pod CIDR or potentially individual /32s in the case of a service IP. And so in this model, Cilium is one direction. We can tell the network about prefixes that we have, but we're not using BGP to do anything else. We're just kind of telling the network that they exist. And then for all other routing purposes, we refer back to the static routes in our kernel routing table. The default is going out at 0. That breaks down when you start to bring Cilium or these nodes into more complex network designs. In this example, I have a node with 3 separate network interfaces, ETH0, 1, and 2, connecting to 3 distinct networks. We've got the blue network, the green network, and the red network. In this case, we have different ranges of address space. In some cases, they might be contiguous or aggregatable. And sometimes they may not be aggregatable. Like there might be the same prefixes that are overlapping in different parts of the network. And so right now, if we try to use these 3 paths, by default, if we continue just introducing it, and I believe actually I just saw that Enterprise offers something called multi-network, according to the blog post I found. But let's say for a moment that Cilium can at least use these 3 paths in some mechanism. We've got the BGP daemon. We are advertising a service announcement out, but we're not able to kind of fit Cilium in a way in this model that really makes sense. And what I mean here is that we need to be able to make routing decisions based on what prefixes are available on which network. And so in the blue network, we have the default routes coming in. And so that, you can imagine, that's our default route in our primary network, as you could think, for all the workloads. Green and red represent maybe specialized networks that are used for different purposes, that contain or might need that the host might need reachability to. So in a perfect world, I kind of went down a deep path of trying to figure out what are all of our options. And so there is one of the options that came about this is that we could actually manipulate the kernel routing table and let the kernel routing table decide which path to take when we're talking about outbound traffic. So traffic originating from these pods going back to the network, to at least give it some mechanism to get into the green and red networks. Because there's actually 2 separate problems at play here. One is, how do I selectively advertise those VIPs or those pod or service IPs into specific networks? But the other sticking problem is, how do I make more intelligent outbound routing decisions from the node's perspective? And so in a perfect world, you'll have a very cleanly designed network where you have large blocks of address space, so you can kind of craft these policies in a couple of lines with really large network blocks, like 10/8. So the entire 10 range out of one, and maybe only 1/24 or 16 out of the other. In the real world, our networks evolve in different speeds from Kubernetes and our other teams. And so we get into a case, and I think you even mentioned this in your early talk, where things become disaggregated. And so now we have blue, red, and green that were meant for specific purposes, yet in some cases, we have the exact same prefix or the exact same, let's say, 15 carved up. And so some of the ranges are in one and some of the ranges in the other. And so we can't have this like very simple set of static routes that say, okay, all this giant range out of this one for this. We now could see potentially hundreds, if not thousands of routes to actually make this work. And so the problem statement really around why I'm proposing, I didn't actually say what I'm proposing, but what I'm trying to propose, here is to make Cilium more intelligent, especially its BGP implementation. And so instead of it being this one directional, I'm advertising routes to the network and then deferring to the routing table in Linux to do the outbound, I'd like to modify Cilium so that it's actually more like a traditional router. That routes learn from BGP actually be accepted and be used to make outbound routing decisions from the perspective of the node. And so with native routing mode, I was just mentioning this is possible with static routes. You can build automation, program lots of static routes on the kernel to manipulate these. But the problem there is you then start to build a lot of automation around managing static routes. And so stepping back a minute, let me show a little bit more about our actual use case to understand kind of where I'm coming from. So as a GPU cloud, we're a little different in that we're very specialized in that. That's our focus. Our approach, though, is that customers rent out hardware. And so a given node or server, like an H100, has 8 GPUs, for example. Only one customer has that node. And so they'll rent out a cluster from us, so many nodes. Let's say they want 100 nodes. We will build a dedicated Kubernetes cluster for them. And so it's a cluster per customer. We will install Cilium. We manage Cilium ourselves, but then we hand over the node to them. So they have full access to it. They can log into it. They have root. They can rip apart Cilium and break it if they want. We have automation that'll come back and fix it. But I kind of want to show you the fact that we treat our users more like power users in this case, in that they have full access to what's on the node, even though it's a managed Kubernetes cluster. Which means that if we have to add lots of automation around this, we kind of get into the sticky point where we're trying to give them a very simple node that is kind of programmed to manage, but not with a lot of extra things running because they're going to be able to both see, touch, and break those things. And so if we think about this model where we're just managing lots of static routes and building automation, there's a lot of potential risk there, and that now there's a lot of edge cases with the automation or them getting in the way and things getting broken. And so I proposed this CFP and I started talking to Hars Imran. Apologize if I butcher his name.
We usually call him Pablo because his last name.
Pablo, yes. I like that. Pablo and I have been talking about this.
Not Pablo.
Pablo. So I've been talking to him about this. He actually reviewed the initial CFP about 2 months back, which actually led to some other ideas that he mentioned we could use, which is this one, which is why not add another router between, like, routing daemon between Cilium and the network. And so this is one example he proposed, which is Cilium, instead of peering with the actual network, these CRDs are configured to peer with an additional third-party daemon that's on the node. And then we would manage that third-party daemon. So in this case, it's passing the Cilium routes through that. So what, I swear I'm not explaining this very well, but
Cilium wants to attract traffic.
Yeah, Cilium wants to attract traffic.
Bring me this traffic.
And so in this case, if we put a daemon in line, Cilium is continuing to advertise routes, but it's now advertising this peer that's on the box, that's this intermediary. And so it just is kind of a pass through. It'll continue advertising this to the network. So that part is unchanged, that we're advertising out. In this case, the routes coming in from BGP are now programmed to the kernel by this third party daemon. Stepping back to what I just described, that's in our case kind of problematic because this whole host is a specific customer. They're running workloads on it in Kubernetes And so if we install potentially either in Kubernetes or on the bare host, an instance of Bird or FRR or another BGP daemon, we're kind of getting away from this Kubernetes native model of this entire system is programmed by or managed by Kubernetes, either custom resources or just over Kube API. And now we have this layering of another daemon on here. So from our perspective, that's kind of problematic. And so where we went to in this discussion on the CFP is that I originally proposed kind of a variant of this, which was Go BGP, which is what's used under the covers. So they don't implement route programming in the kernel or the RIB or anything like this. So their implementation already is in a way one directional. But they do receive routes, so they don't just throw them away. They do receive routes, they just don't do anything with it. And so they have a documented approach for standing up a second daemon, specifically the Zebra project, another open source project, for the purpose of having Zebra connect to Go BGP and do the program. That was what the CFP originally proposes, which I haven't edited yet. And Pablo pointed out that Cilium actually brings up multiple BGP daemons in some cases. And so there's some complication there where if we have multiple Cilium daemons pairing with Zebra, is it one Zebra or one-to-one? And then thinking about the overhead of now managing an additional daemon on the side that's not actually part of our project, it's part of somebody else's open source project and stuck in a container. So he was kind of recommending not to do that. And so the discussion then continued a little bit more where we brought in, forget the guy's name, but the Go BGP guy that now works for Isovalent. Yes, Utaro. The Utaro, I tagged him on this and said, hey, would it be better to put this effort into extending Go BGP to actually do native route programming in the kernel? He steered me away from that because of how big of a change that was. And so then the discussion kind of came back with Pablo, and he suggested, how about we think about bringing native route programming into the data plane? Because there are a number of features potentially that it can unlock if it's not this disjoint thing on the side. So that's kind of coming back to this. The proposal here is I would like to bring full-on BGP route learning into Cilium and specifically explore that option of connecting it in such a way that routes are programmed directly into the Cilium data plane. I'll admit my eBPF side is very limited. So I've been focused just on the BGP stack of Cilium. I've worked on that. So I don't know if there is a concept of a routing table in eBPF right now. But if there's not, this would kind of introduce the idea of a routing table that we directly are programming to reflect these routes that would be used for then egress traffic leaving the node.
I'm curious, like the additional functionality, can you give some examples? Like what would you gain by, I know, yes, eBPF, you can do anything,
Yeah.
but like what specifically?
So this was Pablo talking, let me pull up the CFP. I don't know if he actually mentioned this specifically, but I want to say he was talking about security functionality.
Also, Joe, to your earlier question with multi-cluster, you were asking like what happens after VXLAN, right? Can we use this BGP daemon to send out route saying that, hey, if I'm this pod side, to send it to this IP address?
What if you had a plugin?
This is better conversation.
It's a singularity. It's all coming together.
Are the plugin sets?
Yeah, so I don't remember if he actually named specifically. This is one of the things he was proposing, which was to pass the responsibility of installing kernel routes to Cilium itself instead of another process. We were talking about the lifecycle and management of PHP. Control and it's installed. Sources.
It sounds like for sure like debuggability, because you just go to one place, like Cilium knows everything. Like,
Yeah.
That I can see.
I mean, Cilium
But
just really,
recreating it, right? Like how big a task is that? Is it small?
I mean,
Is it big?
that's, yeah, that's.
Yeah, I honestly am, so from my
You start down the
perspective,
track of, I'm gonna implement BGP, and then
Yeah.
you're like,
well, so that's part of why I wanted to bring this here. So
yeah, yeah.
for example, I've done a couple of tiny commits on the BGP stack. I am a software engineer, but I'm not an eBPF like software engineer. So from my perspective, adding it directly to Cilium seems like a huge lift. Like it's more than I could do. But I was curious more to understand more from the conversation with Pablo. He thought that, like, he didn't name specific features, but he thought there was other features and functionality we could unlock potentially. I think on the security policy side, maybe. But I was more curious, like, does this remove some tech debt, for example? Does it unlock some future features that we couldn't even think of? But now, if route programming was native, does that make our lives easier? Because the very simple answer here is to add just a third daemon in the middle that is not even managed by Cilium. Like, granted, I talked about some issues in managing that, but like that's a far less lift. So I'm curious.
Yeah, I mean, that
am
does
I the only
feel
one
like
running
off the shelf.
Yeah.
Something you could cobble together for your solution.
Right.
Right.
Like, am I the only one running BGP, for example? Like, you guys were talking about having a custom networking layer underneath. It sounds like Google probably does too. So
Yeah,
we are trying to not do anything with like custom networking underneath the covers and just use BGP to the network. Like, is that a large use case for anybody else?
This, what I'm going to say is mostly a question to the better experts than me. Like, I've heard some people, especially internally, say like, "Oh, if we keep everything in Cilium eBPF and then sort of like skip kernel, like all routing and so on over." I don't really know what the trade-off there is, just because I'm not super familiar with that. I don't know if like some folks have like an opinion on that. It sounds to me like, why would you skip something that exists? But you know, maybe it's so simple.
I just wanted to say, if you want to find other users who have similar problems, you need to find users that are running Cilium on-prem. But like cloud providers, I think they have distinct teams like DC folks doing BGP.
We do have on-prem users.
Yeah, but
Probably don't.
like there are a few on-prem Cilium users who rely on BGP.
I think standalone load balancer requires BGP. Cilium standalone load balancer. People who uses that on-prem bare metal servers use standalone.
Like there were a few talks on like moving away from NetLLB to BGP.
Yeah.
Like maybe those companies might have some problems.
Thing is, like, probably also boils down like to how complex is it to implement. I mean, like installing routes from like Go, I mean, that's not complicated, right? But like that engine, I don't know like how that looks, or like what is currently supported Go BGP has, and what other potential features you would have to duplicate from FRR and so on.
And then do you end up needing
I don't
to,
know.
like,
I mean, but just to clarify, like from the eBPF Datapath, it just reuses whatever you install into the routing table. So if you do that, then
In the Linux running table? In the
Linux
Linux running table?
in the Linux kernel routing table.
so it's like from BPF, it's doing a lookup in the Linux current routing table and making its decision about how to route based on that. Which is maybe one of the kind of where you have, if something's just programming that, then Cilium could still actually make the data link of entirely.
Yeah, so that's what Pablo was suggesting, was we might want to skip that and put it straight into eBPF, which I'm curious.
I
mean, that's fair.
We reuse whatever someone installs to the routing table from eBPF, but I don't think it makes sense to duplicate like the kernel routing logic.
No,
because
okay.
there's like a lot of things that need to be taken into consideration. It doesn't make sense.
Okay.
And
I
that
don't
works
think
for,
Cilium cares what user space programs that recently,
Yeah, exactly. I mean,
and that works for multi-link and eBPF host routing too.
the host routing uses the routing table. Yeah, okay. And then you also reuses the neighboring subsystem. So, and I think like, why would you not? What's the reason not to?
Yeah,
it doesn't make sense.
Kind of related to this. So am I correct in thinking that Cilium, the open source version, only allows a single network path? Or is that a thing right now?
A single interface.
Yeah.
No.
So if you can use multiple, how do you steer outbound traffic? Is that just purely Linux routing table?
Yeah.
It is, okay.
You can look at the ENI board has multiple links.
Yeah, same problem there, right?
Even with overlapping IPs, you just look at the source, I guess, where it's steering.
And that's what ENI does, it's source-based routing.
Okay.
I haven't looked super closely if there's any nuances with the eBPF routing. I guess it's just taking whatever decisions it's made, right? So,
I mean, like from the yeah, like the host routing is just like from the BPF LXC stuff. You do the routing lookup, FIP lookup, and that's it. And then you do
but you
whatever,
give like the source and destination IPs or something like that.
yeah, whatever is in the routing table.
And Mark, yes.
So we peel the scope back. Let's ignore the eBPF like routing table, like duplication side. Would you be in support of potentially extending Cilium to still do BGP route programming and receive routes? It seems like there is some complication there in that we can't just turn on a feature or add some code because Go BGP is what's used under the covers and it's not supported there. And so with that, I guess one thing I'm trying to get in my head is like, I can't be the only one that's asking for this because I know in GitHub issues I've seen others ask as well. Would it be beneficial or like welcome to extend it in such a way that at least the Cilium deployment manages this other daemon and we potentially provide a way to configure this other daemon?
Something I'm wondering, this might be a stupid question,
Yeah.
I don't know that much about BGP, but where you have the two instances of BGP daemon.
Yeah.
Right? So the Cilium one is advertising addresses that are known to Cilium.
Right.
And you have the sort of incoming one. And you've actually got like a BGP connection between the two. What I'm wondering is if both of those are programming the kernel routing table, can they not just be independent? Like one of them is handling advertising addresses, the other one is handling.
Oh, that was another variant Pablo mentioned. We could do that as well, which would be actually having a variation where we just have the sessions from both. So you would actually have all these sessions would be in parallel.
I guess one thing is maybe you don't feel like every router should appear twice to the same to every node. Or is it every node actually?
So the complication with this one is, yeah, I guess. And so in this case, Cilium would be the outbound, the other one would only be for inbound.
I see what you mean.
Yeah.
There would be two.
It's something that it feels like.
For the remote node.
Yeah,
they'll
you're
probably
right.
appear twice,
That
yeah.
was the thing we were thinking about. Because now from the remote node, the network has to know that every host is actually two sessions.
So
Yeah.
proxying it through
Yeah.
one kind of
Yeah.
helps solve that.
So yeah, right. Proxying it through one means the outside network only sees this box as a single session. The disconnect here now is you don't have a way to generate config or manage the lifecycle of this. So is that potentially something we extend Cilium series to describe and then that becomes config? That feels messy.
Or is it
but-
just an extra container, or like what do we? Like, is there something deeply that we need to integrate, or like you mentioned CRD just now, but we'll get back to that.
So again, thinking back to like trying to be really Kubernetes native, I would not want to add a system to service separate, which is where this is actually showing right. Because this like more practically would be a system use service that spins up Bird or FR or some other.
You could just deploy one of those things in a container.
Or it could be in a container, but separate. I guess what I'm trying to get at is I'm not trying to make the user know about it or have to deploy it, like even though I'm putting it on their node. And so if I could manage it via Kubernetes, that would make it
You could add it. Why not just add it to your Cilium daemon set as like a special sidecar and then you go to it.
And like you do have a little bit of like, how do you get to config in and out?
Yeah. So you have to like stitch it
So
together.
there's probably a little bit of extra software development just to wrap it in somehow. on
Yeah.
Kubernetes, but-
Would you recommend I do that just myself, not part of like Cilium's like project?
I would probably start from there, and if it's a huge pain, like maybe we can have the conversation. Yeah.
Okay.
So this kind of reminds me of what we do with IP Mask Agent on our nodes, where there's, you know, kind of configuration that happens actually in IP tables for masquerading outbound traffic outside the cluster cider. And we run that as a completely separate daemon set in parallel with Cilium. They're both daemon sets. They both get managed by us. They both are managing Linux networking constructs. And in the configuration we test, it works, and they're able to kind of coexist. This seems to be like a similar problem, except instead of IP tables, now you're talking about the route table. Right. Same idea. It's two daemon sets that are having different responsibilities, but happen to be implementing that by programming constructs in the Linux kernel.
Okay. But maybe a good path, like immediately, is like once I kind of like test this out, is maybe in the official docs we have a section of, hey, if you need to do route learning, here's an example of how to do it. That might be an easy stepping stone.
I mean, to that point, like we had a like Cilium with Bird guide.
Yeah.
I think the folks working on BGP marked that guide as deprecated because just the most common case that we're trying to support with Cilium and BGP is just the service advertisement.
Yeah.
Kind of thing. So the more we increase the scope of what the docs say, the more that users kind of show up and say like, hey, I want to do this.
Oh,
we're
that's
expecting the
true.
project to kind of give them a bunch of support. And we're like, well, there's only like, I mean, it's good if we have the community involved and like respond.
Yeah.
Right? But if we have these guides and we never get them, they kind of sometimes break.
No, that's
and
fair.
nobody's helping them, then it kind of feels like it's not a great user experience.
So I was surprised. So you guys are not using BGP. Is there any cloud using BGP?
Clouds won't normally because they just do everything under the covers.
Okay.
Nothing RFC. Okay. Like it's their own stuff. Yeah. So it's fully programmable.
So I guess we're the odd one out here trying to be standardized.
On-prem or smaller clouds.
Yeah. Okay.
I did have one other just more general point, which was like we've gone through a few different iterations, and like this is actually why I like the deprecating the docs kind of thing.
Yeah.
Because like probably you've looked at the BGP docs and Cilium.
Oh, a ton, yeah.
And there was like 4 different
Yeah.
options I think by this point, like Kubernetes, Bird.
Right.
We had the middle LB thing. Like one of the learnings I think from middle LB was we kind of in some way implied that because we're pulling in middle LB, and middle LB has all this configuration for the BGP is doing. We would just kind of take that configuration, give it to this middle LB as a library, and do its thing. But we weren't like testing the whole scope of all the different things that we do. So I think one of the struggles maybe if you do try to integrate more and more BGP config is like how far down that road do you want to configure? And like I mean, one thing I know from a security perspective is like the filtering of routes coming in, depending on how well you trust the peers. Now, I guess in your case, you're trusting these routers. You're the one programming these routers because it's your.
Oh, we are, yeah, yeah.
But obviously, like an internet exchange or some kind of other use case, it's like a whole different.
I do know when I talked to I know I've also talked to Radislav a bit, some of the PRs. I think if we went down this path, he would want us to introduce filtering, like as like a kind of secondary feature with this. Right, you're right. Right now, a user cannot define like custom BGP policies to do like really much in the way or any in the way of filtering.
Yeah, I mean, like definitely this feels like the kind of thing where like if we clearly had like 2 or 3 like different users or like aligned users, like you and a couple of others that were like, yeah, we definitely all trying to do the same thing.
Yeah,
it probably makes a lot more sense to say, yeah, let's like figure out if there's a more integrated way with Cilium. I do wonder if
that's fair. I wasn't
on the way, or like maybe we didn't make sure it's. If there is something we can do, like adjust the help charts or something to make it easier, that might be a way.
It would be interesting to know whether there are other users who are, you know, deploying bird or something as a daemon set. Maybe it just works.
But I guess the
so-
Kubernetes thing, like
Yeah.
that's where like you want to somehow bridge those worlds. That's I think we're
Well,
Bird
to be more
doesn't-
specific, so we're currently Calico, and we're moving off.
Yeah.
So this is in Calico already. So it's a sticking point in that. I see where I can move like,
solutions based around.
I can move like 50% of my workloads to Cilium as is. The other 50% I gotta keep Calico, and I don't want to keep Calico. And it just makes me wonder more of like, as you get into more advanced use cases, are there people that want to stick this in like a random edge location and treat it more like a router versus just like a data center? And that's more what starts to unlock here is like, if this was like thinking about just how the internet's built, like POPs and racks and like routers, could this potentially take the place of that? Like, are there places where Cilium just can't be used that if we could handle routes to directional like natively, that it just kind of expands it? I don't know if that's a goal of the project or not, but it's just kind of something I was thinking of.
Yeah, I mean, I think probably to date we haven't seen contributors say, hey, like we really, really want this.
Okay.
And like a big part of any open source project is like, what is the maintenance burden going to be with this?
Right. Yeah.
And there's a bunch of different things. Like this is the actual code.
Yeah.
It's like how do we change the configuration? Is you know, what happens when there's one contributor but they disappear for whatever reason, right? So yeah, in the back of our heads, you always kind of think about like, okay, this is why I say like when there's like clearly 2 or 3 people like, yeah, we're aligned and we think this is useful, then it's much easier to say, oh yeah, like let's make sure inside the project that you can kind of extend and build something in there.
Okay.
And until that point, it's a little harder to say whether we should have something that's like changing Cilium code and stuff like that. Even though like I look at it and I say, well, if you have 2 boxes that say BGP, shouldn't there be 1 box?
Right.
Like this is very, you know, so deep down some feeling there, right?
Oh.
I felt like that about the
So like how much does the Go BGP, I mean, like it must be able to establish the session and receive routes, or like do you have to implement the receiving aspect of that? Or
So that's the one thing that I was surprised. Oh, I thought it was.
Also got like max 5 minutes left.
Okay, cool. I was just trying to share it again. So Go BGP actually implements a complete BGP stack. So it is kind of weird that, not to speak for, I can't say his name, but not to speak on his behalf. But I've always found it is a little odd that it doesn't do, I was trying to share it. So it actually has a full BGP implementation. I've actually used it in like last job -3 at very large scale. I had 140 POPs where good BGP was the router, and we were doing full internet tables with it. So it certainly is capable of receiving and programming routes. In that case,
so in that case, it basically boils down to just installing them.
yeah, it was just a matter of the plumbing to install the routes. Because in that case, we ran BERT. So Go BGP, or no, sorry, Go BGP was before that. It got replaced by BERT.
Because I had seen a blog where somebody was alleging that Go BGP does not scale well to like internet scale tables.
It didn't. This was Subspace, if you ever heard of them. It did not. That was why we ripped it out. It went to BERT. We went to BERT because it keeled over. But we were trying to throw like 60+ peers per box at it with pooled internet tables. So it was huge, the footprint. We ran basically just lots of race conditions and memory leaks that we couldn't get to the bottom of. On that one, I'm trying to think. So the stack there, it was network as a service with eBPF under the covers. So there was some custom programming. I don't think, yeah, in that case, I think we only use it for outbound traffic engineering. But so what I was doing at though is it does have full BGP, like the stack. It's not like if you've heard of ExaBGP, which is a Python application, that's literally like dumb as can be. Facebook uses it, so it does have lots of scale. But that literally doesn't even support receiving routes. Whereas Go BGP does like completely have the idea of ribs. You have full-on routing policies. You can actually like inspect what got received. It's just the fact that it doesn't program anything. They expose a specific RPC that is where the Zebra recommendation comes from. So they have like a specific like IPC that makes it like native. So it's not like doing a BGP session to it. It's more direct. Yeah. I think that's great feedback, though. I think just trying to.
Yeah, when if it is just the piece to install the route, I think that's like then it would be like fine. I think the question is like how far does the scope go on the configuration side, the route filtering, and like what use cases you're trying to support. Do you end up with this whole big BGP configuration of all this elaborate stuff? And do we have the maintenance for that?
So I'm not trying to do anything, just to make that clear. We're not trying to do any crazy kind of policies. It will be minimal, like ideally we will have like route policy, like route maps, like more community based, nothing fancy and all that.
But and I don't know, maybe this is an interesting, just broader like Kubernetes thing. People wanting to do BGP routers with Kubernetes. Like I can see the appeal of CRDs are a way to configure infrastructure, and Kubernetes is the way you do infrastructure. Therefore, it's a solution here. I have Cilium select the base of that. That's kind of neat. Like, there's a bunch of people.
For what it's worth, a lot of Kubernetes components are literally multiple daemons just like duct taped together. If you look at kubeDNS. So it's not like running bird on the side is like any less than the other aspects of it.
I think we are also kind of having this like discussion about like cell and hive and pluggability.
Yes,
like,
yes.
Do we have a monolithic daemon? Do we have multiple?
Yeah.
Maybe there aren't solutions to this problem to build check the clock.
but yeah, so like running bird, I'd say it's not a bad solution because you think that daemon has like a lot of miles on the road, right? Like,
no, that's true.
You kind of understand it. Like, are you reducing tech debt, or are you opening up avenues for vast more amounts of tech debt sometimes?
No, that's fair. I think part of why I wanted to bring us up here was trying to figure out if there's more things in the roadmap that like is potentially open, but it sounds like there's not really, like in terms of like security functionality and stuff like that. That's cool. This is helpful though. I appreciate the thought. I actually didn't even think about. I think you were suggesting the actual like Helm chart.
You just like
manage the Cilium deployment on potentially just add the extra container. That makes actually a lot more sense because then the customer, because we're using Cilium in its own namespace, so then the customer, they look at the Cilium namespace. It's not like in some random thing.
So I think one of the challenges for the multiple daemon sets is like, what if you have to upgrade them independently, and then what if they have to like, talk to each other, or is it they're kind of contained in the same unit and life cycle sort of sorted?
Do any of you guys know anything about the graceful restart implementation in Cilium right now? Because Pablo pointed out that will break if I have a secondary daemon. To my knowledge, I wasn't sure if it like a legitimate like thing in Cilium though.
There's been a bunch of work on that recently, right? I don't know.
Okay.
We are doing that for SDP or L7 proxy, but not for Cilium agent itself. L7 proxy or the Envoy event, we have irrespective start.
Oh, so I'm talking BGP graceful, which is where like the upstream routers can signal I'm reloading, but normally without it, your routes would actually like be withdrawn. But in BGP, if they signal and they have this feature turned on, then it basically says ignore the fact that the session's going down, keep all the routes for some amount of time. And it would
I feel like I've seen the demo of that recently.
Yeah. But this is in this example, Pablo pointed out that if we have the two between,
there's no way to relay that.
There's no way to relay the message. But at the same point, if there's one in between, as long as there's a session between Cilium and the other one set up, I think it.
Unfortunately, I think we're hitting time.
Oh, I'm sorry.
Yeah, no, it's fine.
Yeah.
So.
Screen. All right. So I'm not going through the whole thing because like that's the KubeCon talk. But basically, yeah.
You should pitch when that is. You know?
Which is on Wednesday. Yeah. But basically, this is like the second half of it where we did some performance experiments. Given in the case of Cilium, we're seeing more and more users using wireguard. So, and we found there was like a blog post from Tailscale people where they use the user space wireguard implementation. And the blog post basically said, user space isn't slow, some kernel interfaces are. And they did some work on the WireGuard user space implementation and the WireGuard Go, what they use, I believe, to make it faster. And the way they made it faster is basically utilizing BGP GSO. If you're not familiar with that, it's basically some aggregation mechanism in the kernel to aggregate more packets to basically send like a single big packet up the stack and like down the stack. And they basically said in that article like that they achieved better performance than the WireGuard kernel driver. So we wanted to look into to see how it looks today and if there's something we can improve in terms of performance. So this was the whole goal of that work. And the first step was actually for us to get to a stable baseline. So we have some bare metal test machines with 100 gigabit NIC, and first of all, it's not that trivial to actually get to the full 100 gigabit for a single TCP stream. So what you can see here is like a network screenshot with 97 gigabit for a single stream, and without WireGuard, so that's like host to host over wire, and on our little lab. So basically, the hardware we've been using is some AMD CPU, the Connect X6 Mellanox NICs, and this rig basically has PCI Express 4. And the Linux kernel, so we basically rebuilt our kernel to remove some overhead that is usually there by default. One big one are obviously the CPU mitigations against spectrum meltdown and so on. So we turned them off. Then the other one is like some kernel hardening stuff that is actually really costly for networking workloads, which is clearing pages on allocation and freeing. So in particular on the networking side, this you can really see on flame graphs if you look into that. We changed the scheduler mechanism from the default for most distributions, I think, is config preempt voluntary to preempt none. And preempt none is, as far as I'm aware, also done in production, probably by Google, by you guys as well. Meta too. And yeah, so in most distributions, they have the voluntary one, which basically means the kernel can reschedule it at certain locations when you're not under the RCU lock and so on. So yeah, like for server workloads, the preempt is certainly better. Then you have to turn off IO MMU. For the Mellanox NICs, we enabled large receive offload. We went to 8K MTU, given you have higher MTU, so you can push through more. And we pinned the network IOQ affinities 1-to-1 to CPUs, sent the CPU governor to performance. We enabled big TCP, which basically allows for more aggressive GEO TSO, and we tweaked some of the TCP receive and read and write memory to adapt it to the MTU, because by default it's like optimized for the 1500 MTU. Yeah, so it's quite a bit of stuff that is involved to get there, like for a single stream. And if you compare that now with WireGuard, it drops significantly, right? So like with WireGuard, by default, you can get to 25 gigabit per second with the kernel driver without any changes. And the WireGuard Go user space one actually achieves under 8K roughly 20 gigabits. So a little bit less actually than the kernel one. So turns out actually already today, like the kernel one is faster, like with a higher MTU.
So is that compared to what Tailscale saw? Were they
Tailscale would
would
be the yellow one, but I will get to like the default 1500. I will get to that. The difference is even bigger, like for the TCP/RR benchmark for the transaction per second, where you just send small packets back and forth. the default MTU actually turned out there, the wireguard Go is a little bit faster, right? So you get to 8 gigabit versus 6 of the kernel driver. So in this case, yeah, with the transaction per second, the kernel is still better, more than twice as much. So the question we had, okay, so can we do better for the single stream workload than today, like with WireGuard? So the question is, how does it handle GRO or GSO on the kernel right now? In the case of GSO, what you can see is basically the kernel pushes individual packets up, and here like MTU-sized packets, what you can see. And it will go through the WireGuard UDP socket. The UDP socket does the decryption, and it pushes it further again to the receive path of the kernel. This time with the bigger length, because the WireGuard driver internally does GRO aggregation once it decrypted the packet. So then it can send up more to the stack. And it looks roughly like this, right? So you receive the encrypted packet, what I just mentioned, and then the GRO one on the right side is actually then pushing a bigger packet after decryption. So there's no aggregation in the first one, and the second one there's aggregation that takes place. On the transmit path, quite similar. So the kernel sends down a big packet to the WireGuard driver, and inside the WireGuard driver, you can see then from that point onward, it's sending MTU-sized packets down to the Mellanox NIC. And so this is what it looks like here. You get a big packet, then into the driver, it does the segmentation and software on the right side, like on the top right side, and then it pushes it down. But there's no offload, so you cannot make use of something like TSO, where the hardware would segment the packet. So yeah, why is that? So basically that is like, why does the WireGuard driver needs to do the segmentation and software? Because the WireGuard protocol header has a counter for the replay protection. So it cannot take a big packet and encrypt it and then somehow rely on hardware to fill in that data. So it basically needs to break it apart in the driver, and then on encryption populates the counter value, right? So there's nothing we can do on the transmit side, but on the receive side, we can actually optimize it slightly. So there's L2 GRO, where you can basically, already push data into the WireGuard on the first GRO location. This is like a small code that we added to WireGuard, how it looks, and what you get out of it is basically, is basically a 14% optimization for a single TCP stream for the 1500 MTU. Here you see the result much better. With 8K, it's much smaller because you're already batched, right? All right, so there's that. The thing is, like, if you do this benchmark, you will see that it spreads the data across CPU for the encryption as well as decryption in case of WireGuard. So this is how flame graph looks like. You can see like lots of kernel threads that are doing the work. If you take a look at the individual one, you can see that, okay, this is like the part of it is the decryption, and the small part is when it pushes data up the stack. And yeah, so this is like a scheme, how it works, like with the internal threads, so that it has multiple queues. One is like the peer queue, so that you don't have reordering when you push data to different CPUs for the decryption. And then there's another decryption queue where it basically has like some internal kernel threads, which does the work, and then signals it that it can go further with the processing. So yeah, what is the downside of this is basically you're not CPU local anymore, and it does cache trashing, right? So like how does it look if you would do everything like just on a single CPU? This is what we implemented, and it basically now looks like this from a flame graph point of view. So you don't have like all these little threads that you saw earlier. But The downside is like, given everything is now on a single CPU, like for the bulk, for the TCP stream workloads, you get a 60% drawdown. However, for like small transactions, you get like a 80% win on the other side. So if you look at the latency, so basically we also compared that. That's the P50, P90, P99 latencies. Like the yellow one, this is the one with the where you go to the wireguard go, which is really high. And the green bar here is the latency where you have this inline encryption plus the L2 GL.
I have a question on the distinction between the small transactions versus not. Like, is it sending more data, or is like because bandwidth seems like a lot higher.
Yeah,
that's like what is going on there?
It's basically sending like one byte data like to the other end.
I see.
Like yeah, small packets.
So statistically, you're encrypting, decrypting,
like
packet headers, not data.
Like very little.
Very little
crypto,
very little data. So basically, with the stream, the bulk of the time is spent on the encryption decryption. Right?
I see. So it's not consuming as much CPU per se. Okay.
And I guess usually you have like a mix of both in the real world.
Right.
Got it. Yeah, so that's basically what we want to optimize for, right?
The solution is to send both workloads. They're small workloads.
Exactly. So yeah, there's no free lunch, and then there's a trade-off in all this involved. So now the thing is, okay, so this is how it looks like for a single stream. But like what if you have multiple parallel streams, right? Like this is because, of course, like in the case of Cilium, you have like one wireguard device on each of the nodes, and data gets sent through like the east-west with multiple streams in parallel. So how does it look there? And it's actually quite, not that pretty. So this is like when you have multiple TCP streams in parallel, and what you can see is like it doesn't scale at all. So it's stuck on the 30 gigabit per second thing, right? So that's quite sad. So how come that it doesn't scale? So the problem here is really like like all the traffic, the source and destination ports and source and destination IPs, they look all the same. So basically all the traffic will end up on a single receive queue on a NIC because there's no RSS, even though the unencrypted traffic is all different, right? But yeah, so that's quite unfortunate. So yeah, the naive approach we took was, what about if you have multiple wireguard devices so that you have different listener ports and the traffic could maybe load balance among them. So we tried like different options. Like one was maybe what if you have a bond device and then you want the wireguard things underneath, but that doesn't work because like wireguard is layer 3, bond device is layer 2, and there's like in the kernel it will reject it correctly. So I mean, it could be perhaps made to work by changing the bond driver in order to get this done, right? But today, out of the box, it doesn't. It's not reported. Then the question is with multipath next hops. So you're able to configure something like this, but the problem is right now, at least wireguard itself, and I'm thinking it's probably a bug in the wireguard driver today. So if you have different listener ports, but all the other wireguard parameters are basically the same, somehow they override each other with the different wireguard devices. Like for example, with the allowed IP setting. I don't know. You've looked into wireguard as well. Maybe you've seen something like this too.
What is that?
So
like a singleton.
It looks like if you configure the same stuff for all the different devices, then it looks like only one device gets that config and the other one config is being removed.
So like allowed IPs only map to one.
One, yeah. That looks like a bug in the driver. Same if you have different listener ports, different key pairs, but then the endpoint and the allowed IP setting is the same. So I think probably a bug. I will have to into that, but Different everything works, so nothing conflict here, but this is like the most complex setting. But if you compare that, you already get a much better combined throughput of the streams, right? So the yellow one, again, for comparison, is the WireGuard Go user space one that you can see, and then the red one is you create multiple devices and then send flows through those different devices. So that's like a 1.x, and a 2x better combined transaction per second. Actually.
How this multiple WireGuard is chosen? Like it's random. It's like using ECMP kind of stuff. Like choose any.
I mean, like in this test, just to see whether something is workable, I added the different like the netperf instances with the different endpoint addresses, so that you force them through those devices parallel, right? So yeah, like the RSS scaling actually improves things. But now the question is, how does it look like when you do the crypto inline on the same CPU? So this is the case for the TCP stream. So here you see like the green line. It looks like, so that system basically had like 16 CPUs. And it looks like initially it scales linearly, but then at some point it like cuts off. Looking at the flame graphs, it looks like more and more work is delegated to the kernel software IQ. So potentially this maybe creates that problem. But at least, yeah, that's something I need to investigate further. But like that's at least like from an initial point of view, it looks much better, even though like for a single TCP stream, the performance is lower, right? But it does scale better. And like for the inline crypto, you now get to a 4x transaction per second compared to the default kernel driver with a single device. So this is much better. Yeah. Now the question is, do we actually have to create multiple devices? What if we could change WireGuard to actually hash data from the unencrypted stuff, like the tuple, as a source port, right? Like what you would do with VXLAN, for example. So that you still can have like the single device on all the nodes. And it would, however, change like the WireGuard protocol or the semantics, right? Because you need to agree like in general on a single port, and then for the traffic to source port, it looks different in each of the cases. So yeah, that's what I also implemented, and that also works. So that's, yeah, going forward, like maybe this could be done as a new WireGuard mode, or when you create a device in the kernel. So yeah, that's more or less it. So like how could the architecture look like in general? So you know, to get to a good performance in general, you have like Cilium with the Netkit devices, and then the WireGuard with the L2GO I talked about, with the source port hashing and the inline crypto. So that's something we are thinking to bring up to the WireGuard kernel community, and then like for getting this merged. So far we only did the POC, but there was not enough time before KubeCon to upstream it. Yeah, but yeah, that's the plan. Yeah, so this is pretty much it.
You had any luck getting in contact with the maintainer?
He's quite unresponsive.
I sent like a patch 2 months ago, and I reached out to him on IRC. So I'll look at it eventually. Okay. But yeah, I have not been able to get a response.
Yeah.
I mean, if you do.
So I sent him a patch like for enabling big TCP, and he said he's going to apply it, but he didn't yet. But let's see, like the merge window opens in 2 weeks probably. So worst case, I ping the networking maintainers because I have them on WhatsApp, and I tell them I can do yeah. I mean, if there's clicks that you need to get in, then
Yeah, it's like the netlink API. I can flag for it basically. Okay. Like a bigger deal about it. But it's not like we fixed it on the Cilium side with like a weird workaround with like a dummy device or something, or a dummy peer to remove IPs from another peer. So it should be like a flag to actually remove an allowed IP directly.
yeah.
You need to get this WhatsApp.
Yes, I mean the link to the patch, I think.
Yeah, sure.
Jason.
Do we have data against the baseline comparison after this improvement? Like,
Say again?
do you have the comparison against the baseline you were showing, like 100 GB second?
Yeah.
Against with these improvements that you made with the port hashing and everything, did we have the comparison? What is the?
Yeah, I mean, like that's the so pretty much like similar to the last one, to this one, right? I mean,
Both requests.
yeah.
If you look at the throughput,
So you look the throughput, yeah,
Yeah,
like, it's basically this right now. So like I need to look further,
with
like
NetKit.
say again?
With NetKit, right?
No,
the-
so this benchmark is basically host to host. So like I took this out for now, but like with NetKit, it will be the same because there's when you send this out, there's like the overhead of the few functions removed, right? But like there are 2 changes I want to do for NetKit actually, which is the kernel exposes like a per device setting where it tells the stack like how much headroom and how much tail room to reserve. And I want to make this configurable so that once you enable, for example, tunneling or wireguard, like in case of wireguard, it uses headroom and tail room to propagate to the stack that it needs a little bit more space. And I want to add this parameter to NetKit as well so that you can propagate this into the pod so that the stack in the pod already knows it needs to allocate more space so that you can save this reallocation, the worst case. But other than that, I mean, yeah, I don't expect any difference. And I also at LPC, I talked with the IPsec maintainer, and he said like the initial implementation of IPsec had like a similar scheme to distribute the work like for the encryption decryption across the CPUs, and they ran into this problem and they removed it. So maybe an argument for removing it as well, or like somehow to maybe have like a balanced or like a mixed for like large bulk traffic to still keep this, but like for, yeah, it's not, we'll see where we get to. So.
Curious about the SongTigerQ crusher gratitude. Yeah. Is that an artifact that all affect it? I think there's like 3 pages or something packets to go through in the wireguard process. Encrypt queue and maybe something else.
Yeah.
So is it possible to like get rid of maybe one of those being queues? Just
that's what we did with the inline crypto stuff, right? Like that's the green stuff here. So to do everything in place without having to fill it against through that.
Right.
So have you done anything like only with 8K, or is that you got something like smaller MTU, like 1.5?
Say again?
So this testing, whatever you did, like it's done only with 8K MTU, or it's something you have performed with lower MTU as well?
For cloud and
because like cloud we use like 1.5K. That's why I'm asking.
Yeah. So this one now was done with 8K. Yeah, I can, like, if you're curious, I can. Okay,
but if you have scripts, probably we can run in our clouds.
I do have scripts, yeah, because it's, yeah. We're back on time.
Yeah, we're actually slightly ahead of time, which is good because we have to take a break. A couple more things. Yeah, we're gonna take a break now. But if people can come back at like 1:30, then we'll have a bit for the last sessions. We're gonna do a bit rush, so like 15 minutes now. 15 for the last ones. Thanks.
I mean, that way to understand it.
You're American.
Yeah, otherwise like
we're back in America. That's the thing.
Picture is different.
Okay, so I think saw a lot of technical presentations today, and this one is slightly less technical, but I think it's also really relevant to everyone. It's like, you know, what is the developer contributor experience for Cilium, the open source project? So kind of this will be a discussion session. It's a little bit generic, but you know, I heard a lot of conversations kind of around the same thing, like, hey, how do we get more SIG participation? What conversations would you have on Slack and kind of those things. So I'm hoping you have discussion. There's long-time Cilium developers. There's some new developers on contributor experience. And it's like the big questions is like, where do you want to go with the project? What is working well? And what needs attention or can be improved? So every talk needs a diagram. So this is my diagram. So I think like an open source project, I'm super generalizing here, right? Like we see these polls on the project. There's the overall technical direction, like Cilium is going to be the most excellent, you know, Linux networking stack for cloud native. And then we also see user needs, like I need to support feature X, I need to support feature Y, or you know, this is my deployment and so forth. And finally, the third leg I view as like project health. It's like an open source project is great, everyone contributes, but if no one contributes to project health, right, then we're going to have some problems. So I think like contributor experience is like how to figure out how to resolve each of these forces. You can imagine that particle in the middle is like subject to all these like force vectors from each of these directions. So in terms of technical direction, it's like it would be good to establish some long-term objectives for the project. I think there's like a vision statement. I heard Liz, you worked on that. And that's like, what is that next level, taking that vision statement and establishing like, for example, one thing I heard in this session was scalability is a major concern for almost everyone. It's like, okay, great. Like that would be one of the themes that the project's really focused on. And I think these things, while it can seem kind of hokey, is very important because one of the big questions that has always come up is like, for a new proposed feature, is it in scope right now? Does it align with the project's technical direction? Is it in scope but not right now? So maybe we need to pay down some technical debt, but that's something where we want to get to. And of course, the third one is if it definitely is out of scope, at least for the foreseeable future. And I think Cilium is both being used directly by end users as well as part of larger systems. So like this question will come up a lot. How do we balance all these things? Like, is it part of the core, part of extension, or is it like a patch? Or maybe we just like, it's not relevant at all. I'm using terms from Kubernetes projects that I've worked on as well. Okay, so like in terms of project health and complexity budget. So Cilium, like all systems, will continue to add features applied to new use cases. Like how do you balance this with making sure we stay within the complexity and performance budget? And one thing I point out, like at least from a contributor perspective, it's like we need to have contributors be able to put in, which is like reduce complexity, make it easier to maintain, versus what is, it's not really taken out, it's more like it's taken out from the complexity budget. So when we add new features or use cases, we're kind of like adding complexity, which then needs to be put in somehow, like the complexity budget. Finally, like this has really improved over the past year. So I like thank all the leads like Joe for kind of like helping drive this. It's like climbing the ladder, discoverability. So what are the project rules of the road, best practices, especially towards being able to get aligned on the overall project goals? Find places where people can help, especially on this like complexity budget, tech debt. So I think these are particularly intimidating for someone coming new to the project. It's like, how do I find those things? Let's say I am ready to help out or contribute to kind of reducing the debts. Like, how do I even find that? Especially fitting each contributor's strengths. For example, I know personally our teams are really focused on scalability, and like there's people actively working on that every day. It's like, how can they find the place to kind of contribute? And finally, understand what the path is for some form of technical leadership in the project. I think these come with time and scope and work in the project for sure. But again, like I said, I've seen this like vastly improved over the past year. So this is, I think we're going on the right track. So this is like a discussion. I know that with every project, there is some amount of mechanisms to enable some of these things. So we have the Cilium feature proposals, which I think, Bill, you're going to be talking about. We have now bug and feature triage, for example, triage of CFPs and triage of bugs and triage of PRs to kind of ensure that the project has some kind of cadence. I would also like point out like this, at least in my work on the Kubernetes side, was important is like how can, for example, community members help out with release? Because some of the big debts are like, okay, CI is broken, right? Like how do we fix that? You know, how do we get it into release? And also like, you know, what is the toil around releasing? So my general to close the session is like, what is working well? I want to hear from all of you. What areas should get more investment? I think that's very interesting. It's like, are there any areas of the project that are neglected that we feel like we should see people take a look at? And then where do we see Cilium as a project going into 2025, 2026 plus? And I just opened this to discussion. That's the end of my slides. So to open it up.
There's no specific order. I can start with something.
Yeah.
Recently, I discovered a feature that I thought was stable, but it was beta. So I marked it as beta. So there are different ways in which we can document a feature stability, right? So it's either docs, Cilium IO explicitly mentions that this is a beta feature. There are command line flags that users just put in brackets say it's beta. And generally, whenever we introduce a major change, we always introduce it as a beta or experimental feature. And how long it takes to graduate, who owns when it graduates, is not really well defined. And it should generally be owned by the person who has built it, who's driving it. But sometimes contributors come in and go away. So the feature stays there in beta forever. So there's a chicken and egg problem where like people think it's beta, so they don't use it, but maintainers think we need feedback. So they don't know that doesn't happen. So one thing I was thinking is, how do we solve for that? How can users give us feedback directly about beta features? So if we streamline like all of our features and have a standard way to mark them as beta, and then if we have a place where everybody could go and say like, oh, you like this feature, we're looking for feedback. If we have enough feedback about this feature, we'll mark this as stable so that people know that them giving feedback is going to directly help us to mark that as stable over time. So right now it's very unstructured. They'll have to ask the maintainers, why is this beta? And somebody shares information on why it's beta. Then if you have enough feedback or somebody works on actually driving it to stabilization, only then it becomes stable.
I can just share our experience from Kubernetes, and Rob is here as well, so he can also share. Like, for example, I think in Kubernetes, we, at least on SIG Network, we maintain this like project board. And now with the CFPs, I think it's very clear in terms of like, okay, this feature, this is the status. And we're basically tracking moving from alpha to beta to GA. And I thought there was a rule where if it doesn't graduate within a certain amount of time, I mean, obviously there are exceptions and discussions and so forth, like you kind of say, well, I don't know if this actually is going to make it, and kind of just remove it. So
I think that's definitely true in Kubernetes. I don't think we've really formalized that in Cilium, have we?
We haven't formalized it yet.
Yeah, so it's like, it gives it like,
makes sense.
it's come up. It's like, it needs to either move forward, it can't just slowly like die, which I think is probably the worst, because someone's going to come along later, right? As you said, it's like, oh, I'm going to use it. It's like, oh, sorry, like it's actually not functional, right?
I think that's a reasonable, I mean, if we would do something like this in Cilium, it makes sense, because like all the stakeholders that have an interest in this, they want to make sure it's going to become stable over time, right? And if there's nobody interested in it, okay, we remove it.
I mean, we could be doing things like using the annual survey, or maybe we could, you know, have some kind of feedback button on the docs or something that lets people signal to us if they're actually using a beta feature or would be using it if it weren't like marked as scary.
Maybe one of the things relevant, Andre's working on adding metrics for a whole bunch of different features. So like from Prometheus, you would actually see this like export of like, here's the tree. That will also give us usage statistics from CI. So we'll know how well covered the features are in different configurations. But maybe from users or from like clouds, you know, we could take that as input somehow. Like, say,
yeah,
like,
that would be very useful.
Are there anybody using it? Like, well, somebody has a Prometheus.
Yeah, that's a really good point actually. Like because the matrix is so big today. Like you never know if the combination of feature flags that you're using is even tested upstream at all, right? So having that to start with, like as a matrix, at least if somebody is interested in, okay, I want this matrix path to work, the first thing they could do is add a test for that, right? So
I have a question because at least on the Kubernetes side, we've actually had very hard time getting anyone to use alpha. I think beta is a little bit better, but like, are people more comfortable with using Cilium beta than, like, for example, Kubernetes, like alpha is like nobody uses it. So that you get no signal, and it's like, I need a signal to go to beta. And it's like, it's like a chicken and egg, like completely.
Yeah. I don't think we've ever used the word alpha unless we're very, very concerned. We do put it in some of the CRDs, but mostly because we don't understand how to version CRDs properly. I think like as a project as a whole.
But they're not all supposed to say V1 alpha.
No.
I mean, a lot of them still do, but we've never just formalized guidelines. Like, I'm not saying that there's no knowledge anywhere. It's just like, it's not evenly distributed.
I see.
yeah, my sequence today has been sometimes features stay in beta for a long time. And if it's something that's just added and it's beta, I wouldn't touch it. But if it's been beta for a while, and then I've seen improvements go in like over time, then I'm a little more open to trying it out, especially if it's there in multiple releases. Because I know that features tend to stay in beta for a long time, and for the most part, they work. And then I also go to the corresponding six and ask people, what's the gap to stabilization? And people generally link me to one mega issue that has all
I see.
some issues.
Yeah.
So generally that helps me get a full picture of like what's missing. But this is not straightforward to people generally.
Yeah, I think like that's like something, I don't know if we need to put in a CFP or something. It's like, what is the graduation criteria? Because otherwise it's like, for example, I myself have personally experienced like an API that's beta, but literally used by everyone. And then you're like, oh, we're going to graduate it and change it because, you know, that's part of graduation. Everyone's like, like, what did you do?
Yeah, I think we need to formalize it more. It would be good, and then have like an overview page in the docs, and then it might also be a good entry point for new developers, right? Like, where can I help? Okay, like here's the list of things, and maybe if there's something interesting, you can help to graduate.
I think a long time ago, probably our criteria were like tests, but also like somebody is running it in production, is like willing to kind of reference that, like, hey, yes, I'm running in production. It's not causing major problems. I don't think we've been quite as strict on that side since then. Like we've done a little bit more of, no, we're just going to beat it up a lot, and then, but we haven't formalized. It should be one way or another, or like when do we feel confident? And
So a low-hanging fruit, I think, could be if you get that matrix, or if we have all the beta features somewhere, we could explicitly document it and create like a GitHub discussion link for each beta feature and tell people, if you share feedback here and if we have enough feedback, we're going to work on getting that graduated, right? So at least that gives a forum for people to say that I tried this worked. I tried this did not work, right? It's a free form way
I
to
really
just
like
post
that.
feedback.
Yeah, we've been thinking about trying to turn on GitHub discussions in some useful
already
way. And that,
I mean, somebody turned it on. I don't know who, but people have started using it. So.
oh, okay.
I like that idea of a matrix, because you can easily get lost in all the GitHub like issues on their own.
The trouble is it ends up being multi-dimensional.
Yeah.
Well, then you have projection.
We could try to make some effort to say in the docs where we've got, you know, we've marked a feature as being so or whatever, as a link to the discussion there. At least make that discussion or the mega issue kind of discoverable.
One tool, speaking of GitHub tools, is the project board for GitHub is actually really good for this high level, like this CFP is in this state and like moving it.
As long as you've got control over who's changing it, right?
That's true. So like someone needs to kind of run the moving, like the dragging and dropping, but it's like very intuitive. Like, oh, we graduated this. Oh, great. Like, oh, these are still in the queue. Kind of triage.
And one other thing that would also be nice is to remove the, like, where possible, configuration knobs and like just stick to a default. Like if it makes sense and if this is enabled most of the time anyway, there's no reason to have certain knob actually disabled.
Yeah, I think flag
It would
retirement.
remove
Flag retirement is
I mean, and that would also,
because like I think like so we were
to
burned a
reduce the
lot early
metrics.
on. We were like, oh, we just deployed that to prod, and then the tiny little piece is not working right. So like in reaction to that, I think we ended up being like, oh well, if we can turn everything off, then like somebody hits something in prod, we can always like just reconfigure it in this kind of weird and wonderful way, and then it will just work. But by this point, the configuration flags are
too many.
It's not a user interface. It's like a, I don't even know what the analogy is, but
It's like
And the dependencies.
the city built on the city built on the city.
Yeah.
You can't get rid of the lowest city.
I mean, also like in the old days of Cilium, like there were like some knobs, for example, where you could disable like the session affinity support or like some couple of other such features, right? Because maybe people don't need it or whatever. But nowadays, pretty much everybody has it, so we can just as well get rid of it and always have it done.
Yeah, that's one thing I found, like in that feature life cycle, there's like, you know, beta GA, but there's also like the tail end of like, you've added this flag, like when do you retire it? Like kind of tracking that as well.
There was some discussion on trying to use open feature from CNCF. So maybe a parallel effort could be we can have like a completely separate fork of the project where we migrate everything to open feature. This is just me throwing out ideas, but
what is open feature?
So open feature is this feature flag framework from CNCF. Where
Okay.
you basically, it helps you roll out like experiments. You can say
Got it.
enable this on 1% of my nodes.
I see.
Something like that. So it's a generalized framework for everything feature flagging. So like it has lots of bells and whistles. We don't have to use all of them, but I lost my train of thought. But at least use this as a way to like rewrite all of our feature flagging and maybe have some sort of criteria of evaluation.
I see.
Yeah.
So one thing I wanted to touch on is like, we see scalability as like one of the major themes, I think, from what I'm hearing. Like, do we see any other kind of major themes that are coming that like, okay, this is kind of very important for the project?
I think one thing for sure that is coming up more and more is IPv6.
Oh, of course.
And I mean,
we have it.
Hmm?
I thought we have it.
Sure, but the question is like whether it's on the same state as the IPv4. Right?
I see.
Because like much more people like running IPv4 only deployments, but not IPv6, and then yeah, it's definitely coming up more.
Do we know if we have like feature parity in IPv6? Or
they have demanding IPv6 only deployment?
I've seen some users trying to do that recently.
What was the question?
IPv6 only.
Whether we support it.
Oh, that's interesting for us, but we're not.
I do support IPv6 only, but
There is a way to configure it, whether or not that actually completely works for your use cases.
So, you know, like that's a bit of a gray spot, right? So like that's something that needs to be over like for the next couple of years, whatever, you know, like that's something where
that it is work. I mean, Marek and all the people working on that.
Right.
And we did basic works.
Oh, the basics,
I think, yeah.
So then when is these extra things that you identified that doesn't work? Custom Cilium features or community features?
Okay, like one stupid example, right? Like if you would do IPv6 only, what you cannot use right now is tunneling because like it's the endpoint is IPv4. Like you can route traffic over the IPv4 like VXLAN thing, but like
But that's the thing. When I worked on the IPv6 stuff in Kubernetes, 99% is the main mistake is to try. If you try to do IPv4 things on IPv6, I mean, why do you want to do tunnels, right?
sure.
That's the thing that we need to work to educate people. Right?
Yeah.
Why do you want to do tunneling? You have all the peace in the world, right? It's kind of thing. And I think that if we want IPv6 to work, we need to move the people in that direction. If we need to map IPv4 as an island, IPv6 and an IPv4 thing, we're going to fail. I say you.
No, this is the classic IPv6.
No, but but they're moving from the I know the classic, and I'm not against the classic. Right? When I went to Amsterdam, I'm going with one guy from the ATF explaining the problem. We need to be pragmatic, right? So there is one classic thing that, oh, you don't use that. I don't care. Services are good with that. I mean, it works. I don't care. But the other thing is, if I can give any code and independent IP, where I mean, that's the differentiator of IPv6, right? You solve the multi-cluster problem right away. Other pods have another. So you go Aguas, and you go there and you don't have any, and it escapes because it's direct routing. But
I mean, this was okay.
That was just one.
But I'm not sure, like, what's, for example, today, like the CI coverage of all the stuff we test in IPv4, whether we also do this for like policy or whatever.
Very, policy will be more. It's not even based on IPs.
Just as one data point, there was an issue, I think, last week where Cilium connectivity test just doesn't work on IPv6 only deployments.
No, which one?
The CLI test.
Okay, the conformance test.
I believe that.
Yeah, that's okay. That's the minimum.
That's a very good thread that somebody can pull on and say, oh, why is that?
Yeah.
Pods are not deploying is some specific.
And I guess we're not here to try and solve the IPv6
Yes.
problem. I'm saying that is one of the things.
It's like one area where we.
Users are reporting bugs, and you've got like IPv6 dual stack with IPv4, and then you've got IPv6 only, and there's different bugs.
That's why I was asking,
and the coverage
link with the question is, which is, do the stack is going to be broken forever? That's that never goes to work.
I have two other themes. Is every time we build a new feature, like we generally build it for a single cluster scenario, and then whether it works for multi-cluster case or not is always an afterthought. So that is again a hard problem to solve, but maybe in our CFP templates we can also make people think about it on how does this work for multi-cluster, right? I don't know the solution for it. That's one part. Just a second.
To boys, multi-cluster is also a common thing we should be working on.
Multi-clusters, it's clearly a theme. Like in I guess the Cilium user survey, we gather statistics about how the users are using different spreads of
multi-cluster can mean many different things. So is it cluster mesh, or is it Kubernetes multi-cluster, or is it this multi-cluster?
At least Cilium's multi-cluster solution to start with. Like we're doing operator managed identities. And then if you want to support cluster mesh with it, now we'll have to start replicating network policies between clusters. But as of today, that's not part of the CFP, I guess. But because if you just add it to the template, it will force people to think about it.
So it sounds like we need to figure out a way to start deprecating things and adding like a life cycle of features, I guess, kind of. So right now we added a bunch of things, but we don't know how to progress things and how to retire things. So
I think even just identifying them with the CFP process, I think is like a huge step up. Is then you can see like the movement, because otherwise it's sort of like, oh, this issue or this PR is kind of moving, but is it done? Like that PR is done or that feature is done? Like CFP kind of has this formalized life cycle.
Yeah, so maybe that's another question I kind of had. It's like, what do people think of the CFP process right now? Because I think a lot of people have filled out CFPs in this room. Like, what could be improved?
Great, you can talk about that. I wanted to open this up quickly. So when I open a CFP, right, I don't know what's the process, right? How can I involve people to review here? I mean, I can bring this up in dev community sync and then sync policy sync and everything. The thing I am seeing, right, this is from my experience, like maybe experience may be different for different people here. So, I mean, I see at least a welcoming idea, but constantly I have to engage in the I mean, the progress is kind of like getting delayed and delayed. So how can we define a timeline for a CFP, right? So how can we make sure like, I mean, I can ping people, I can make them to review, but what I see like it actually happens in the call when I have a sick policy sync every month, only then it's getting reviewed, and then sure helps me in reviewing in async way, but I don't want to just rely on one person, right? So I don't think there is some more participation in the review, at least as far as I've seen, like because we are working in async, people working from Europe, people working in different regions, so it's becoming very harder to get people to review the CFP and then show some progress. This helps in motivating people also to contribute, in my opinion.
I think something we sort of recognized for a while is that, you know, having Joe and Andre as the kind of
arbiters of everything.
Yeah, like, you know, they don't scale. And Christine's been working on, is it still draft? Yeah, a sort of draft around SIGs and how we can just document a bit better, like how to get involved with a SIG, and the idea there is that we settle on leads. Yes, like a SIG lead would be able to provide feedback on CFP without it always having to go to, like, if they had anything they were concerned about, they'd still be going to Joe and Andre and asking for assistance, but rather than absolutely everything having to be passed through that bottleneck, we'd be able to identify people in SIGs. And obviously there's going to be a whole question of how do we know that they're kind of capable and qualified and what have you, but at least if we document the process, people can start sort of self-nominating. But like, yeah, I think I'd be okay to review in, you know, policy or whatever the scenarios are.
Yeah, so it would be very good, like even if they don't think the idea is like not right, we can go and look back, right? But not if we don't get any feedback or anything on that, it makes me think like, okay, is it good, or like, is it okay to you guys are agreeing on that, or it's something like I have to follow up again and again and again. So yeah, sometimes I will lose the confidence as well.
And I would say I think it's less about defining the timeline, because the timeline's always going to vary. Like in the run up to KubeCon, nobody has time to look at anything. And more about identifying who are the people that, you know, are the right people to reach out to, or the right people to say, please could you SIG.
Yeah, to add on to that, we were kind of trying to define like SIG groups as well, and obviously there's like network policy, it's obvious one, stuff like that, but we're kind of lean with how we're defining and how many processes we're also putting onto it, because like we're taking a lot of inspiration from the Kubernetes project, but then also we're not ready for that formalized method too, so we're still kind of figuring that out. And there is a GitHub issue or a GitHub PR that's open, so people do have opinions, because it's written out, but still needs some TLC. So
yeah, I just show it to you, send it to you.
Yep. You want to try it in the Slack channel?
Yeah, I can also. So as a new contributor, I two comments on the CFP process. I thought it was really helpful that you tagged people look at mine a while back. But it wasn't clear, for example, like how to actually move forward. If, like, let's say I absolutely wanted it. Like in this case, I was kind of on the fence, do we need it or not? Like in which way should we solve it? But it wasn't clear to me until like I got the invite for this from Billy to present here. Who would I have gone to next? Because in that case, the CFP, the BGP guys were reviewing it, and they're like, hey, we should probably lean towards thinking about the data plane, but I don't have data plane reviewers on it. Like, and I didn't know who the data plane people are. Like, how do I get it in front of them to even like pitch the idea? So like in terms of like I'd rather just be shot down right away versus like dragging it out and like having to think. Unrelated, but second comment, the thing I think you guys are doing really well is on PRs and GitHub issues. I'm getting like tons of momentum when I open either. And it's nothing sitting and dragging, whereas I've got PRs on other projects that I have to like pull teeth to get reviewed. So I think you guys are really on top of actually the triaging and like getting the right people on that side of it.
That's great to hear. I'm not entirely sure.
At least on the BGP side, it's all my
people. I do think the BGP side is working a little better than some other.
Because I'm working with Pablo, Radislav, those two from Arrow.
I wanted to make a quick follow-on comment to that, which is in the contributor ladder, which I'm glad we now have. It kind of goes from committer and then reviewer is the next step. And it's always been a little unclear to me whether that's actually helpful and when it would be helpful, right? Like they have a new contributor who's suddenly giving opinions on PRs. Like hopefully they know what they're talking about. But is that actually helpful for the project and in what context? And so I'm curious, like, you know, is that something that you need more help with, or you want folks like actively reviewing, or is it something where, you know, maybe there's other ways to contribute first? I'm just, it seemed a little unclear to me if that's the right next step.
How do you become a reviewer? Like, do you just self-nominate, or?
That's what I don't know.
So
Like, do I just start commenting?
Also, there is one more confusion.
I think,
Yeah.
yes, feel free to do
Yeah.
that, right? I can't remember exactly what we put in the contributor ledger about how you become a reviewer, but I think Jay made a really good point in a conversation we had a few weeks ago about how, like, the reviewer is actually the reviewer status is actually super important, because the person who hits the merge button hasn't necessarily reviewed, or, you know, they've got the commit rights, but they haven't necessarily got the expertise to review. You know, they're committing across the whole project, whereas the reviewers are sort of much more specialist and, you know, looking at the details. And I don't know that we articulate that very well yet. And maybe we need a kind of, I can't remember what we talked about, some kind of like reviewer onboarding thing where people could sort of start reviewing. And we want people to think like, yeah, they can.
Yeah, we want
Their
to
input is good, but we want to say, okay, once you've reviewed a certain amount and you've built up the trust that, you know, those review comments are helpful and useful, then we want to be able to start saying, okay, they actually are a reviewer, so their review flag means something.
So yeah, like this. I mean, I have so many thoughts on this, but so like what does a review do? Like, yeah, they give an approval for a specific area, and depending on which areas of code base, that's going to potentially allow that PR to go all the way in. So there's some degree of like they should be the expert. Secondly, they're part of a group that gets auto-assigned, and there's kind of some degree of obligation or expectation that if you're in a code owner review group, GitHub is going to just hand you PRs to review, and you should probably get to them, you know, at some point. Like at some point they'll kind of stack up, and then like everybody's waiting on you, and probably people start pinging you. So there's a little bit of social pressure on that. But then, you know, if you're heavily involved in the project and expert in an area, like that's fine. It probably makes a lot of sense, right? But then if you're coming into a particular area, maybe BGP, you're like, oh, how can I help the project? But I don't yet feel that I know all of how Cilium works of this area.
Yeah.
Maybe the scope is not as clear as just BGP. It's like kind of, you know, policy, as it turns out, has a whole bunch of different areas, which the scope is actually quite large. So
crossing
then
that
how do you get to that? And that's something like we can create links for all reviews for SIG policy, and it'll be just all the PRs that are currently open requesting SIG policy review. And these links are very easy to generate with GitHub if you know quite how to create them. We've bookmarked them for the existing SIG Slack channels. So as somebody in the community who wants to, you know, maybe become a reviewer, you can go and find that link and manually go and review things. That will help to build your reputation, I guess, in the community. Like, people will see
That's a
what
good point, just kind of
asking and like
dropping in and giving feedback.
That's a method. It doesn't have the green check mark that gives you that feeling in GitHub. It's a gray check mark, but like, I don't know.
I don't know, like Jordan, you just kind of onboarded into certain areas, like what was kind of.
Well, one thing I was going to mention is there's been a few instances where I want to add new test coverage. It's like swinging up my mind, and it's hard to do that without committer rights, I think we found. So I needed to get help from you, right? I think I'm wondering if that like level of you know, permissions is really should be required to just, you know, casually, I want to add a new test case to X and make sure it works.
So that I think is a specific use case. Like I would say the percentile of people who are actually trying to modify CI at that level is rare.
Really?
Like most people would be writing E2E tests.
I think one thing is like the GitHub workflow infrastructure, and I think there are some quirks about how we do testing that for some use cases, you do end up having to write some changes there.
Yeah, actually, I was asking Jordan if you could talk about
Sorry, that was my pet peeve. and I was-
Well, what specifically? Well, like, you know, you were grabbing, I guess, like bugs in like a certain area and basically like kind of doing, that's what I found is like, yeah, you might grab some bugs. Some will be hard, some will be easy, but if you find the easy ones and kind of take them to the end, like that's a good way to kind of get in the loop. With the understanding that sometimes you'll grab a bug and it'll just be like, yeah, we need to refactor all of Cilium to like fix this. Like, okay, I'm not gonna work on that one.
Yeah,
The first one.
the labels are helpful, like, so just say Datapath or whatever I'm interested in and just go through and I want to fix this or that. But then again, you never know if it's going to take like a month or a day.
Yeah, so you should probably just like cast a wide net and you know, if it's not working out, then just like, yeah, like move on to like something easier.
I have some more thoughts on the reviewer mid stage in the ladder, right? So I feel like putting out your own PRs is one thing because you have full context on the change you're trying to make, what's not working and what's working well. But when you're tagged on somebody else's PR, you'll have to context switch and first of all, try to understand what they're doing in the first place. So before you become a maintainer, like you're expected to do all of that reviews. And like today, I think Isabel is doing all the heavy lifting, but like ideally you're expected to be able to context switch into so many other different threads. So having this middle stage of like getting tagged on PRs, so maybe you've contributed to a certain subsystem, you're familiar with the code base. So being a reviewer, because you're familiar with the code base, you've made some changes already, I think would kind of test like how much commitment these folks have, because it is a lot of responsibility. Like I find it hard when I get tagged on a PR I have no context on to like try and understand and validate. First of all, it could be a race condition that is like super hard to reproduce, and then there's a fix. So sometimes the author does a good job explaining what the race condition is, sometimes they don't. Now you'll have to maybe spend a couple of days on it to actually fully understand and give valuable feedback. So I think it's a good middle ground to start with. Personally, I would say like it's a good step to have, and people who are really committed would learn and also like have an opportunity to like tell the community that they're committed to the project, right? So it will be easier for other people to nominate the person because they've reviewed a bunch of stuff. Because it saves time from maintainers.
And I think that's the main bottleneck, right? Like the reviewing part to make sure change looks good and has all the necessary ticks. I mean, to be honest, I think sometimes like for some PRs, like in where GitHub automatically pulls some people, like too many people are pulled in, like for whatever reason, I feel like, right? So maybe in some cases it's
tricky if you try to do something tree-wide, that's for sure. Yeah. Sometimes you can break it up into like a few code owners or something, but then you end up with 5 PRs. But I would actually rather that because I know that, like, so CNCF publishes stats, like the div stat stuff, and is it LFX insights. And you can see, like, depending on the size of the change, it's this massively exponential time on like how long it takes for the thing to merge. So it's like 1 to 10 lines, it's maybe like 3 or 4 days. Once it gets to 1,000 lines, it's like 3 weeks or like on average, right?
Each line has a probability of like zoning out.
So I guess the question I have is how many folks have successfully crossed that chasm from like, hey, I've made some commits to, okay, now I'm in the reviewer and maintainer. Is that something that we're seeing success with? Is it still a work in progress?
I can speak as a non-isovalent person. Like we've had 2 people in our group kind of cross that chasm. Like one is Georgie working on scalability. You also working on scalability and some other stuff. Yeah, they basically were like for a year kind of really invested in that area, and I think they understand the obligation. At least that's what I've been telling them. Like you're reviewers, and you should be looking at not just your stuff, but like other stuff. I don't know. Like, I hope they're doing well.
Did they just starting out? Did they just proactively look at the list of pull requests and comment on whatever they thought they could help with, or was it more like eventually they did a lot of PRs and now they're on the list and they get automatically?
Oh, you can ask Joe.
So they had clear goals, right? Like Jorge was working on stabilizing CES, right? And I think I don't know if he was part of the original implementation, but they had clear goals with CS, just working on it. It's necessary to like have CRD scalability. So, and it's involved work, right? Like it's almost replicating Kubernetes and point slices to like Cilium and point slices, and also making sure it's scalable, backing them with tests from GKE or whatever. So there's enough work there. So, but if somebody who does not have such a major work stream still wants to get somewhere in the ladder, I think that's the unstructured path today.
So one more thing, right? So Cilium has like different areas: scalability, policy, agent, data path, and everything, right? So, and each some area may be very, very small scope. For example, SIG FQD, and there is area for SIG FQD, and there is area for SIG Hubble, right? So some SIG policy is very big. So what is I'm just getting the clear requirements for each area, right? So some areas you may have only spent this many PR, this many reviews are quantified. On some area you may need to have more time to get to that state. So I'm not understanding now. So the people should focus on one area here and then get only the, if a new contributor coming, right? So they wanted to like climb the ladder now. Now they want to know about every area. As Hemant mentioned, like you can go to any PR and then learn reviewing the PR and then you can learn. But their focus should be on one area to get this climb ladder, or they can focus generally and we can make a decision there. Or else like they have to focus on one specific area like Datapath. I'm going to only work on Datapath. I'm not going to care about the agent or policy, anything like that. So how are we defining that? What is the requirement there?
So I guess it's always going to be harder for somebody to spread themselves thinly across, a very complex project. So I suppose if somebody came and asked, I would probably recommend focusing on one area because you're likely to be successful that way. But I wouldn't say we can put it down as a hard and fast requirement. I think one other thing that we really want to steer away from, because we have seen people trying to game this, where you don't want to say, you have to have reviewed however many PRs, or you have to have had however many PRs accepted, because it's going to depend so much on the complexity and how people interact. If somebody needed really guiding by the hand through every single line of a PR, that probably means they haven't yet built up enough knowledge to go and advise other people. Whereas there are some other people, they've already done one major change and people have gone, oh, they've really internalized that. I'm really impressed. I'm totally generalizing. I think it's much more about how that individual interacts and shows their expertise, shows their learning, and shows how well they communicate as part of, not just the technical work, but understanding it, communicating it with everybody else. So I think that's where we wouldn't want to say a quantified approach to climbing up the ladder. But I do think we need to do something more, like I'm hearing it, you're like, is it okay to comment on PRs? We need to articulate that better, clearly.
Well, yeah, and also I think else, part of the reviewer thing is I don't want to degrade the new committer experience, right? By having some random guy from Microsoft coming in and like, like, oh, you should change this or that.
I want to create noise.
Exactly.
Yeah.
Like I want to help move the project forward without degrading what is already a pretty good like new contributor onboarding experience.
How do you guys feel about carving a big space into smaller? For instance, we have this one CFP where my team member is kind of rewriting how Hubble metrics is done, right? And then can we carve out SIG Hubble into SIG Hubble metrics, where he has effectively rewritten the files, and then he can be a reviewer for those files.
Yeah, and this maybe touches on what you were talking about. Like, you've got
It's a
something
very
big,
big SIG policy, right? So,
yeah, I think we're open to it. Like that's definitely an option. I think identifying specifically, having an example like that is actually a great discussion. It's not that. You've got aspects of expertise just in the area, like you could say, well, maybe we just throw them all out. We say, well, you're either C or Go, right? And you're like, okay, well, in theory, yes, but in practice, maybe you're working on Cilium endpoint license, all the scalability impacts that so how do we divide it up partly based on expertise? And that's definitely one aspect of it. another aspect, maybe when it gets to say Hubble, for instance, is that I think if we split it up into smaller groups, is it substantially the same people, or do we have different people, and is there an interaction between how those groups are managed? But maybe if we see that, say, splitting those ones up, and that's a pathway to be part of all of the Hubble parks, then maybe that helps. You know, like it might make that easier for you to say, like, okay, can I be a reviewer here? And then that's you learn more
gradually
and you
move
go.
up, like become like part of the bigger tree, right?
So, what do we, this last one?
Yeah.
What do we think about if we delegate SIG leads to create sub SIGs within their SIG? Like, let's take policy, right? So we could have FQDN, CIDRs, whatever, L7. And then there are people working on each of these areas. So the SIGs can manage, like, okay, who's reviewing the subcomponents? And maybe the leads can actually be responsible for making sure the person grows through the ladder. Because right now, who nominates whom is also like a very unstructured thing. It happens.
Is there a role that the GitHub automation plays versus like a more fine-grained automation? For example, I know that Kubernetes uses like prow, in which specific files could have like owners and specific, like you can have a reviewer set that's like way more fine-grained than just SIGs. Because we don't want to end up like SIGs be like everyone is in their own SIG.
I like that because
We've shied away from putting specific username owners of files. Just
Yeah.
like.
But I'm saying like there could be groups, but it's just like.
I like the idea of having more fine-grained groups, so because as like a new contributor, it's like, well, I made a few PRs to like the wireguard page or something, but does that entitle me to be like commenting on everything Datapath or something? That probably not. So like to be able to incrementally kind of gain experience across different things.
The flip side is the point that Daniel brought up is like you make a change across the tree and suddenly there's like 50 different groups. So like that's the
But I feel like
trying to.
Yeah, somewhat that's inevitable though, unless you're like making like spell check changes. Please don't spell it, by the way. So it's like you're gonna have a broad announcement anyways. Like I am changing like this.
And maybe for that particular case we can't just be better at communicating.
I think what would probably help, I mean, I do like the model of the Linux kernel where you have this maintainer file and then there's for some specific sub thing, let's say a group of reviewers or people that are domain experts in a specific area. And maybe coming also back to the SIGs, maybe we should have like a file in there where we list all the SIGs where it's easy to find and like.
So there are files like this. Maybe the form is not great, or maybe it's not.
I think the code, code owners is
but there's also in the Cilium community, there's the whole kind of structure.
Yeah.
Which is.
I don't think is super.
Yeah, I think it's like not as discoverable.
Yeah.
Yeah.
I think this is what that 6 PR is.
Okay,
Starting
so maybe we can segue to
Yeah.
Bill's.
Yeah, and we do kind of have to like, we got the other topics after this. So I guess maybe the outcome from this discussion is like, we need a better way to get people from like I'm a board member to I'm a reviewer. And maybe it's like breaking it up smaller, or maybe it's like getting people into SIGs. And so it'd be great to have people to look at this PR from Christine. And kind of like the idea behind the SIGs is to kind of like start breaking the project into smaller parts that people can kind of get involved in, rather than showing like I'm at the developer meeting on Wednesday with 50 people, right? It'd be like more like the ones that we're thinking about right now are that are actually kind of working right now is like policy and scalability. Like for instance, those ones actually have meetings and kind of like leads that like we'd like to, I guess, kind of like formalize those once this goes through. It'd be great to have like, if people have other ideas about like what the SIG lead should be doing. If there's some other discussion now about maybe having them like manage the like code owners or like getting the reviews or getting people, encouraging people to review it. Another part that we're like thinking about in here too is like reviewing the CFPs and managing like the CFPs in their area to make sure that they go from, it's not just kind of like sitting of like, this is an idea I have and it just sits around. Because like David was saying, like it was, you didn't know who to take it to next. And so it'd be great to have be like, okay, this is a BGP one, go to SIG BGP and either go to their meeting or talk to the lead, and they'll get somebody to review it, like that type of stuff.
Yeah, and like PRs that are open in that specific area or issues, right?
Yeah.
Like to at least make the community aware, and maybe somebody could jump in and help out.
Yeah, exactly. And then the rest of this PR is about kind of like the creating like a very simple charter. Like we're trying to create like a very kind of like lightweight way of doing this. So it'd be great to have some reviews on this PR. I think that's where I'd like to move the discussion, because we do have to move on unless anybody has like two
I think
cents.
that's super related, right? Because
Yeah.
we want SIGs to be people who can review in areas
Yeah.
and yeah.
Yeah, I do think, yes, it's like a mechanism for, being able to like, okay, I don't have to like eat the whole project.
Yeah.
It's like, I don't want it in time.
I think there's a lot of great possibilities there. I think we also need to recognize that the group is not that much larger than who's in this room. So like like if we had 20 different
Yes,
SIGs,
that's-
it's basically
you don't want
like
to be a SIG by
everybody is
yourself.
running their own SIG. And like maybe we should focus on fewer things. So that maybe links to like what you were talking about. But scalability is like one of the primary things. Like, like the SIGs we do have are driven by clear need from like several people like saying, hey, I'm interested in scale. Okay, let's set up some infrastructure around that, right? Yeah. So
Before we move to next topic, like something that skipped my mind came back. So I think we should also, I know if internally ISO is doing something, but I think network policy experience for users, the user experience part of it is something that we could maybe collectively look at. Like internally, we support a lot of users trying to write their own network policy, and it's absolutely not intuitive. They find it really hard. So to a point that when their packets are dropped for some reason, they just give up. And if we ask them to debug a network policy, they find it incredibly hard. One, because there are lots of features in it, and unless they're spending a lot of time writing network policy, it's not super intuitive. So the question really is, if we were to rethink network policy, and from a user experience perspective, will it look any better? Can we do any better than what it looks like today? I mean, for people in this group, I guess our heads are kind of wrapped around it, so we kind of understand how we are writing it. But people who are new to the project, mostly they're backend engineers. They just want to deploy their app and walk away, right? They don't enjoy reading Cilium documentation of what are entities, what should I worry about now, what's an API server entity, what's a world entity. But when I mesh them together, what happens to my cluster entity? Is cluster now all of them together? Like it gets so involved to a point that a centralized team needs to be involved to like review it. So can there be an abstraction that simplifies how people express policy, network policy? It's a super loaded question.
Yeah.
Are you thinking more from like an API perspective?
We may want to put a pin in that one.
Yeah, I mean, this can even be its own SIG. Like, how do users write network policy? People who are not necessarily managing Cilium, but
We won't go on to it, but we were talking about this during lunch, like network policy.
Okay, so
It's like,
yeah,
we have multiple people.
Yeah,
That's great stuff.
Add it to the themes.
Yeah.
Okay. All right. Next.
Yes. So I just wanted to give, for some people, there's going to be a recap here, and there will be some new content too. But I wanted to give just a little bit of an overview of what we're going to do with XDS, what we've done so far, and what we are currently working on. Because there's a lot of themes that don't seem directly related to XDS, but they're all trying to, work toward the same goal. So basically, why are we doing this? We want to provide a better load balancing behavior by completing a feedback loop. You'll hear feedback loop a lot in what I'm saying. Kubernetes itself is not well equipped to do a feedback loop, in my opinion. And by that, I mean getting a lot of metrics back to each individual data plane, where you have a data plane on every node, is something that I have not found a good way to scale in Kubernetes server. And then simplify integration of endpoints from other sources. In GK, we're very focused on like other clusters or environments, but I can imagine that extending way beyond that. And then probably further down the list of just, can we please connect this to other like XDS control planes? There's a whole ecosystem out there. And way back in the day, there was this blog post from Matt Klein, who's one of the founders of Envoy. And he had this vision that Envoy, the XDS data plane API that Envoy uses, would become a universal data plane API that would be used by many data planes. So far, that is basically just Envoy and gRPC, but we would love to see that go further and particularly get into Kubernetes ecosystem a bit more. I know Envoy is already, and gRPC are already very much in Kubernetes ecosystem, but yeah. So motivation one was topology aware routing. This is probably the most generic and probably, hopefully easiest to understand. You probably know that by default, Kubernetes sprays traffic everywhere and doesn't really have any idea of what zones are. It's just, which gets very costly if you're on a cloud provider that charges for traffic going across zones. We have a really simple thing in Kubernetes, which is just, we'll keep all your traffic in the same zone, which is great. And that's Cilium 116, so yay. But also it has a lot of sharp edges. And one of those sharp edges is that if you don't have enough endpoints in that zone, overloaded, things blow up, bad things happen. So yeah, the local endpoints getting overloaded, significant risk. And it puts a lot of the weight onto users and customers to ensure that there's always enough endpoints in each zone. And there are a lot of cases where you have a small number of endpoints where instead of spinning up an entirely new endpoint, you'd rather just, 10% of your traffic spill over to somewhere where you have capacity. But we can't do that in this world because we don't have a feedback loop. So if you imagine what people actually want, it's, please, can I just keep the traffic closest to where it originated from? I want to minimize costs. I want to improve zonal isolation. And, fill the closest endpoints to me and then spill over to the next closest endpoints. And then you get to this very fun problem of what on earth does full even mean? So the working theory is it's some combination of CPU utilization and active connections. And although we can try and have some sane defaults there, it's going to be near impossible to have a system that works for everyone. So it needs to be somewhat configurable by users. And the problem is, well, hold on, Cilium just doesn't even have this data. You need access to endpoint connection data, basically how many connections are coming to this specific endpoint. And Kubernetes APIs, as I mentioned before, just are not capable of handling this level, this amount of data propagated so frequently. It's imagine like, I'm familiar with endpoint slices. I spent a lot of time on them. This is many orders of magnitude more complicated than that in terms of propagating the data. What I think is unique about XDS is that it's well equipped to solve these problems. There's already a load reporting service that is in use at very high scale. There's already this centralized control plane that understands these concepts of spillover, load reporting, etc. And then there's this very important detail in XDS, it's Delta XDS, which is this very cool concept that you only propagate what's actually changed. Which is something we don't have in Kubernetes. I mean, we have it at a resource level, but it's much more fine-tuned here in XDS. This other one, I'll just very briefly cover because I know we're short on time. Endpoints from elsewhere. I'll focus on multi-cluster service, but basically the idea is in GKE we have this centralized control plane we call traffic director, and to make multi-cluster services work, you need to basically sync all your endpoints from all your clusters somewhere, and then distribute them. At least this is the pure Kubernetes multi-cluster, whatever model, and then you end up with this mess where we are taking XDS from our centralized control plane, translating it to Kubernetes, and then translating it back to Cilium, and we want to remove that step. That's it. That's all. But you can imagine that maybe you're not doing multi-cluster the same way. I know most are not. But maybe you want to have endpoints from VMs or different environments altogether. This is a nice generic way to do that, where you don't have to feed everything back through Kube API server. So yeah, that's I think this is useful more broadly than just that multi-cluster service. But let's talk about what we've actually been doing. I would split this up into 4 different work areas, and we already have added metrics to track active connections. Thank you everyone who helped review that. We have a whole bunch of PRs in progress. Thank you, UC, particularly for helping with the StateDB work. We've been trying to help out too, and we've been trying to make sure this goes forward because we want to have this kind of common interface for data sources, whether it's Kubernetes API or XDS, and we view that as StateDB. And then we want to add this basic XDS client. That is also in progress. And then the final step, putting it all together, is actually report the metrics we already have via load reporting service. So that is where we are today. I want to give credit where credit is due. As you probably have noticed, I'm not doing basically any of these PRs. So I want to give credit to the people that are. Katarzyna, Damian, and Alexander was. Their username, their GitHub usernames are in bold because it's maybe difficult to map, GitHub usernames to actual people.
Especially Awesome Patrol, who I didn't know who that was, and I kept talking to them. I thought it was Damien. I was like, why aren't you responding?
Which one was it?
So those are great people, all based in Warsaw, so so for time zone. But yeah, just so you know, traffic distribution that went into 116. Active connection tracking, a lot of those things went into 116. Damien has been helping a lot with StateDB improvements, or just link PRs. I can share these in Slack or something. But just so if you're curious, there actually are things happening. I know it may just seem like things are just paused, but I promise things are happening. They don't all say XDS in the name, but they're all related. And then we have a few things open for review right now. There's the actual PR that adds the XDS client. We're doing a bit of refactoring, so we kind of, Katarzyna specifically commented to hold off just for a minute because we got word that there's going to be a standard Go XDS client finally. So yay! But we're trying to at least, we're not going to wait for that to be live because that's 6 months, a year away. But we want to at least make sure that our interfaces match their planned interfaces. So when it's just going to be a plug and play kind of thing. Then some megaliths report and StateDB for the per service load balancing. And then this last one I want to call out is kind of interesting. Shadow instances in StateDB is this idea that StateDB can track endpoints from different sources. And so if one of those sources goes away for some reason, you still have the endpoints from the other source kicking around, which could be useful. Yeah, so that's a really whirlwind update. Happy to talk about anything. Yeah.
Couple of questions. How does this proposed MCS system differ from what Cilium already has today with cluster mesh? I think with cluster mesh, you can still do the multi-cluster service support, still do the global services. So
I am not an expert at this, but my understanding is Cilium service mesh. You don't have
Cilium cluster mesh.
Cluster mesh. Sorry, yes. That does not have global visibility while endpoints, right?
It has visibility of the endpoints that you declared as global.
Okay. So you're opting it. How are they propagated today? Is that like
that replicates?
Oh, yeah. So this is just another way to replicate it.
I think the MCS feature is also not super well used or documented. I don't know who's using it, but
Sorry, which one?
So
the Cilium one, the
Cilium
one,
the Cilium one.
I see.
The Cilium one with cluster mesh has support for MCS to some extent. Like my Cilium con. Again, there's a GitHub handle I'm trying to get. Mr. FreezeX.
He's an odd one.
I've seen a bunch of MCS related ones. I just want to make sure there's no duplicated effort for the
Like,
MCS
don't
support.
think we have a Mr. Freeze.
I'm pretty sure he's China.
Yeah,
Oh,
probably.
Yeah.
Okay.
He's.
Yeah, and if I don't have traffic director, how can I test this?
Yeah.
Will it be compatible with this TOD or like any other?
Yeah, I don't know which, so Istio, sure, I don't think we wanted to pick winners in terms of the control plane. I think for the sake of testing, we talked about it in the CFP, it's kind of like reference XDS control plane, but is good enough for E2E testing, make sure it works. But there's a lot of XDS control planes out there. I don't know if we were to say like plug in Istio, that might be controversial. I don't want to wait into this.
Right. So like if I pick the XDS control plane by today from the Envoy project, I think it has some boilerplate code. What's the delta between whatever we would need to run in CI to test against these features versus what the Envoy/XDS control plane already has to do? Does it already have?
I think that was one of the ideas, the proponent, sorry, the like, this is how you test it, is to take the Envoy one time.
Yeah.
So
So
that was like,
already go control plane and Envoy that.
yeah.
Yeah, we can reuse. The fundamental difference though is what the data looks like, right? So you need to populate data somehow, and you need to agree on how it's going to be represented, right? Because XDS is not Kubernetes API, so you need to have a mapping from Kubernetes APIs to XDS, and that's like detailed in the CFP and now in the Envoy in the XDS client. But basically, it's just how we think it makes sense to map concepts. Like I think you're pretty familiar with XDS, right? But okay, all right. But yeah, but there's similar concepts of endpoints. That's a thing that maps very well. But then very confusing terminology is in XDS, they have a cluster, which is what we would call a service. So that gets really funky. But then, so there's some little things, but anyway, most of the cluster IP load balancing kind of features map very well into XDS because, well, that's what it does very well. When you start to get outside of that space, it just doesn't work that well. So what we've proposed is just we're going to do cluster IP load balancing, like focus on this topology concept, focus on maybe we can accept endpoints from other places, and just start there.
Yeah, for full context, like we are also have a leg. Maybe Rob has like 3 legs. In the XDS side, so the XDS folks are actually very interested in expanding the use cases of that. So like while today it might seem kind of awkward, like they're really interested in understanding like, okay, if some stuff from Cilium is like controlled via some XDS control plane, like what is like a better standardized XDS representation? So it's not like, oh, XDS is kind of weird, it'll never change. It's like actually that one is all evolving as well.
Like the next iteration of this presentation, if we were to remove traffic director, the control plane, how far are we?
How is it useful to non-traffic director?
Yeah.
Or how are we maintaining this? So
yeah.
But I'm probably asking different questions. But
like all of these PRs, they need to have E2E tests, right?
So I think
something.
So yeah, so
do they not need them?
No, so I mean, there's a lot of things that kind of stand on their. They're working towards this vision that we want for XDS integration, right? But you think about, well, we're just going to publish active connection metrics, and those are published via Prometheus, right? And so we also want to publish them via load reporting eventually for XDS, but we already get, and all these state DB improvements are like, yeah, we want to use them for XDS, but they're just fundamentally useful to the project.
I was going to mention that, yeah.
So we're not trying to just like shove a bunch of code in that is completely disconnected from the rest of the world, right? So no, that is absolutely what we're trying to do. And then the last part of how is this actually useful? I know topology is kind of it feels like a niche thing, but there are a non-trivial set of users that will come complain to me at KubeCon because our solution is not great right now. And so it's an awful lot of work for just that one thing. I think it unlocks a lot more things, but at least that there's a lot of people that just want this to be better. And I think that's generically useful on any platform.
But I still hear we do need to have a story for what is a canonical XDS control plane.
Oh,
Not
yeah,
canonical,
definitely,
but like
yeah, we want
a
that
functional
reference.
XDS
Yeah.
control plane.
Yeah, because I'm.
I mean,
I'm
at minimum
ask-
for CI, right?
Yes.
Yeah, exactly.
I'm asking that question because internally at Datadog, we extended the Go control plane to build our control plane.
Yes.
So I know that there's some delta, but I don't know how much is that delta, like just enough so that we can use it in our CI. And people can swap it out with whatever they want. But does the Go control plane come with like a Kubernetes plugin? That
It does
people-
not.
It does not, okay.
So that's what we'd have to add, and that's
So one question I have. So you mentioned the full, right? Like if the zone is full, the endpoints can spill over to the next zone. What, I mean, you mentioned like there are two metrics like active connections and CPU cycles.
Yeah.
So you get this metric from every node? Like how do you determine it's full? I'm not getting
yeah.
it.
So if you the idea is to determine that an individual endpoint is full, and so we already have CPU utilization per endpoint.
Endpoint like here represents node or pod. Okay.
And then at the same level, we're trying to get the number of incoming connections to each endpoint. And that's the thing that up until this work, we didn't have. So you combine those two signals and we believe that's sufficient to have an idea of fullness.
But it can differ, right? Like maybe some zone have, I mean, depends on the resources allocated for that endpoint.
Yeah.
So can it differ? Like one endpoint can have like different, so you cannot have like a.
Yeah, I think you're thinking if like a deployment has like a heterogeneous resource size.
Yeah.
I think you might need to, for it to work, you might need to make some base assumptions like it's like a uniform deployment, which in most cases I think it is, because you use Kubernetes deployment, you're not going to like template out everyone. I do have a question on StateDB.
Before state.
Oh, yes, okay.
Because that's loaded too.
And then we have like 5 minutes for this, so time. So.
So internally, we are also adopting gRPC based control or gRPC XDS control plane or whatever. So there is a variant that we're building of the XDS control plane that works with gRPC. So I understand that there are some differences in, I don't know if it's the API or the spec, but I see that that's probably the future because you have a proxy-less gRPC is directly getting updates. So how compatible is this work with, if Cilium needs to support, or I don't even know if Cilium needs to come in the picture here because gRPC can maybe discover it directly, but how different are both of these works?
Yeah, you know how Bowie mentioned I have like 3 different the team that is actually working on a standard Go client is the gRPC. So they're very aware and cheerleading for this to work because they want to see XDS go in more places. So yeah, definitely trying to make this all make sense in a broader ecosystem.
I think there was one issue upstream on somebody trying to ask on how Cilium's control plane could provide information to gRPC directly.
Oh, well, send them the
Interesting. Yeah, send them. I could use another leg and then.
Yeah, it's fairly.
I could take those statements. I was just curious because it's such a useful data structure. Is it going to be used not just for services, but like for other things?
Yeah, I think so. Yeah. I mean, like right now, UC is focused on migrating the service handling over to it, and like the faster we can get there and retire the old cloud, and faster you can also try other areas. But yeah, that will definitely.
Yeah, I have maybe a comment there because I think there's potential to change the way that we flow data from different resources, from different sources into the data plane. It provides a very structured way, and then we can rework the way that you do debouncing and a whole bunch of like and all this sort of stuff. So I think this actually modernizes the central core of Cilium in a lot of ways.
Yeah.
The challenge, of course, is we have this prod, hardened piece of software, and now we want to rewrite all of it. So like, what is our transition plan? How do we make it kind of, get to, like, we want to retain the level of quality that our users expect, but deal with this tech debt really and modernize the code base. And I think like the cool thing about the load balancing stuff is like, we've kind of, as a project, I think we said like, all right, like let's put this on the package experimental load balancer. It will be experimental for now. Obviously, that's not the long-term plan. We want it to be used by everybody, right? But that's also kind of giving us more ways to explore how Cilium should look in the future.
Yeah, I love this DTB stuff because it's kind of like the introduction of this like relational database where you decoupled components because of this like schema in the middle, this concrete schema. So anyways.
Maybe that's
I'm a
another
big fan.
long-term direction.
Yeah.
I think, yeah, there's something.
I'm actually hoping maybe like by Cilium, I don't know, like 1.18 perhaps we can fully move over, like depending how much help we can provide UCU from all possible sites, like to migrate over. But
yeah,
it would be nice to get there as fast as possible. But yeah.
The question is almost stability. How do you?
It's like all test-driven development, right? I mean, like you need to make sure that the behavior is the same.
I think there's like at least 3 times more work in there than there's just a refactoring.
Maybe let's explain a bit the history behind it. Huh? So we have a problem in SIG network that we are slow and we are very slow bureaucracy, and all the project networks need to move on, and we know that we are not fast enough, right? And ideally, what I'm telling SIG network for the ones that you don't know Kubernetes, and the spirit that we want to try is to standardize in APIs, but we realize it's impossible to agree fully there, right? So we have tried to be a bit more pragmatic now and to say, let's see what is the minimum that the people want, right? And let's give the people that develop networking features, frameworks, and a way to move fast forward, right? But being able to coordinate these two things. We were talking about network policy, right? There was a group of network API policy that is lasting forever, and then everybody do their things, and now we try to consolidate, right? We'll try to avoid that, right? I think that nobody wins if everybody wins if we have a nice API, and then the best implementation win, or whatever thing, because that is the key of Kubernetes, right? Portability between applications and all this stuff. This is an introduction, right? But then we are going to focus on the multi-network problem. Right. This was a similar situation. People come with different background, different ideas, different things of multi-network and try to do the same. Long discussions, a lot of problems with implementation, and it was at one point in time to get an API and then decide, oh, everybody can do their own API and their own implementation of the API. And I mean, I've been in OpenStack too. That's how it's working, and that's how it doesn't work at all. So that discussion kind of ended soon. And I was really, I mean, it was really clear from this discussion that there were real issues stories that we want to solve in Kubernetes, right? One, it was, you know, this is super hot. This all these RDMA interfaces, whatever. But this is really a no-brainer, right? Then the other people that was very vocal was from the storage. I think that they have these appliances in data center, this NAP, I don't remember the name now, right? And they use this model of, I have these VLANs or these interfaces in the nodes, and I attach the pod there, right? Really simple and really simple to do. Then you have all these tables, right? With all the CNCS, or CNCS, CNN, no, right? I added another letter. The CNF thing and the put two additional interfaces, all these architectural things, okay, well, that's another use case that was strong, right? They also already have paper there already doing that. Then I'm working at Google, right? And this is a very common use case. We have the concept of VPC, right? And then pods maybe attach different VPCs. And then the last one, this is the more controversial, is people want to build clouds on top of Kubernetes, right? And this is the one with more friction and the one that just totally shut down the multi-network. Because this is not a problem that we want to absorb in Kubernetes code, right? But this is a problem that we want projects like Cilium to absorb, right? That's what is the value added, right? Is Kubernetes is an orchestration application, right? And it cannot be it cannot try to be everything. But then there are projects like Cilium, well, I'm talking about Cilium, we're here about Cilium, that you can absorb this problem, right? Because it's really what you solve, right? All these network connectivity problems, all these things. And that's what we want, right? We want to have a core in Kubernetes, common APIs, and we want this project like Cilium to say, we want this standard. And then we want to facilitate their life to say, okay, people that want to send, we need to build the necessary tooling, APIs, or whatever for these projects to grow on that and benefit Kubernetes in this way, right? As a side conversation of this, another project that I said, right, KNI, is the problem is it was clear, right? Okay, I want to do develop network things, and I need to use CNI that is not even part of Kubernetes. I don't have clear how the kubelet works, and then I need to do these basic things of going through the API, come back, use CRD in one side. I mean, that's a mess. I mean, I think that all of us here are burned out by this situation, right? This is a diagram of the Kubernetes. How it works when you create a pod is two steps, right? You run pod sandbox, this goes to the runtime, and then it runs CNI ads there, right? And what's the problem with CNI? And I told this Casey, and Casey hated me for this. The problem is that it's an API that is not, it means to use chaining. And that means that, or you are part of the chain, and you need to do a lot of food. And I was talking with Casey and said, yeah, we had this problem with Cilium in AWS, right? They have their own CNI, and we need to work around this problem, right? So this is another problem that was clear that we need to solve, right? So, well, this was the line, right? I mean, you suffer this. If you are the CNI, cool, everybody has to adapt to you. But if you are not the CNI, then you need to work around the problem, right? And then it gives you to all these places, all these kind of incompatibility things. Then you have all these service mesh problem. Okay, we were talking about this, you don't know all the stuff. If you own the hood stack, cool. But if you don't own the hood stack, you enter in a lot of friction problems. So I started to work hard on this problem. Right? I get into the guts of the kubelet. I was talking with the container runtime. I started in Paris. The thing that when I went to talk with you to the device, we presented this in Paris, and please give the feedback. Give all these problems that you have, we need to try to solve. And it's when I told you, you told me we need to do this, and I understand, right? You cannot wait for 200 people in a cab to discuss, oh, this field has to be a thing, a pointer, or whatever. You need to ship things, right? And we want this feedback. We want the people to ship these things. And the other thing is, we have problems that we are not going to solve, like the VM or the keeper thing, but you is in your roadmap, right? So we want to solve these things. And what was clear from this discussion? And what is this? That we have two needs. One was a high-level API, right? That you don't need to play with. It's small, or I don't know if
it's fine.
Okay. So we need a high-level API that allows you to how the multi-network API started. I mean, it was clear the mechanics that we wanted to implement, right? I want this pod to reference a network, and I want to be able to schedule in some place, and I want the pod to create the network, right? But the problem is that it was very specific, right? It was leaking all the details. Okay, network rules, interface with all the things, right? And we want to, it's more Kubernetes Cloud Native to say, focus on the what, right? And not on the how, right? It's not the people to need to know about the network and all the things, right? And the low-level APIs, we need to break free of these shortcomings of CNI that I was saying, right? If you don't are the owner, or you need to attach multiple interfaces, you are with this multiplexing of mutus or whatever thing, but it's just plugging interfaces in a network namespace. It's not so complicated. Right? So for the high-level API, there was another people working on this. That was all the NVIDIA stuff. They have this problem with the hardware, right? And they took an approach that is kind of the device plugin. You're familiar with the kubelet device plugin? It's like a device plugin 2.0 with steroids. So, and the concept is really simple. You have a driver in the node that publishes the resources on the node. So you can say to the driver, okay, I have this network in can I don't know how to do the okay. This doesn't show the point. Yeah, it yes.
Hit L.
Okay. What?
Hit L.
L? Oh. Okay. Google stuff. Okay, so you can create this abstraction, right? We were saying is you can tell the user, oh, I have the network B or the VPC blue or the whatever thing, and you can add random attributes. So this is unstructured. That's why I was telling you, you don't need to play with CRD. For playing with CRD is really hard. You need to know all these API conventions, and you then need to implement all these weird things when people just need, I just need to pass something structured that I know how to interpret. I will deal with it. It's a configuration problem. I will deal with the configuration problem. So this is another key of this design is, first, what the things that is published is unstructured, right? It's the strings, number, and whatever thing. And these are the attributes that the, let me go to the second slide. This gets complicated here. So these are the attributes that the users are going to match on. So when you see the previous one is, this is what the driver published, okay? So the driver is going to publish whatever you want. This is an example. I say, okay, this has a VPC with a string blue, right? And encapsulation is an IP, whatever, right? And then this is what the user is going to request, right? Is I want to connect to network B, or I want to connect to one interface with driver, whatever, right? And well, this is much more complicated because it has resource claims, resource claims, but I want you to get is the resource claim thing is what the user is going to ask the system to provide. Is I want network B, I want interface 2, I want, I don't know, bots with the netkit only. You can implement whatever logic you want to do. The system is going to implement the scheduling for you. And the driver is the one publishing the sources, okay? And this is how we can solve the high-level APIs. You have a framework here that you just need to play with this data. And the other thing that is important that I wanted to share, one second, is that, let me share this tab. Did you see this? Nice. Control plus. Control, oh, this is Mac. Is counting. Okay. This is opaque. It means you put whatever you want there. You want to use CRDs, okay, you put a CRD, but this is just YAML format. And this is the config is a field for implementation to pass the config that they want. And this will get to the driver directly. And then this has also a different abstraction. There is this, okay, let me go back. There is this device class. So you can also implement a class that is global to the cluster and then use it as reference. So I don't know, example. There is people that are looking into this as, well, I have this kind of drivers that are everything is SRIOV, so I implement a device class that's SRIOV, and the claims require the SRIOV class, right? And the key here is you get the concepts and try to map to whatever you're using and see if it fits. If it doesn't fit, came with feedback, and we try to implement it well, right? And so you don't have to deal with implementing with CRD and operator all these complex logics, and we can absorb it here, and then you just focus on the business logic. Okay, and this is for the low-level API. Okay, that's the high-level API. For the low-level API, I don't know how many of you are familiar with NRI. Well, NRI is a plugin protocol. It's a protocol for plugins from container runtimes. It's implemented in CRI-O, implemented in container. What they took, they did the same evolution of CNI, but they realized that the problem of dropping binaries and not having a state, so they moved to a kind of gRPC model, right? So what you have with NRI is you can deploy a daemon set or whatever that connects to the container runtime, establish the gRPC connection, and then it gets hooks on the pod lifecycle. For networking, we are only interested in 3 hooks, right? It's RAM pod sample. This gets called after the CNI outcome. So this is the important thing here is everything has to be backward compatible so people can build on that and doesn't have to change any installation. So I added this last week. This pull request is when you create the pod so you can have another CNI or whatever thing, you are here in your daemon set that is already running, and this is going to receive all the pod information and the pod IPs. Okay. What is the other nice thing that these NRI plugins have is that when you connect to it, it gives you the system state. So it's not like CNI that is stale, right? So you are at the moment that the IP is created, you're lucky. If you restart whatever thing, you need to figure out what is running there. So this is not. It has also implemented the logic that when you connect, it's synchronized, it gives you all the pods and all the IPs. So you should look at this pull request because I have some example. This is solve the problem of I'm not the main CNI. I need to integrate with her. And it's also another problem. Imagine that your Cilium are growing and want to have some prototype or something, right? You don't even need to put this into the Cilium. You can create a Cilium driver for whatever thing, right? And run as a daemon set or as a side container or whatever thing. And this gives you more velocity for adding new features, just not having to wait to integrate everything into the main scene or to prototype it. Because you are running in parallel and you have the information that you need. You need the pod IP and the network namespace, right? And the C groups, right? With that, you have all the stuff. And that is planned directly through this hook. And then you have another 2 hooks that is stop pod samples and remove pod samples. That allows you to do the cleanup, right? And then I introduced NRI, and now is how NRI works with DRI and what is cool. So this is the benefit for NRI with DRI, but with DRI, you also have this hook here. So you have the what I call network DRI driver. It can be Cilium, can be whatever thing. Before the pod even starts to be created, you have the node prepared resources call. And this is when you are getting my point. You need to allocate security things. You do this. The pod is not even being created. You don't stop the pod startup at anything, right? And then when you get the RAM pod samples, you can hook here or you can hook there. But you already have the information that you already created, right? And I think that's so far is what we're doing. I have a demo, but it's too messy to see in the screen. It has just, I mean, it's super complicated. You have all these things. I don't find it useful. We can go through it.
So that basically means like Cilium would also like have to provide this DRA driver or.
This is the concept I'm creating, right?
Yeah.
What I'm saying is, we know that we cannot standardize. Standardizing an API and relying on implementation is never a good solution. What we want is just let's provide the framework so you don't have to re-implement most of the things. What are the things complicated with scheduling? I mean, if you want to implement multi-network with an API, you need to implement a scheduling plan. And then that's a work that you shouldn't be doing, right? That's a Kubernetes business. What is the other thing? CRD. I mean, Rob can explain horror histories about CRD. And just doing CRD, but like everybody, is the easy way, right? If you need to implement now versioning, upgrading, API review, whatever thing, you're going to spend all the time on that you don't need. You just need to buy something, and you own the platform. So you can say, okay, I'm going to break this config in this thing, and I'm going because I manage my life cycle of my component. So that's the thing that I wanted to produce here, and that I'm moving forward, and that's why I want all the feedback from all these communities and all the people to get on board. So we make Kubernetes better, and we allow the people to grow on the things that Kubernetes is not going to.
This containerd of pass, I mean, like now it doesn't need to query API server. Containerd pass all the information to the CNI about the resources that it needs to.
That's the question. we need to be more specific because we have talked today in the contributor summit, and I thought it was clear, and the people there have a misconception. What are the resources that you are saying that are you going to have?
So I'm saying like what the NIC raises, like if you want to use like secondary NICs, this is multi-NIC network support, right? Like if if the pod has like multi-NIC needs to be configured, it needs to now today like the container pod is only one interface name, right? Like the CNI and underscore if name, like will it get, does it need to query the API server to get like what are the NICs needs to be configured for that NIC for the pod, or does it get through the container itself, like all the information?
Okay,
the NRI provides that.
That's why we need to work on this. So the thing is, who is going to define it? You are going to say, oh, I want this pod to have network, right? That's okay. The example. Let me.
I'm going to say like some CRDs needs to be defined. Like say this pod, for example, the resource claim you were talking about represents two interfaces there, right?
Yeah, this example says.
Yeah.
Okay,
so
I want to connect to network, NCCL network to two NCCL networks. Okay.
So now the CNI has to provision like two interfaces inside the.
But that's the thing is remove CNI concept.
Okay.
Let's call network plugin or whatever because CNI is needed. Okay. Now you are telling to the system this pod is going to have two additional networks, right? Or two additional interfaces, right? The concept of network is something that we are providing on top, right? It's at the end the pod only knows about interfaces. Right? It's a network interface. It's not going to have anything. It's going to have routes, it's going to have IPs or whatever. But then what is going to happen is this pod is going to be a schedule based on this time, right? Okay, the schedule is going to look at the resource slices, it's going to look at the source claim. I'm going to choose, okay, this is the node that has this interface, right? Or these two interfaces. I'm going to schedule it. Then the pod lands in the queue, okay? And then the queuelet is going to call the plugin that exports this interface, right? Because the system knows there are two interfaces there, right? So the queuelet knows that this driver has two interfaces. So here, somebody is asking for these two interfaces that you're asking for, right? And then the driver is going to do some stuff here, right? And say, okay, I'm ready. Then the queuelet say, okay, I have everything ready to create the pod. I'm going to create the pod.
Like what is the driver doing in that case? It's like creating the interfaces to like for the pod, or
I think it's allocated.
It's up to you. I mean, it's I'm just describing the diagram. Everybody is implementing it differently, but I think that having the call before, because these use cases are coming from NVIDIA, right, and all the people, and then when they have the GPU, we have this today. Some people from NTT or everything are talking about the PGA, right? And the problem is that they need some time to provision this hardware.
Okay, I see.
So this cannot happen at one time.
Yeah.
So the hook here is thought about that. Right? I need to provide to provision something. Right? If it's a BS or whatever, you just check.
So that's the NRA to keep track. Like these are the NICs assigned to the pod, these pods. So this NIC is like not free now. Like it maintains a list of devices, right, for assigned to that node. And if these two devices, network devices assigned to this pod, then it keeps track, like keeps track some state saying like these devices are assigned to the node. These are the free devices available for that node.
Yeah, just this list.
Yeah.
So resources wise.
Yeah, when you call the prepare node resources at that time, like the NRI keeps that state, right? Like that's what NRI has to do. What Daniel was asking, like what is the significance of this prepare resources call?
No, the prepare resources is for that. Imagine that the thing that you are asking requires to configure something like FPGA or whatever, right? And then you need to provision some hardware that maybe, or SRIOB or whatever thing. That's an area I'm not familiar, so correct me if I'm wrong. But it's some process, some heavy process that you need to do. That's unrelated to giving IPs or whatever. So this is this hook. Is you want to provision this hardware before you enter in the critical path of creating the pod. I don't know if this is solving your question. Okay. So then imagine that you want an interface, a Mellanox NIC, whatever, that need to load some firmware X, right? So this is the step where you load the firmware and you reset and you.
So I think maybe rephrase the question. Why is it bad to put that initialization after run pod sandbox?
Because this is not part of the, this is not part of, this is container, this is not Kubernetes.
I guess
So-
it gives you an opportunity to set stuff up that you need in place before you create the namespaces.
I think it was like something related to error handling.
Two?
Error handling.